will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Welcome to this course. My name is Maximilian Schwarzmuller. I'm your instructor in this course, and in this course, I will get you started with end-to-end testing and Cypress. Cypress is a very popular and indeed amazing tool and framework that really makes creating and writing and working on end-to-end tests a breeze. For example, because it gives you an amazing app that makes it really easy to see what your tests are doing and why, for example, they might be failing. Now in this course, you will learn all about end-to-end testing and Cypress from the ground up. No prior knowledge is required. You just need basic web development and JavaScript knowledge. You will learn all about the core concepts and of course also about some key advanced concepts and best practices. You'll see many examples and demos, and with that, I'd say let's not waste any more time. Let's dive right in, and let's get started with the most important question. What exactly is Cypress, and what's end-to-end testing, and why should you care? So what is Cypress? Cypress is a JavaScript-based test automation tool and framework for web developers. You can use Cypress to write automated tests for the website you're currently working on. Now you can use Cypress for automated testing in two main ways. You can use it to write so-called end-to-end tests, and you can also use it to write so-called component tests, though this course here will be about end-to-end tests. Now, the idea behind end-to-end tests is that you have automated tests that test entire application flows. For example, the user authentication flow, where a user enters data into some input fields, hits the enter key, and then is logged in. You might want to test whether this entire flow works correctly, and you could write an end-to-end test with help of Cypress to do just that. And indeed, this exact flow will be one of the many examples we will take a look at throughout this course. Now, component tests are about testing individual UI elements, individual UI building blocks. For example, you could test if a modal overlay component works and looks correctly. You can write these kinds of tests with Cypress as well, though this course will be about Cypress for end-to-end testing, not for component tests. Nonetheless, what you learn in this course will also help you if you then decide to also take a look at component tests thereafter. End-to-end testing is all about testing these complete flows. That could be such a user authentication flow. It could also be that you want to test whether to-do items are added correctly to your to-do list. So you want to test those entire application flows. And understanding the idea behind end-to-end tests is crucial because you might also know another form of automated tests, and that would be unit tests or unit testing. I do also have a course on unit testing because that is also another important form of testing, but it's crucial to understand the differences between these two approaches and when to use which approach. It's important to understand that these two approaches are both important and are not really alternatives to each other, but instead should best be used in conjunction. The idea behind unit testing, as you also learn in my dedicated unit testing course if you want to, is that you test small individual building blocks of an application. For example, whether a given function works as intended. The idea, however, is that you don't test the combination of components or functions, so that you don't test entire flows, but that you test the individual building blocks instead, and you therefore can ensure the correct functionality of those individual units. However, of course, with unit tests alone, you can't ensure that those units work correctly once they're being combined. So unit tests don't guarantee the functionality of the overall system. And therefore, that's where end-to-end testing comes into play. Unit testing is important to test your individual building blocks and find errors early when those blocks break. But you then also have end-to-end testing to test those complete application workflows, as mentioned, like that login flow. And therefore, with end-to-end testing, you can ensure the overall functionality of the entire app or of those key application processes and workflows. With end-to-end testing, you're not necessarily covering all possible combinations of those different units, but you of course try to cover the most important workflows and features of your application. And combined with unit testing, you hopefully achieve a state of automated testing in a given project that allows you to cover all major building blocks and flows and catch errors and bugs early. So now that we know what Cypress is and why we might want to use it, it's time to get started with it and write some first tests and add it to our first project. For that, you can visit cypress.io, and on that website, you find some getting started instructions. But in the end, it's just one simple command that you need to execute in your project, followed by another command. So here I am in a brand new project, and you find that project attached to this lecture. It's a React.js project, but you don't need to know or understand React.js for this course. It's just a demo, and we're not going to write any React.js code here. Just download the attached project, and once you did so, open it in your favorite editor. Here I'm using Visual Studio Code. And once you're there, you need to install some dependencies. Here I'm doing this with the built-in terminal that's built into Visual Studio Code so that I can run a command directly in that project folder. And the command we have to run is npm install to install our extra third-party dependencies of that project. Once that's done, we're ready to run this project and also then install Cypress. Now, if we quickly run this project, which you can do with npm run dev, you can visit it on this site here on your local system. You should see this website in your browser. As a side note, here I zoomed in quite a bit to make this a bit easier to see. That's why it might not be that big, that zoomed in by default on your system. So that's the basic starting project I created for you. And it's this starting project which we're going to use to install Cypress and write our first test. Of course, throughout this course, we'll see more demo project and also more advanced scenarios. So in order to install Cypress, we head back to this terminal where we ran this development server before. And there we want to execute this npm install Cypress command, which we also find on the official Cypress website. Now this installs this Cypress tool into this project. And once this was installed, once this Cypress dependency was added, we can run npx, not npm, but npx Cypress open. And this command will now use that dependency which we just installed and open the Cypress application on this system. After running npx Cypress open, you should get a window that looks something like this. And what you're seeing here is the Cypress application, a tool created by the Cypress developers, which we can use to manage and run our tests thereafter. Now, when we're starting this tool, we have to decide whether we're going to write and run some end-to-end tests or component tests, though you can also have both types of tests in the same project. Now, this course is about end-to-end testing, so that's what we're going to pick. And as you see, it's currently not configured, since this is the first time I'm running this command in this new project. So when we click this, we now get this initial configuration step, automatically managed by Cypress. And here in the end, Cypress in the end just tells us which extra files have been added to this project. For example, a cypress.config.js file, which could be used for configuring the testing behavior of Cypress in this project. Here we just confirm this by clicking continue. And then we can choose in which browser we want to run our tests. Because Cypress actually supports different browsers. If you have Firefox installed, you should see Firefox as an option here as well. But I'll use Chrome here throughout this entire course. And therefore now if you click Start E2E Testing here, a new browser window should open with that Cypress application running inside of it. This is still an extra application provided by the Cypress team, which we will use to then run and evaluate our tests. Now, since this is the first time this is starting and we haven't written any tests yet, it asks us whether it should create some example tests, which we could use to learn Cypress and see some, well, examples in action, or if we want to create one single, basically empty testing file, which we can then use to write our own tests. Now, seeing these examples can be very useful for exploring some Cypress commands and learning Cypress. But since you have this course for learning it already, we will actually use this empty spec file here, this empty file, and write a test from scratch. We can then give this a name, and here I'll just name it first test. You should keep the .ci.js extension, and you should also keep the folder, which it's suggesting here. I just changed the file name, or the part in front of the extension, to first-test. With that, we can create this spec file with this dummy content and click OK, run the spec. And with that, what Cypress does thereafter is it executes this testing file. And from this point on, when this application is running, as you add new testing files, Cypress will run them for you, you can rerun them, and when you reopen this application after you closed it, and you can close it like any other regular browser window, so after you closed it, if you rerun it, Cypress will run all the testing files it finds in your project again. And keep in mind, you can always reopen it by rerunning this npx cypress open command. So that's how we install and run this Cypress tool. Of course, we're going to take a closer look at this tool and what we can do in there throughout this course. But with that out of the way and this up and running, let's now write some Cypress testing code. So we installed Cypress, we started this Cypress application, and it should still be up and running at this point. This process, which was started with npx cypress open, should still be up and running. You should have this running process in your terminal here. And you should now have some files that have been added. Now, we'll take a closer look at these files throughout the course when we need them. At the moment, it's just important to recognize that we have this Cypress folder. And in there, this E2E folder contains the actual testing files, which we'll work on. And you can add more test files here, and you can write your tests in those test files. What's important is that those files end with .ci.js, because that will tell Cypress that it should pick up those files, look into them, and run those tests it finds inside of them. So this extension matters. So it's this first-test.ci.js file, which we created in the previous lecture. And in there, we find one example test suite with one example test. This describe function, which is provided by Cypress, is used to create a test suite, which is simply a collection of tests. And then this it function, which is also provided by Cypress, creates a single test. So here we have one test in one test suite. You can, of course, add multiple suites and also multiple tests if you want to. Now here, this is just a dummy test, but every test you create with this it function has a description, a name, so to say, which is totally up to you, and then a function as a second argument, which contains the actual testing code. And it's inside of this function here where you then use these various Cypress commands to tell Cypress in detail which steps it should take on your website to test a certain behavior. Here it just visits an example page, and therefore this test at the moment always succeeds because this page is visited successfully. But again, we'll learn more about these different commands and how to combine them and what you can do with them throughout this course. Now here for this course and for this first test that we're writing ourselves, we of course don't want to visit this dummy site here, but instead we want to visit this site here, which runs our local React application. Therefore, I'll copy this URL and paste this here into this visit command. Now, the visit command is executed on this CI object, which is, as you might guess, provided by Cypress, and it in the end instructs Cypress to visit a given URL. In this case, this local URL, which will work because Cypress also runs locally on our machine. So visiting local sites will be no problem. So with that, we changed this step to make a bit more sense for our application. If we save this and we go back, we see that this test failed though. We see that it failed because it failed to load this site, and in the end it failed because the connection was refused. And this happened because our local development server that hosts this site is actually not running anymore. At least I stopped it here on my system. If I try to reload this page in the browser, this website page, I also fail here. I stopped this development server when I started the Cypress app, and therefore in order to make sure that Cypress is able to visit this, we have to restart this development server, this React application server. Of course, I don't want to stop the npx Cypress open process though, because this Cypress application here also should keep up and running. And therefore what I'll do is I'll open a second terminal window, and in there I run npm run dev to restart this React application development server. And with that up and running, we can successfully reload and visit this page. And we can now also go back to the Cypress application, rerun all our tests with this icon up here. And now you see that this test passed. And we actually even get a screenshot here that shows us what Cypress saw, so to say. And this test passes because the only step we have in this test at the moment is that we want to visit this page. And therefore, if that succeeds and Cypress is able to visit that page, the test is marked as successful. Now, in many cases, you don't just want to visit a page, you want to do things on that page, or you want to validate that certain elements are visible on the page. So you might want to write more complex tests, and we're of course going to do that throughout the course. But this is a first basic test that shows us how we can generally get started with Cypress. So now that we get this first basic succeeding test, let's make it a bit more meaningful and useful. Just visiting the page is not enough. Instead, here for this dummy demo application, this very simple first website here, we might want to ensure that this page is not just loaded successfully, but that we can actually see those 6 course goals. Or we might not care about the exact goal texts that we see, but we might care about the fact that we see 6 course goals. We might want to ensure that this page is loaded correctly and displays exactly 6 course goals. And that would be a very common expectation you want to check with help of Cypress, that certain elements are visible or that a certain amount of elements are visible. Things like that, as you will see throughout this course. To add this extra check to our test here, we can use the CI object. And on this object, we can now call the get function. This is another built-in function, another built-in command provided by Cypress, just like the visit command. We can use this command to search for certain DOM elements on a page that was loaded with help of visit. So we first visit a page, and then in a second step, we search for a certain element. Here in this example, if we use the developer tools to inspect this rendered DOM, we can see that in the end, these course goals are list items inside of such an unordered list in the main element. And indeed here for this simple page, these are the only list items we have on the entire page. So what we can do to find those list items is we can pass a CSS selector to the get function, so a string that contains a CSS selector, and just search for the li tag. Now, for more complex websites, this might not do, because you might have different li elements in different areas of the page, but for this first basic example here, this is good enough. And this will find us all these list items we have on the page, so in this case, all these 6 course goals. And that's also important. Get does not stop at the first element it finds. Instead here, if it finds multiple elements, it gives us multiple elements. We can then chain another command here by adding another dot after that, and then use the should function to formulate an expectation. And then to should, you pass a string, and in there you can, for example, write half.length, and then separate by a comma, Specify the length. Now, this is one of the many possible expectations you can formulate, and throughout the course you will learn where to find all possible expectations and where to find other commands like get and should. But for the moment, that's what we want to write here. This will check that we have 6 list items so that we get a list of list items here that has a length of 6. That's what we're writing here. And if you then save this, the tests will automatically rerun, but you can also rerun them manually by clicking this button. And once you do that, you see the test still passes because it gets those list items. If you hover over get li, you even see what was selected by Cypress, which is very useful. And of course, that were 6 items, so this expectation was met and the test passed. Now, that's the quick start. Of course, we're going to learn more about these commands, how to combine them, where to find all these possible expectations. But that's how you can get started with Cypress and how you can write the first Cypress test. And with that, it's of course time to dive deeper. So now before we dive into Cypress and start using it, I want to explain what you can expect from this course and how you can make sure that you get the most out of this course. This is a getting started course, which means you need no prior Cypress knowledge. You should have some prior web development knowledge though, because Cypress is a tool that's used for testing web applications, and you should know how to generally build such web applications. Otherwise, this course will definitely be very challenging to follow along and to understand. Now, since this is a getting started course, in this course, we'll start from scratch when it comes to Cypress, and we'll explore all core Cypress concepts at concrete examples. Now, these core concepts include not just the basics, but also some advanced concepts. All that being said, though, we'll not dive into niche scenarios, we'll not dive into running Cypress in the cloud or into CI/CD integration or anything like that, but instead we'll focus on the core Cypress features and how to write Cypress tests. And for that, we're going to explore common problems and solutions along the way. By the end of the course, you will therefore have a solid understanding of the core Cypress concepts, and you will have a solid Cypress foundation, and you'll be ready to dive deeper into Cypress and start applying Cypress to your own projects. Now, my goal with this course is to make sure that you get as much out of this course as possible. That, of course, starts with the videos. It's a video-based course, a video-on-demand course to be precise, and therefore, of course, you should watch these videos, but watch them at your pace. Use the video player controls to slow me down if I'm going too fast or speed me up if I'm going too slow. You can, of course, also skip entire videos if I'm covering a certain concept you already know, but generally, you should watch the videos in the order in which they are presented to you to get the most out of this course. Since it is an on-demand course, you can also repeat videos whenever you need to, and you should definitely use this feature because it's totally normal that you maybe forgot about a certain concept, that maybe one video wasn't super clear to you when you watched it the first time and you therefore want to watch it a second time. So definitely take advantage of this on-demand nature of this course. Now, in this course, I'll show you many examples, and you will get more out of this course if you also code along, if you try things on your own, if you follow along in code whilst watching the videos. For that, of course, you should also pause the videos from time to time to try things on your own. I won't prompt you to do that in this course, at least not too often, but you should do it nonetheless. Practice whilst watching these videos. Don't wait for me to tell you that you should do it. Instead, pause the video, try the next step on your own, write some tests that we're not writing in the videos, and practice what you learned. Of course, also in your own projects. So in your own dummy or demo projects you might be working on. In the next lecture, you also find a link to all the slides that come with this course and also to various code snapshots that you can use to take a look at when getting stuck when following along with the course examples. I do have various code snapshots in that next lecture that you can use to compare your code to mine and potentially find out why a certain test is working for me in the video, but not for you locally on your system. And last but not least, of course, you should also help each other. We have the Q&A section where you can ask and answer, and where I, of course, also try to help you, but you should also help each other, because by answering the questions of fellow students, you will learn even more, because you're forced to think about a problem and come up with a solution. And even if your solution is wrong, well, someone will correct you and you'll learn even more. So definitely take this as an opportunity. But don't just use the Q&A section for that. Also consider joining our amazing Discord community, to which you'll also find a link in the next lecture, which is a great place to meet fellow developers, discuss anything related to development, and also totally not related to development if you want to, and use this community to grow together with us. So now that we got started with Cypress and this course, it's time to dive into all the important Cypress fundamentals and basics you must know in order to work with it. In this course section, you're going to learn how you can find elements on a page, and of course, we're going to take a look at different possible approaches and also at more complex element queries. But since you typically don't just want to find elements, but in many tests you also need to manipulate or interact with elements, you will also learn how to do that with Cypress, how you can simulate user interaction. And last but not least, in many cases, you of course also have certain expectations that should be met when going through certain application flows. You might have a minimum amount of elements that should be visible on the screen. Maybe a modal should have opened. There are a lot of different expectations that you might have. And therefore, in this section, we'll also take another look at assertions, at expectations you can formulate, how to do that with Cypress, and how to evaluate your test runs. Now, for this course section, I prepared a brand new starting project, which you find attached. It is again a React project, but again, you don't need any React knowledge. And after you downloaded this project, you should navigate into it in your terminal, or use the built-in terminal here in Visual Studio Code, and run npm install to install all the project dependencies. And once you did that, you may also run npm run dev to start this development server again. And this server will need to be up and running when later running your tests, so that your tests can find that server. But you can also run it right now already and take a look at this site. And you should see a site that looks like this. Again, I'm zoomed in quite a bit here, which is why this is rather big. But you should have this very basic task management app here, which doesn't have any tasks initially, but where you can add tasks, give them a title and a summary, assign a category to every task, and then view your tasks in a list here. And we're going to take this basic app here to dive a bit deeper into Cypress, into its base syntax, its base features, and we'll explore in greater detail how you may select elements, interact with this website, and evaluate your results, all in an automated way by using Cypress. Now, for that, of course, it's not just enough to have this project and have this development server up and running, but instead we also need to add Cypress to this project. And therefore here, I will actually quit this running development server and install Cypress by running npm install Cypress to install this tool into this project again. And once that was done, I will restart the development server because, of course, as mentioned before, this must be up and running for Cypress tests to work and to find this server. But with that up and running, I'll open a second terminal and there run the good old npx cypress open command again to open this Cypress app, which will then later run these tests and which will allow us to evaluate these test runs. Now, when running this, you again get this window, which you know from the first course section, where we will select E2E testing, because this is an E2E testing course. Click continue here, and I will continue in Chrome. And this then opens this new browser page that runs the Cypress Studio. so this Cypress application, where we later can view our test runs and so on. And here I'll again start by creating a new spec file, which I'll just name basics.ci.js. Create that file like this. And with that, we got our new spec file, which we can run from inside this Cypress app here. And we can view this file here in our project if we go to the Cypress folder and there the E2E folder. Again, there are more folders and files, which we'll take a look at later in the course. For the moment, we'll focus on this basics.ci.js file and we'll dive a bit deeper into Cypress and its core syntax. So here I'm in this basics.ci.js file, which we created in the previous lecture. As mentioned earlier in the course, it is important that this file ends with .ci.js so that the Cypress app, which we're running here, successfully picks up that test file and runs it. So this extension is important. And in that file, we start with one test suite created with the describe function, and in that suite, one test created with the it function. Now, these suites and tests actually receive names or descriptions here, and at the moment it just says templates back and passes. Now, you want to give these suites and tests more meaningful names. And a suite, by the way, is simply a collection of tests that are kind of related. For example, here we might want to create a couple of tests that are related to the overall page, so whether that page is displayed correctly and has the correct content. Therefore, I'll name this tasks page, this suite, and then in this suite we put all our tests that are related to the tasks page. And if we had a second page, we would probably create a separate suite, most likely in a separate file for that page. Here we have this one file with this one suite, and in there this first test maybe simply wants to check whether the page loads correctly and displays an image here, something like this. And therefore we could give this test a name or description that says should render the main image, if that is what we want to check. If we want to check whether the page is displayed correctly and has this main image. And please note how this reads like a sentence here. I'm saying it should render the main image. This is not a must do, but this is. Now, of course, we already used visit in the previous course section already, and there we also used the get command in a second step after visiting a page to get certain page elements and, for example, see whether they are part of the page or if we have enough list items, which was the test we ran in the first course section. Now, when you type here, you might or might not get auto-completion. And here I'm not getting it. And you should definitely make sure that you do get auto-completion when using Cypress, because writing your commands, using them correctly, and adding expectations is much easier if the IDE helps you. Now, if you're not getting auto-completion, as it's the case for me here, you can add one simple line at the top of your testing file to ensure that you do get auto-completion again. Add 3 forward slashes, not 2, but 3, that's important. And then this angle bracket, so the smaller than sign, followed by reference, and then types equals Cypress, Cypress with a capital C between double quotes, and then this closing tag here, so to say, forward slash and then greater than sign. And with that, you should get auto-completion. Now, if you type CY, this should be understood by VS Code, and if you add a dot, you get this auto-completion with. Now here, for this test, I want to make sure that we have this main image on the page. So this image. To make sure that our test tests that, we should add an instruction to the test that searches for this image, and then basically makes sure that the test fails if the image is not found. Now, how do we search for the image? Well, get is a good start because get is the Cypress command we use for finding elements on the page. And to do that for us, get takes a parameter, an argument, which is actually a string, so some text, and in that string you put any CSS selector of your choice. You can, for example, select by tag, using the image tag here, for example, to find all images on the page. And that's important, by the way. This will not end at the first image it finds. This does not work like document query selector, which would stop at the first image it finds. Instead, this will find all images on the page. And therefore, often you don't just want to look for elements by tag, but maybe by class name, by starting with a dot here, using the default CSS class name selector, or look for some ID with the hash symbol at the beginning, or by attribute, like type equals text to look for text inputs like this with square brackets. And again, these are all just standard CSS selectors. Now here to find this image, we can again use the browser developer tools to take a look at the DOM. And we could of course use the image tag selector, because in this case, this is the only image on the screen. But we could also make this a bit safer to make sure that we don't accidentally grab multiple images, if there would be more than one image on the page later maybe, by making this selector more specific. Now, for example, here I know that it's in my header, which has a CSS class of main header. And therefore we could select this image in this header by refining this CSS selector we passed to get by using the CSS class selector main header to select an element that has this CSS class on it, which in this case would be this header. And then we want to select the image in there, and therefore again we can use a default CSS selector for that, add a white space here, and then image. And this will now select all images that are inside of elements that have the main header CSS class. And in this case, there will only be one such element with main header on it. So that should therefore select this one image we have on the screen in the header. And if we now save this, our test ran again, and it actually succeeded because it successfully found that image. And just as mentioned in the previous section already, if you hover over those different steps, you also see on the right what Cypress saw, so to say. And it also selects the elements here on the right that were selected by that command. So here this get command selects this one image, and therefore it's highlighted in blue on the right side in this preview here, so to say. And that's one of the many awesome features offered by Cypress, that you can see those different states of the website here on the right for the different steps that make up your test. Okay, so at this point we basically repeated what we already saw in the first course section. Now let's add something new. Let's add a second test here by using the it function, and then giving it a meaningful name or description. And here in that second test, I want to make sure that I'm actually checking for my website having a title that says My Cypress Course Tasks. So therefore here I'll give this test a name or description of it should display the page title. I don't include the page title in the test name, but I make it clear that this test will test for the page title. So that's the test description. The second argument for the it function then is an anonymous function, typically an arrow function. And here inside of this arrow function, we then write our test code. Now I will start by again visiting this page. That's crucial. We must visit this page before we can start to look for elements. And then I want to make sure that I have the expected page title. Now to do that, we could of course look for this title element, for this h1 element here, and make sure that it's on the page. So we can again use cyget just as before, and then here look for the h1 element. And since we should have only one h1 element on the page, this selector should actually be specific enough and should not accidentally yield multiple h1 elements. And even if it would, that probably wouldn't be a problem, because we just want to make sure that there is at least one h1 element. However, here I don't just care about the existence of this h1 element, but I also care about the content. To be precise, I want to make sure that it contains the correct text. And we can make sure that it does by adding another command thereafter, so by chaining another command or another query, as it's called to be precise. And in this case, that would be the contains query. And contains allows us to look for a certain text. And if here we want to make sure that this title contains the text my Cypress course tasks, we would simply write it like this. As a side note, we could have also just written cy.contains this text like this and skip the get h1 part if we don't care about the element in which the text is stored. If we write it like this, then this test will only succeed if this text exists inside of the h1 element. If we write it like this instead, this second option, then this test will succeed if this text is found anywhere on the page, no matter if it's inside of the h1 element or not. In this case though, the test will fail, as you will see. It tries it for a couple of seconds, but then it will fail, because indeed here this h1 element doesn't say my Cypress course tasks. Instead it says React tasks. So looks like we caught our first bug, or maybe a change that was unintended. So time to fix it. And for that, I'll just quickly dive into the source folder, and then there under components into the header JSX file. And here we can fix this title and replace React in this h1 element with my Cypress course, so that it says my Cypress course tasks. If we now save this, we can close the source folder and close this file. Our tests should rerun. Alternatively, we can rerun our tests by clicking this button up here. And now both tests succeed again. And for this second test, we see that it successfully found the text inside of the h1 element and also in general on the overall page. Of course, for this example, we don't need both these checks. One of the two approaches is enough. I just wanted to show you that contains can both be chained after other commands, after the get command specifically, or be used right on the CY object like this. So we worked on our second test here, and there's one important thing to understand about this test. It doesn't have any explicit expectation that would be part of this test. It does have a couple of implicit expectations, like that we visit this page successfully, that we have a h1 element, and that this element has this text, and that ensures that the test either fails or succeeds. But we don't have an explicit expectation as we did have it in the first course section, where we checked for a specific amount of list items. And that is a big advantage of Cypress. Many queries, many commands which you use, like contains or get or visit, have these implicit expectations. So even without adding your own expectation, without adding an expectation like should exist here or anything like this test fails or succeeds depending on whether these elements are found on the screen. And this makes your tests easier to write since you have less code to write, since not every expectation must be written by you. But of course you can add explicit expectations if they are needed. For example, here, as part of this page title test, we might want to make sure that we have this one main title, this one h1 element with this text, but at the same time, there shouldn't be more than one h1 element. There should be exactly one h1 element, not more, not less. To do this, we could add another query here by using cy dot. As you can tell by now, you pretty much always start with this globally available cy object. And on this object, we can call get again. And then to get, we pass our h1 selector again to select all h1 elements, because as mentioned before, that is what get does. By default, it finds you all the fitting elements. It does not stop at the first fitting element. And then here, to make sure that this is only one element, we do have to add an explicit expectation. And that's done by chaining another command here, and that would be the should command. Should is another command built into Cypress, and it's used to add an expectation. Here, an expectation related to our selected h1 elements. Now to then define that expectation, you pass a string to should, and then there is a broad range of possible values you can pass in here. And that's another aspect where autocompletion is very helpful, because with that you have all these possible expectations here. And there are a lot. This can look overwhelming, but of course, as so often in development, you often work with the same set of 5 or 10 expectations, and there are some expectations in here, some assertions as this is also called, that you will almost never use. In addition, the advantage is that these things also read like proper sentences. So here, if you want to check that we only have one h1 element, we could, for example, write that this potential list of h1 elements should have length, and then as a second argument to this should function, pass the specific length we want this list of h1 elements to have, in this case 1, so that we have exactly one h1 element on the page, not more, not less. Now what you pass as a second argument to should, and if such a second argument here is needed at all, depends on your expectation. If you, for example, have exist here, then you can't pass a second argument to should, because exist doesn't need any extra configuration. But for have length, we of course need to define that length. That's why here we need that second argument. Now attached to this lecture, you find a link to the official documentation where you find a list of all these supported assertions, so all these supported expectations you can formulate, and on that page you also have a list of common assertions where you find those most important assertions you will probably use a lot. Here, for example, you find this have length assertion, which we used a couple of seconds ago, but you also find a couple of other key assertions, and of course you'll also see many crucial assertions throughout this course. Nonetheless, this can be a great backup page to learn more about these assertions, see different examples, and be less intimidated by the vast amount of available assertions. With that added, however, if we save everything and we rerun all our tests, this test should again succeed because we have only one h1 element on the page. But if we were to add a second one by again diving into source and then into the app.jsx file, and by adding an h1 element here in the main section where we say another title, if we add this, save this file, and then rerun our tests, now this second test will fail after a couple of seconds, because now this assertion didn't succeed, because now it found two h1 elements when only expecting one. Here, of course, that's not what I want, so I will delete this extra title from app.jsx, save the file thereafter, close it, and then rerun my tests, and this time they both succeed again. So now that we got started with selecting elements and we played around with these various commands and queries a bit, it's important to be aware of one common gotcha related to selecting elements. One mistake that's quite easy to make and that can cause your tests to succeed in cases where they shouldn't. And this mistake that's often made is that you might want to select a nested element, like here, this image, which is nested inside of an element with the main header CSS class. And instead of writing it like this with this nested CSS selector, which is totally fine and actually the way you should typically write it, but instead of writing it like this, you decide to split this across two chained get calls, like this. So now we first get the element with the main header ID, and then we get the image element in there, right? If we save this, the tests both succeed and everything seems to work. But this is actually not correct. See what happens if I move to my source code, to my header.jsx file, and there I actually take this image, cut it from there, so I remove it from this header file and save this header file, and I then add it in app.jsx into this main section. So it's in a different place in the DOM. We actually also have to go back to the header and also copy this import, this logo import here, and bring that to app.jsx as well. And here you then actually have to remove one of these dots at the beginning. If you do these things, copy and adjust the import and move the image from the header to the main element here in the app component, you will notice that if you save all these files, the website still works but looks wrong. Nonetheless, if you go back to your tests and you rerun all your tests, they still both work. And that's of course a problem. The page is broken and our tests don't catch this. Indeed, for this first test here, it does successfully find the image. Even though it's not in the main header anymore, but it doesn't look like that's a problem for this test. This isn't a problem for this test here, because get does not work the way you might think it works. If you chain get after another get, it will not look for this element inside of that first element, instead it starts at the top of the page again. So chaining get after get like this is exactly the same as starting from scratch again like that. It simply looks for any images on the entire page, not inside of main header. So using get like this does not work the way you might think it works. And that's, by the way, different for contains. If you chain contains after get, as we're doing it here in line 12, that does look for this text inside of this element. But for get after get, that's not how it works. If you do want to split your selectors into two steps like this, instead of simply adding image here as we had it before, you have to use another query instead, and that would be the find query. Find sounds very similar to get, but it works in a different way. Find indeed finds all elements with that selector inside of all the elements that were found by get here. So in this case, find will look for all images inside of all elements with the main header class. And therefore now with this, if we save that and we rerun the tests, now the first test does indeed fail because now it does not find the image inside of an element with the main header class. And that's a common gotcha and really important to understand and keep in mind. Chaining get after get does not look for nested elements. Instead, it always starts at the top. You have to use find if you want to look inside of other elements. Alternatively, you can of course use the approach we had before and simply use a nested CSS selector like this. This also works. But if you want to split it into multiple steps, use find instead of get for the second step. You can't use find for the first step, by the way. If you try to do that, it will fail because find can only be used after you had a get. Okay, so at this point we selected a lot of elements and we talked a lot about selecting elements. But to be honest, when writing end-to-end tests, selecting elements is one of the key things you'll be doing, because how do you determine that a page works the way it should? Well, a crucial part of that is to find out whether it contains the elements you expect it to contain. That's why being able to select elements and being able to do that correctly is crucial. But of course, there's another important thing you typically wanna do on a page to determine whether it works correctly. And that would be user interaction. You typically also want to simulate user interaction. For example, on this page here, it's good that we know that the image is there and that we have the correct title. But of course, we want to make sure that when a user clicks add task and then adds a task with some text and some category, that, for example, after this task was added, it's showing up here. You also might want to check that an empty task can't be added, and instead we get this error message if a user tries to do that. You also might want to test whether the modal can be closed by clicking on the backdrop or the cancel button here, or you want to test whether this filter works correctly. So these would be more things you do want to test typically. And of course, all these things are not just about select. Now let's start with a basic test. I want to test whether this application allows us to click this Add Task button, and then if it opens this modal, which can then be closed by clicking on the backdrop or on this cancel button. That's the first application flow I want to test that includes user interaction. Now for that, we want to add a new test, and here I'll actually add it in a new file. You don't have to do that. You can use the same file. You can add a second suite to that file and add the new test in that suite, or add it to this existing suite here. But here, to keep my files organized and to make sure that they're not getting too crowded, especially here for the purpose of recording this video, I will add a new file and I'll name it tasks.cy.js. And my idea here simply is that this was a file, this basics file was a file that got us started with some basic checks for this task page. Now I want to add some tests that are related to this task management here. Hence this new file, tasks.cy.js. As you learned, the file extension matters, and it should be in this E2E folder, in the Cypress folder. And then in there, we start by adding a new suite by using the describe function, which is made globally available by Cypress. And here I'll give the suite a name of tasks management. And then the second argument is a function, an anonymous function that contains our individual tests. And as mentioned before, those tests are added by using the it function. And now the first test is the test I just described, where I want to check whether we can open and close that modal. So I'll just say it should open and close the new task modal. That sounds like a fitting description. Second argument then is this function into which we put our test code. And now with that new test function defined here, let's add some code. I'll start with the CY object again, because as mentioned, this is the core object you use for all your test steps. And here I get auto-completion. If you're not getting it, copy this reference annotation here and add it to the top again. And then here we'll start by visiting our page again. That is always the crucial first step here. So I'll in the end just copy this visit command and use it here. Now once we visited this page, I want to make sure that this add task button is clicked. Now to do that, we first of all need to select this element. So here we are again, selecting elements. I mentioned that this would be important. Now to select this element, we could use cyget button to select all buttons on the page, and at the moment we should only have one button, and this would be this add task button. This here is a select element, a drop down, and there are no other buttons here. Still, this might not be perfect and we could look for a better selector. For the moment it will do, but I'll still show you an alternative. I will use contains. And as you learned before, we can use contains to look for text. Now what I haven't mentioned before is that contains then will actually also yield the elements that contain that text. So here if I look for add task for this text, I find this button. And that's another way of selecting this button. Of course, selecting the button like this means that this test will fail if we ever change the button caption. If in our code we would change the button caption to add new task, selecting it like this would fail. But for the moment, I got no plans of changing that button caption, hence this selector should work. Well, and with that we got access to the button. Now we want to click it. And this can be done by chaining another command here, and that command is conveniently called click. And this simulates a button click. It's as easy as that. This is how we can simulate a click on this button. Now if we save that for the moment and we go back to our Cypress Studio and we reload everything, we see that we're still in basic CY.js here. To see our new file, we should go to specs here on the left. And there we now have tasks.cy.js. And if we click on that, we now see the tests in that file. So here we then have the tasks management suite, and in there this one test which we just added, which should open and close the modal. And here we got the different steps, and again we can hover over them to see how we visit this page, how then we select this add task button, as you can see on the right, and how we then click it. And here you even see that we get two preview snapshots on the right, one where we see the button right before we click it or when we click it, and then one where we see the modal that opened. If I hover away from that, we see the final state of the page after this test finished, and here this final state simply shows us the opened modal. Of course, here with our test though, we also want to check that the modal is closed correctly, and therefore we also need a way of simulating that. Now to simulate that, we got two ways. We can click the cancel button or the backdrop. Now this backdrop, if we inspect it, can be identified by the backdrop class selector. The cancel button could be identified by its text, cancel. So therefore here, I'll start by getting my backdrop here, by using this CSS class selector, looking for the backdrop class and clicking that. And that should then close the modal. If I now save this again, this runs again and fails. Now here this click fails because Cypress reports that the text area is in front of the backdrop. And this of course is correct if you click in the middle of the screen, which Cypress does try by default. When you tell it to click an item, it by default picks the center of that item. And the center of the backdrop is indeed behind the modal and behind the text area in that modal. Now in the next course section, I'll get back to actions and dive a bit deeper into selecting elements and actions and show you how you could change the coordinates which Cypress chooses for simulating a click. Now, one easy way of overriding this here though, and of fixing this problem, is to go back to this click method and add a configuration object to it. And in this configuration object, you can set force to true to, well, force Cypress to make that click even if it thinks that something is in front of the element it wants to click. It's worth noting though that this click failing by default is a useful behavior because in the end that shows us that Cypress really wants to simulate this website and this website flow which we're trying to rebuild here in a realistic way. It tries to find out whether some element is clickable by a human user and warns you if it thinks that this is not the case, like here with the center of the backdrop which is hidden behind the modal. Of course, we know that here this won't be a problem because a human user would just click on the backdrop outside of the modal, and that's in the end exactly what we're simulating now by forcing Cypress to click that backdrop. So with that added, if we save this test succeeds again, and we see that now at the end of the test, the modal is gone. However, if you think about it, this isn't really a good test.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
So this test now succeeds again, but it's actually not really a good test. It succeeds, but it also succeeded before we added this last line here. If I comment out that line and rerun my tests, it still succeeds, because there's nothing there that would cause the test to fail. However, we want to test that we open and close the task modal, and at the moment, as you can tell, it succeeds even if the modal is not closed. On the other hand here, if I comment in this last line again, and I then go to my source code, and there in app.jsx, in cancel add task handler, which is a function that would be executed when the modal is closed, I set is adding task to true instead of false, you will see that if you save that and you run your tests again, it still succeeds even though at the end the modal is still open. It's still open because I just added a bug, so to say, because I changed this here from false to true, and this will cause the code to not close the modal. So the application is broken right now, but our test doesn't catch it. Instead, it still succeeds because it just simulates that click on the backdrop and it succeeds with that click, and therefore it thinks that everything is fine. So our test definitely needs some extra check. After clicking that backdrop, we want to check whether it's really gone and whether the modal is really gone. So what we want to do there is we again want to select the backdrop, and now we want to add an extra expectation here. We don't want to be able to find that backdrop. And right now the test would succeed if we do find it. Now to make sure that the test does succeed if we don't find it, we need the good old should method again. And now here say not exist. Because that's also something you can do. You can check for negatives. You can check for not something to be the case. In this case, for this to not exist. And I also want to take it a step further. If we quickly inspect the modal here, we see that this is a dialog with the class modal. And this, of course, also shouldn't exist after the backdrop was clicked. So I also will add another expectation, another assertion here, and look for the element with the modal class, or the dialog with the modal class. Important, no white space between the tag selector and the class selector if you use this combination, but it's actually not needed here. I'll just look for the modal class. And this also should not exist like this. This is now a better test because now we have some expectation regarding what should happen or what should be the case after the backdrop was clicked. And we expect backdrop and modal to be gone by then, but of course now our tests fail because that's not the case. Modal and backdrop are still there because of that bug I introduced. So now we have a proper test that actually fails if our conditions are not met. And this now makes us aware of this bug and allows us to dive back into the app.jsx file and set is adding task back to false here in line 26 in this cancel add task handler function. With that, if we then save this and we run our tests again, now the test succeeds because now indeed the modal is gone after clicking the backdrop. So you always want to write proper tests and test for all the things that make up the different states you want to go through in your test. Don't make it too simple. Make sure you don't accidentally write tests that pass in cases where they shouldn't pass. So we're making progress, but actually this test is still not finished, still not perfect. Because here I want to check whether the modal is successfully opened and closed. Now, we're not testing for all different circumstances or all available variations of that flow, if you want to call it like this. I can, for example, also close the modal by clicking on cancel instead of the backdrop. And at the moment, we're not testing for that to work correctly, though of course it should work correctly. Now, feel free to extend this test and add more logic to it to also handle a cancel button click and to make sure that the test also checks for the modal to really be gone after the cancel button was clicked. After a short pause, which I give you to pause the video and try this on your own, we'll implement this missing logic together. So, did you succeed? Let's add the missing logic together. Now we can, for example, select the cancel button by looking for the cancel text. That looks like the most straightforward thing to do, and that is indeed what I'll do here. So you might be inclined to simply add a new line of code here and select an element with the contains function, the contains method, which, as you learned, allows you to select elements by text, and select the element that contains the text cancel. And then we call click on that, just as we called click on add task before or on the backdrop. We don't need to add force here because the button should be reachable and shouldn't be potentially hidden below some other element. But if you would add this code and save everything, you would see that actually the test fails because it doesn't find this cancel button in the end. And why is that? Well, because it's still part of the same test, and keep in mind that here, with this line, we actually closed the modal by clicking on the backdrop, so there is no cancel button to be found thereafter. Instead, we have to reopen the modal by repeating this line here. And this is absolutely something you can do. You can have one test with multiple steps where you even repeat a step if you want to test different variations. You could add a second new test instead, but you can also put it all in one single test. That's perfectly fine to do. So here with that, we now open the modal again, and then we click cancel. Now, that still wouldn't be enough because, as mentioned before, we also want to check that now the backdrop and the modal are gone. So I will also repeat these two steps so that we open the modal, then click the cancel button, and then check whether backdrop and modal are gone. And with that, if we save this and we rerun all tests, this test succeeds. And of course, we can step through all the steps here in Cypress Studio. We open the modal for the first time, select the backdrop, click it, then check whether there is no backdrop, which is the case. Do the same for the modal. And then we again select the Add Task button, click it, then select the Cancel button, click that, check for the backdrop to be gone and the modal to be gone, and everything is fine. And the test passes. And with that, I'm now happy with this test, and we got our hands dirty related to user interaction simulation, and we also learned how to write good tests. Great, we got started with simulating user interaction. Let's dive deeper. Clicking buttons and backgrounds is nice, but it's of course not all users typically do. In this application, for example, it's all about entering data here and then creating new tasks. And of course, we also want to test this crucial flow. Now to do that, I'll add a brand new test, still in this tasks management suite, but you could create a new file, new suite, totally up to you. Here, for me, it makes sense to keep these tests together though, so I'll add a new test here, but outside of the previous test, so I'll just fold it to make this super clear. And then here in this test, I want to test whether users are able to create new tasks. Therefore, I'll give this test a description of, it should create a new task. That sounds like a fitting name. And in there, we now want to simulate all the steps that a user could take to create such a new task. So we want to open the modal, type some information here into the title field, and some text here into the summary field, pick a category or use the default category, and then click Add Task. That's what we want to simulate. And of course, thereafter, we want to check that this task also was created, that it's visible on the screen. So again, it's all about a combination of selecting elements and interacting with elements, simply what users do. So let's start by visiting this page. Again, just as before, we can copy this code here, visit this same page. Later, by the way, I will also show you techniques for reusing common steps, but here we'll just copy that. And then I want to select my button here, this Add Task button with the contains method, and then click it to open this modal. So again, this is what we did before. Now inside of that modal, we don't want to close it as we did before, but we want to type into those inputs. So for that, we need to select those inputs and then, well, type into them, simulate typing. Now for selecting those inputs, I'll again open my developer tools or look into the source code. That would work as well, but here I'll use the dev tools and take a closer look at these inputs. And what we can see here is that this first input, the title input, has an ID of title here. So that sounds like a great selector because there should only be one title ID on this page, and it's also not very likely to change. The second input, this text area, could be selected by the text area selector, just as we could have selected the first input by the input selector, but we can also use the ID here and use the summary ID. So the title ID for the title input, summary ID for the, well, summary text area. That sounds like it makes sense. We then can also select a category, but we don't have to. We can stick to the default here. And therefore, for this test, I'll just focus on filling out these two input areas, or these two input fields. So first of all, we get the title input by ID title using the hash symbol and then the ID value. And then here we know that this will be an input element. So we now want to type into this input element, and typing can be simulated by using the built-in type method. So we have click for simulating a click and type for simulating a user typing into an input field. Quite straightforward. Now, unlike click, type needs an argument because we of course want to define what should be typed into this input field. And here I want to type new task. The text is up to you though, but you should have some text here unless you want to simulate that a user doesn't enter anything. But in that case, you could skip the entire step. Now I'll then copy that and also select my summary field with hash summary. And then there we can type the same text or some description, anything like that. So now we fill some values into both input fields. Now we also want to submit this form. And to do that, I want to select this button. Now this button has the text add task, but I don't want to select it by text because we also have that same text here. So there are two buttons on the page that could be selected. Now, arguably only one of the two buttons is visible, but still, I would rather have a more unique selector for this button. And of course, we can get more unique by looking for the add task text inside of this modal, because inside of this modal, that's the only button with that text. Therefore, here I'll run cyget modal.modal to select the element with the class modal. And then there we can chain contains. And as you learned, contains can safely be chained after get and will then look for text inside of the element that was yielded by get. Unlike chaining get after get, with contains after get you can do that and it will look inside of that element. And here I then want to look for my button with the add task text. And now that button should be clicked. So again, we chain click thereafter. And here you also see something that's quite common when working with Cypress. It's very common to combine multiple commands with each other by chaining them like this. So with that, we click this add task button inside of the modal after entering some text. And now, of course, we want to check that this task really was created thereafter, that it exists on the page. Now, if I quickly do this manually, we can see what we should have on the page thereafter. And now in my test, I want to check whether this task item here, this list item, really exists. For that, we can get the element by tag or by this task class, which sounds like a better idea in case we also have list items somewhere else on the page, which we don't have here, but we could have more lists in the header or something like this. So selecting by this class makes more sense. Maybe even a nested selector with task list and task just to be super safe. And then we essentially want to check whether this item exists and whether it contains the text that we entered in this modal. And if we inspect this here in the DevTools, we see that the title is inside of a h2 element inside of the task, and the summary is inside of a paragraph inside of the task. So therefore here, what I want to do is I want to get my task element by the task class selector. And here, as you learned, this will actually give us all tasks that were found, not just the first matching one, but all tasks. And here, since in this test I'm only adding one task, I want to have exactly one task here, so we can use should and then again have length to expect only one task here in this list of tasks that we try to select. So this list of elements with the task class that we select here. We only want to have one element in there. So that's the first step. I then also want to make sure that I have my title and my description text in there. So I can then also select my task and there the h2 element. And there I expect to have some text, the new task text, which I have up here. And we can then repeat this. And instead of the paragraph of the task item, I want to have some description text. And that would be one way of defining some expectations, some assertions that should tell us whether this flow works as intended or not. You can definitely also come up with alternative expectations that would also work, but these are the expectations I will use here. And with that, we're simulating some text input here, and we're then checking for the overall application to behave as it should. I actually also want to add one other check and make sure that the modal and backdrop was closed after adding a task, because that's of course also something I expect. So from the previous test, I will copy these two assertions where I check for the backdrop and the modal to be closed. So that's what I want to check as well. So a bunch of expectations, which is not uncommon when writing end-to-end tests. And with that, if we save everything, here's our test. It finished successfully. And if we now break the application to see whether our test really works the way it should, it will hopefully, well, behave the way we expect it to behave. For example, in app.jsx, in the add task handler, if I forget this code here, if I remove this code in line 35 here for me, then I actually don't use the task data that was entered in the input in the modal. And therefore, if we save everything and rerun, the test should fail because it shouldn't find the task, or at least it shouldn't find the text that we entered. And indeed it does. It fails. It doesn't find the new task text here in the h2 element instead of the task item. That's good. Or if I bring back that code and then save it again, but I comment out or remove this line here in line 39, which is responsible for closing the modal, then if we save this, the test should also fail if we rerun it, because whilst the text is inserted and the task is probably created, the modal is actually not closed. So this test indeed works the way it should and catches some key bugs when we introduce them into the app. With that, I'll revert all those changes, save everything, and now, of course, this should run again. And what you see here, by the way, what you might have seen whilst the test ran, is that you can even see those keystrokes. Here, you see how it's getting filled out. And again, of course, you can step through all these steps here to see the different states of the applications as things are happening, as text is being entered, and so on. So that's very useful for understanding your application and your test. So that's another test added, another crucial concept, typing into input fields. But for this application, which we have here, we of course also have the scenario that a user opens the modal, does not close it, but clicks add task without entering anything, or maybe entering just a value into one of the two fields, not both. Now in these scenarios, as you can see, we get an error message, and that is indeed what we should get. But we might want to write a test for that to test for this validation to work, so that if a fellow developer accidentally deletes that validation logic, our test would catch it and would allow us to re-add it. So therefore it's time for another test, which I'll add to that same suite of tests here. And here I want to check for user input to be validated. So I'll simply give this test a description of should validate user input. And then here again, we have our test code. And here, just as before, we of course need to visit that page, open that modal, but then I won't type into those input fields. Instead, we visit this page. And now inside of that modal, we want to find that Add Task button and click it without entering anything. So we can then copy that code where we get the Add Task button inside of the modal and click it. And if we do that, we want to make sure that we see this error message. Now, if we inspect this here with the browser developer tools again, we can see that this is a paragraph with a class of error message, and we could use this class as a selector. Alternatively, we could also search for this text or parts of that text. And that is what I will do here, because contains can not just be used for searching for complete blocks of text, but also for parts of text. So here I will then use contains right on the overall document. Alternatively, we use the modal like this in between. Both would work, but since I'm confident that this validation text only exists inside of this modal, we don't have to explicitly target the modal. Instead, searching on the entire page should work. And now I don't want to copy and paste the entire text here, because in that case, the test would fail whenever anything regarding that text changes, even if it's just one word. Instead, I want to search for some part of the text which maybe is unlikely to change, like please provide or please provide values. And we can use this here inside of contains. And contains by default will not just search for elements that contain exactly the same text, but also for elements which contain at least this text, even if they then also contain more text than just that. By the way, it's important to get the casing right, because it is case sensitive by default. With a lowercase p, it would not work. But with an uppercase p at the beginning, if we save that, the tests rerun, or we run them manually, and we see that this test succeeds because indeed at the end it has this validation error message here as expected. And we don't need to add any separate explicit assertion, because contains will fail if it doesn't find that text, so it's clear that if it finds it, the validation error message is there. So that's why there is no need for an extra assertion. We're making good progress here, and by now you should feel quite confident to be able to select different elements or simulate clicks or type text into input fields. And definitely feel free to pause at any time and write some extra practice tests where you apply what you learned to this page to test all kinds of different flows, or simply repeat what you already learned. Now I want to continue practicing together with you, and I want to write one other test which actually adds a new task, and then thereafter checks whether this filter here works correctly, so that it displays the task if it has a matching category, and it does not display the task if it does not have a matching category. So for that, it's time to add another new test here. And here I'll describe it as it should filter tasks, because that's what this test is about. And of course, just as before, initially we visit this page and open the modal by clicking the Add Task button. So I'll just copy that. And then I want to insert some data. So just as before, in this Create a New Task test, I will copy these two lines of code where we select the input elements and insert some text into them and paste that down there. And then I actually want to pick a different category, let's say the urgent category. And to do that, we of course need to select that drop-down inside of the modal and then pick a category. Now, let's again inspect this with the developer tools, and we see that this drop-down has an ID of category. So that looks like a good selector for this element here, for this test. And then if we expand this here in the developer tools, we see the different options. And what's now really convenient when it comes to selecting an option with Cypress, as you will see, is that you could select it by the visible caption, so to say, so by the text which you see here on the left in the dropdown, which includes these emojis here though. But you can also select by the values that are invisible to the user. But you can use these values in your test, and since these values don't include the emojis, they might be a bit more convenient or a bit easier to use in your code. Though you could also use the emojis there, but this is simply a bit shorter and also less likely to change, because the caption that's displayed to users might be changed, and we don't want our test to fail just because the text changed necessarily, but these values are less likely to change in most scenarios. So therefore I'll select by those values by first of all finding this element. Now to find this element we can again use get. And then here, this was category, the ID category was assigned to this element. And then to select an element in a dropdown, we have the select method. So click for clicking, type for typing, select for selecting. Yeah, Cypress thankfully is quite straightforward. To select, we pass a string, and then as mentioned, we could add the text that's visible for users. And if we do that, it succeeds and is able to find that element as you see here on the right. But we can also use the value that is invisible to users, for example, urgent here for the urgent option, and the test will still succeed as you can see. And that is pretty nice since this makes things easier. So with that, we enter text, we have a category. Now we want to add this task, and for this we can again find the add task button inside of the modal and click it. With that, the task should be added. Now I'm not checking whether the modal is closed thereafter, because I'm already doing this in another test here, and we don't need to have the same logic in different tests. Instead, we really want to test for different things. Here we're testing whether a task is created, and that includes the check whether the modal is closed. Now I want to check whether a task is created and the filter works thereafter. So the focus of this test here is really on the filtering to work. So therefore here as a first step after creating the task, I of course want to make sure that it's visible, because by default after adding a task we have the all filter, and that of course should show, well, all tasks, so the newly added task should be visible. We can use the same logic which we used before and look for task items, and here I want to have exactly one task item, that one item which we just created. If we save this all, the test should execute, and it should execute successfully, and it does because the task is there. But now let's switch to a different category. So not urgent, but one of the other categories. And yes, you can interact with this snapshot on the right here, which is quite nice. Let's switch to moderate, for example. To do that, we need to select this dropdown here. So not the one inside of this modal, but this dropdown on the main page, and then choose moderate. Now, if I inspect this here, we see that this dropdown has an ID of filter. And then for the options, it's this moderate option, which I want to select. So here we get our filter dropdown, and we select elements by calling select, as you learned. And then here it's moderate. So this is a different category than the category that was assigned to the newly added task. Therefore, thereafter, after performing this step, our expectation is that the list of tasks is empty and there are no elements in there. So I check for 0 length. If the filter does not work correctly and the task is still there, the test should now fail. But here, if we save everything, we see that the test actually completes successfully and passes, because filtering for moderate indeed clears the task, so it's filtered out correctly. Now I want to make sure that if I filter for urgent, it's displayed again, and for all, it should also be displayed. So therefore, I'll copy this step here and set my filter to urgent thereafter. And thereafter, I expect to find my task again. So the list of tasks should now have a length of 1 again. And if thereafter we switch to all, I also want to have a length of 1, because I also want to see the task then. And with that, we can save this test, and it runs again, and it should pass again. And it does, because all these different steps work just the way they should. The element is added, it has the category, and filtering for this and other categories works with the respective intended results. So now that we wrote a couple of tests and selected elements and simulated user interaction, there is some noteworthy behavior by Cypress which you might have missed. Here in this example, I have 4 tests in the same suite, and all these tests are executed when I run, well, all tests by clicking this button, for example. Now, all these tests succeed, but please note that here in the Create New Task test, in the end of this test, so after this test finished, we have one new task here with a category of moderate. That's the end state of this test, of this should create new task test. But in the test thereafter, the should validate user input test, you might notice that we start with no tasks again, even though we added a task in the test before that test. And that's no bug or coincidence, instead that's a crucial Cypress feature. Cypress offers and ensures test isolation, which means different tests run totally isolated from each other, even if they are part of the same file or suite. They run in total isolation. Instead, Cypress really reloads that page, gives you a brand new browser context, and even clears any cookies or local storage data, if you would be using that in your application, before it runs the next test. And that's of course important because your tests should run in isolation. You should be able to run individual tests. The order of tests should not matter, and they should not interfere with each other. And Cypress ensures that they don't. And this is just something to be aware of. This is a nice feature built into Cypress. You might not have noticed it, but it is there, and it's extremely important. At this point, we already learned a lot about Cypress, selecting elements, simulating user interaction, and how to write tests, and also how Cypress executes those tests. But there are still more fundamentals I want to explore together with you. For example, more fundamentals related to element selection, and especially element selection in scenarios where we have lists of elements. I want to add another test where I want to check whether adding multiple tasks works correctly. So here I will say should add multiple tasks. Now, what do I mean with works correctly? Well, I mean that if we add multiple tasks, of course, all those tasks should be displayed. After adding one task, we should have one task in the list, and after adding another task, we should have 2 tasks. But I also want to make sure that the second task comes after the first task in this list of tasks. For this test, we of course can copy quite a bit of code from the create a new task test. We can copy the code where we visit the page, where we open the modal, enter some data, and click add task. That can all be copied down to this new test. And I'll just change the title to task 1 and the description to first task. But then I'll go through these steps here again and add a second task. And I'll just add an empty line here to make this a bit easier to read. So task 2 and second task. And now it's time to add some checks. After adding the first task here, we can get our task list. And this list should now have a length of 1 after adding one task. And after adding the second task, it should have a length of 2, of course. So if we save that, if we run all our tests, this last test, this newly added test, should also finish successfully. It should pass, and we can see these 2 tasks here on the right. So that indeed worked. Both tasks were added correctly. But I now also want to make sure that the order of tasks is correct, that task 2 comes after task 1 and not before it, so that the elements are displayed in the right order. And to do that, we need to dive into this list of tasks. So here at the end, I want to select all my tasks here. But now I want to compare the first and the second element of that list of task items and make sure that they are in the right place. And that's exactly what this lecture in the end is about. We can chain more queries here, more commands, and we, for example, have the first query to get the first element of a list of elements. We have the last command, the last query to get, guess what, the last element. And we have the EQ method here to get a specific element selected by index. So this would be the second element since the index starts at 0 in JavaScript. So therefore here we could, for example, select the first and the second element. And for the first element, which we could have also selected with first, of course, we can use contains and check for the first task text, like this. So we want to find this text in the first task. If we don't, we know that the first element in the tasks list is not the task with the text first task in its title. For the second element here in this tasks list, we can therefore use contains second task. And here, of course, we could have also used last instead of EQ1. I'm just showing you some alternatives here. With that, if we now save this, all tests run again, and this last test should still pass, though actually it looks like it fails. The reason for that is that I have a simple typo. I have a capital T here, but we have a lower t here, of course. And as I mentioned before, this is case sensitive, so let me replace this. Alternatively, by the way, we could of course also look for task 1 and task 2. But now here, with the typo fixed, with the casing corrected, this last test should now also pass. And it does. And these are more useful queries you can chain. Of course, you have even more than that though. If you use your auto-completion, you find many queries here. And attached to this lecture, you also find a link to the Cypress API reference. And there you find all possible actions you can call. So these would be actions that simulate user interaction. Here you find click and select and type and other actions you might need for other elements. And you find all these queries where you, for example, find contains and EQ and find and first. And other queries where often the name already tells you what these queries do. And if not, you can click on them to learn more about them. Here you learn all about their syntax then, and you'll also find some examples. Though speaking of examples, of course, you'll see many examples for many of these queries throughout the course, since we're just getting started. Nonetheless, it's good to know that this reference exists, and attached to this lecture, as mentioned, you find a link to it, so that you have all the resources you need in order to dive deeper. And that's it for this course section. In this section, we learned a lot about the Cypress fundamentals that you must know in order to work with Cypress in your projects. We learned or repeated how you can add Cypress and tests to your application by running npm install Cypress and then starting that Cypress Studio app with npx Cypress open, and that you can add tests to your project by using the it function provided by Cypress and also organize them into so-called suites, groups of tests with the describe function. Now inside those test functions, it's all about adding different steps, different commands that should be executed by Cypress in the end to simulate certain website flows. For that, you use this central CY object on which you can call various commands and queries, which then can also be chained with each other, so that you can do things like selecting a backdrop by its CSS class selector and then clicking on it. And speaking of selecting and clicking on it, these are crucial steps in almost all Cypress end-to-end tests that you're writing. It's all about selecting elements with CSS selectors by using get and possibly also find. You learned about the difference between get and find in this course section as well. find can be chained after get, but get can't be chained after get, or if you do so, you might get unintended results, to be precise. And you can also select elements by text by using the contains function. And whilst just looking for elements might be all you need for some tests, for many website flows that you want to simulate, you also need to simulate user interaction. And that is also super easy to do with Cypress, as you learned in this course section, because it gives you useful methods like click or type that allow you to simulate a click on a button or some user input in an input field. Now, the ultimate goal of your tests, of course, is to fail if your application, your website has a bug or if some unintended change was made to it, and pass if everything is okay. For that, you need so-called assertions or expectations that define when a test should pass and when it should fail, if the expectations are not met. Now, many queries like get or contains have built-in assertions, so implicit assertions, which you get automatically by just using these queries. If you look for a certain element with get and Cypress can't find it, then the test fails, which is very useful because it means you don't have to write an extra explicit assertion just to make sure that a certain element is there. But you can add explicit assertions by using should, for example. There also are some alternatives, which we'll explore later in the course, but should is the most common way of doing that. And with that, you can, for example, check that you find a certain amount of items in a list of items. You can also add as many assertions as you need to, and you're not limited to just one assertion per test. If you have some unit testing background, you might be used to writing as little assertions as possible, or at least you are used to not writing too many assertions. But with end-to-end testing, there really is no reason to limit yourself when it comes to adding assertions. Instead, when testing a certain flow, the idea really is that you define all the steps that need to be taken and you add all the assertions that are needed to test for the different states that make up that flow, that website flow. So if you switch between different states, you also want to assert that this switch happens correctly and that the UI updates as expected for every step. Now in this test, the first step is actually already there, that we want to visit a page, but we're of course visiting the wrong page. Some example demo page, not the page our application, which we want to test, is running on. Now, since we're running these tests locally, we'll just grab this localhost address here again, just as we did it in the first course section, and use this URL here as a value for the visit command. And this visit command is, of course, a very important Cypress command, a command you typically run at the beginning of all your tests, since you typically, want to test your website, and therefore, in order to simulate any user flows, any application flows, you first of all have to load that site, and that's what visit does. Now, visit, like all the other commands we're going to use throughout this course to structure our tests, is called on this CY object here. And this is a special object which is globally available, made globally available in these testing files by Cypress, and it's our entry point to all these Cypress commands. It's this object that simply offers us all these Cypress commands. So whenever we start a new chain of commands, whenever we start a new step in our tests, we do that with that CY object here, this Cypress object, so to say, like calling visit here, which is one of the commands supported by Cypress. Now, what's nice about visit is that it will also make sure that the test fails if visiting that page fails. And that can be important if you have a page with multiple pages, with multiple paths after the main domain, something like page1.html and page2.html. If you then have a test where you expect to successfully visit page2.html, but you have a typo in that HTML file name, and that page therefore can't be found, your test would fail. Indeed, that is what we can see here. If we save this, and we have the development server, and the npx Cypress open process up and running, if we then go back to the Cypress app here in the browser, we see that the test failed because it fails to visit page2.html on that domain, which makes sense because that page doesn't exist here. So visit is not just a command that gets us to a page, it also ensures that this page renders correctly, and the test fails if it does not. And therefore here, since I want to check whether the page does render correctly and it contains the main image, I already have my first check by simply adding this one single line, and it fails if the page does not load correctly. Now here, of course, I don't want to load page2.html, hence I'll remove that and just visit localhost 5173 in my case. And with that, the tests should succeed again. If they don't, simply quit this npx Cypress open process and rerun it, since Cypress might have got stuck, and thereafter the test should succeed again. So that's the visit command, a very important command, since this is the command that allows you to visit your different website pages, and a command that also ensures that visiting those pages succeeded, or else you will know because your tests fail. Now that we explored a lot of important Cypress fundamentals in the previous course section, it's time to dive a bit deeper. Dive deeper into selecting and using elements correctly, dive deeper into actions and simulating user interaction, including page navigations in this course section now, and take a closer look at assertions and what we can do with them, and also exploring an alternative way of formulating expectations. Now, for this course section, you find a brand new starting project attached. It is, again, a very basic React project, a project which we'll use to explore these slightly more advanced Cypress features. And what's special about this project is that it already has Cypress added as a dependency. So after downloading this attached project, you just need to run npm install to download and install all third-party dependencies of this project, including Cypress, since that is stated here in this package.json file. And then thereafter, you want to run npm run dev to, again, start this project development server. And with that started, you should be able to view this website in the browser. And one key new feature of this website compared to the demo website we saw in the previous course section is that here you have some navigation. You have an about page and a home page. And on that about page, we have a form with some validation, and therefore a lot of things that we can test with Cypress. Speaking of Cypress, since it's already installed, all you have to do to use it is run npx Cypress open in a new terminal window in this project, and then pick E2E testing, the Chrome browser, and you're good to go, and you can start adding some spec files. Either again here through this Cypress Studio app by creating a new spec, or of course simply in your IDE in this E2E folder in the Cypress folder. And that is what we will do in the next course lecture. Now I want to start this section with a new concept or with a new kind of test. I want to test page navigation, so that if we are on the home page, we navigate to the about page and back. I want to test that this works correctly, that these links in the main navigation work correctly. And for that, in this E2E folder, we can add a new file, and we could name it navigation.cy.js. The name, of course, is up to you, but it must end with .cy.js for Cypress to pick this up. Now, up there at the top, I will add this reference types equals Cypress thing here to make sure that I get proper auto-completion. And then we can create a new test suite with describe. And here I'll just give this a name of page navigation, because in this suite I want to group all my tests that are related to page navigation. Then here in this function we add the individual tests with the it function, and the first test that I do want to add here should simply test that we can navigate between these two pages. So I'll just give it a description or a name of should navigate between pages, like this. Now in this test, we of course want to start by first of all visiting our website again. So localhost, then this port number, and then /nothing here. That's the first thing I want to do. But then thereafter, as a next step, I want to select my about link here in this navigation and simulate a click on that link, which takes me to the about page. Now, as always, we can inspect this to find a fitting selector, and there are a couple of options that we have. We could, for example, use the get function here as always to then look for a link in the header. But that would not be great because we could have different headers on the page in different areas of the page. And of course, we also probably have multiple links in every header. So this is not very specific. Of course, here we know on this page that the about link is the last link here. So we could say header A last to select this last link, but again, we might have multiple headers, so this is not very specific, and we also might change the order of the links, and in that case, last wouldn't grab the link to the about page, and our test therefore might fail. So this is not a great way of selecting this. Now, a better way is to use a special attribute, which I already added to this about link. And that would be this data CY attribute here. This is the officially recommended best way of selecting elements in your Cypress tests. Using such a data-CY attribute, which is a custom attribute, not a default attribute, but a custom attribute that you can add to any HTML element directly in your source code, or if it's a React application, you add it basically as a prop to any element of your choice. So it's super easy to add. And using such a data-CY attribute is the officially recommended way to select elements in Cypress. So the Cypress team recommends using this kind of attribute to then use it as a selector when reaching out to elements, when getting elements, and when writing assertions. Now you can select elements by this attribute by using the CSS attribute selector, which looks like this. You use square brackets, and then between those square brackets, the attribute name, in this case data-CY, and then equals, double quotes, and then the attribute value, in this case header-about-link. So in the end, you simply repeat what you saw on this anchor element. And this selects all elements with this attribute and this value. And since this is an attribute that's specifically added for these Cypress tests by you, the developer, this should be guaranteed to be unique. You should never use the same attribute value combination on multiple elements. Instead, you should only use every combination once. So this link in the header is the only link or the only element in general with data-CY equal to header-about-link. That's why it's the recommended way of selecting elements, because it's guaranteed to be unique for every element. Now you could also use this data-CY attribute in situations where you don't want uniqueness, for example on list items, but then still you would have a clear way of selecting all these list items. And the main reason for using this data-CY attribute is that it's specifically added for testing purposes by you, the developer. So if other developers, or maybe even yourself on another day, if those developers start working on the code and you move an element around, you don't accidentally break this Cypress selector. If you do instead use some nested HTML tag selector, for example, looking for anchor elements inside of a header, you don't just have the danger of selecting elements that are part of some other header somewhere else in the application, somewhere else on the site, but you also have the danger that this anchor element gets moved outside of the header. So it's not inside of the header anymore, and therefore this selector fails. Sometimes you might want to catch these situations with your test, and then using that selector would have made sense. But more often than not, this is not something that should break your test, because the link still works, it's just somewhere else. So if your selectors in your tests are connected too closely to your DOM structure or your CSS classes or your regular IDs that are assigned to elements, you have the danger of breaking your tests in an unintended way, just by moving elements around. For all these reasons, you typically don't want to use tags or CSS classes or even IDs as selectors, but instead use these test-specific data-cy attributes. This is the officially recommended way, and that's what we're going to use from this point on for the rest of this course for most use cases. Of course, in the previous course section, we have not used this approach yet, because there we just got started with Cypress and I wanted to introduce one new concept at a time. But from now on, you should keep in mind that typically you want to use these data-cy attributes, assign them to your elements, and then use them in your tests, and avoid using tag selectors or class selectors or ID selectors. You can do it, but you should typically avoid it. So, a lot of talking about that, but it is crucial to understand that you can use a lot of different selectors. You can get really creative when it comes to selecting elements, but in most cases you do want to avoid tag or CSS class or even CSS ID selectors and instead use this special data-cy attribute. Okay, so in the previous lecture we got started with this selector and I talked a lot about it, but it is important to understand why we're using it and why it's better than a class selector or some tag selector or a combination of other selectors, because this is not going to change. With that, however, we're now ready to finally click this anchor element, this link, and navigate to a different page, to the /about page, because this is the about link in our main header after all. Therefore, thereafter, in this test, we want to verify that we successfully switched to that new page, because that is what this test is all about. And to do that, we can again use the cy object, and then there we actually have a location method, which allows us to get information about the location we're currently at on our website. We can pass an argument to location, and here we enter a string value that allows us to access various pieces of information about our current location. For example, the path name. And this path name will be something like / if we are on the starting page, or /about if we're on the about page. And you can see this if you play around with these links on the actual page. If I click about, you see that in the URL, it's localhost 5173/about. For the home page, if I click there, it's /nothing. There is no / at the end, and that's the same as /nothing. But for about, it's /about. And therefore here we can get the path name, and then add our assertion with should, and then here I want to make sure that path name is equal to /about after clicking that about link. To do this, we can use the equal assertion or short EQ. It's the same as equal, doesn't matter. And then for this assertion, we need a second argument. And here, this is the expected path name. So in this case, /about. If we save that and we go back to our Cypress Studio application and we click on this navigation spec file, our test should run successfully now, because we did indeed switch from the home page after clicking on the about link to the about page. And hence we have /about as a path name. So that worked. Now, as part of this test, I actually also want to test that we can go back successfully. And to do that, we could now search for this home link and click this, because this would be one way of going back. But of course, users might also press the back button, and that should take them back to the home page as well. So in order to simulate that, we can again use the cy object. And here we have a special go method, which allows us to go back or forward. So here we can trigger that browser back or forward button. And here I want to trigger the back button by going back. And thereafter we can repeat this assertion here, take a look at the path name, but now it should be /nothing, because we should be on the home page. Here we were on the about page, now we should be back on the home page. If we save this, the test should rerun. We can also do this manually, and it of course also should still work. Now thereafter, I want to go back to the about page by using this about link and clicking it. And we know that this navigation works, so we don't need to assert it again. But now I wanna click this home link to make sure that this also works, and it's not just the back button that may take us back. So for this, we need to select it, and again, we could use some nested tag selectors maybe, we could assign an ID, we could add some CSS classes, but those are actually dynamically generated in this application, so that wouldn't be great. And for all these reasons, and for what I explained before, we want to use this data CY attribute, which I also already added here to this anchor element. So here in the end, we copy this line where we click the about link and use the value of the home link, which is header-home-link. And we click this, and thereafter I again run my assertion that we are on the home page. Now with that, we can save that as well. And now this test should run again, and it passes again, because we do now indeed navigate from the home page to the about page. Then we go back to the home page. Then we navigate to the about page again. And on that about page, we click the home button or the home link and go back to the home page. So this works as expected.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So at this point in this section, we already learned two very important new concepts. We learned about this data CY selector, or about this approach of selecting elements by using this test-specific attribute as a selector. This is a very important concept and definitely something you should use in your tests. But we also learned about location and go, so about some new methods that are available on this CY object that help us learn more about the current state of the website. And you might of course wonder, how many more methods are there? What else could be inspected? And you can find a list of all these supported methods in the official Cypress documentation. To be precise, they're in this API reference, and you find a link to this reference attached to this lecture. There, under queries, you find all these methods that can be accessed on the CY object and that can be chained onto each other. And here, for example, you find get and location, but also all these other methods that exist. You there also find all the details about the options that can be passed to these different methods and plenty of examples. I did mention this earlier in the course already, but I wanted to mention it again so that you know where to dive deeper if you want to. That being said, as always, it's of course typically the same set of core methods that you're going to use over and over again, like get, which we've already used quite a bit throughout this course. And speaking of get, there is something else I want to show you related to the selectors that you can pass to get. Now, you can use any CSS selectors like this one, as you learned. You should prefer this data CY selector if possible, and unless you're sure that your other tag, CSS class, or whatever selector won't accidentally break the test. But when it comes to finding good selectors for an element that you want to select, you're not limited to using the browser developer tools on your page and coming up with a fitting selector on your own, but you can also go here to the Cypress Studio app in the browser, and there you can actually jump to a snapshot of your liking, like for example here, this About Us page. So jump to any step you want, and if you then click on this button here on the top, you open this selector finder or selector playground, you could call it. And now you can hover over elements here, and Cypress shows you the best possible selector for the element you're currently hovering over. So it shows you the best selector it can currently find on that page for uniquely selecting that element you're hovering over. For example, you see that this text area also has a data-CY attribute, which I added in my source code. That's why Cypress suggests using this selector. But if I would want to select this about us text, for example, it sees that there is no data-ci attribute on that element, and therefore it instead suggests this selector to uniquely select this title. This does not mean that it wouldn't be better to add the data-cy selector to this element as well, but since it's not there, this is the suggested selector. And this can also be a useful feature for quickly finding the best selector for a given element. So we added our navigation test here, and with that I'm happy when it comes to testing navigation. But on this page we of course also have this form down there, and there are plenty of user flows related to this form that we can test. Therefore I'll add a new spec file, contact.cy.js, could be a fitting name, and I'll put my contact form related tests inside there. So here I of course again want to describe my contact form, let's say, and have some tests in there. And I also want to make sure that I get proper auto-completion, so I'll copy over this reference entry here in the first line in this file. And now let's say we want to add a test that evaluates whether the form can be submitted successfully. So here I'll just name this test should submit the form. And then we can add our logic for submitting the form in there. And for this form, this would mean that we want to select all these inputs, enter some data there, and once data has been entered into all inputs, we want to submit this form by clicking this button. And here for this application, this button then briefly changes its text and gets disabled before it's there again. So my goal now is to test this submit flow here. For that, I'll first of all start by visiting this page. And here it's actually the about page which I want to visit. So I add /about here at the end. There's no need to start on the home page and then simulate a click onto a link to get to the about page. If the thing we want to test happens on the about page, we can also just start there and visit this page right from the start. And then I of course want to select these different input elements. And as mentioned before, these elements do have these data-cy attributes. It's contact-input-message for this message text area, and then it would be contact-input-name for this name field, and then contact-input-email for this email field. So therefore, we can of course use this get method, and then use this attribute selector as you just learned it a couple of minutes ago, and then here select the message input field, and also thereafter the name input field and the email input field. And of course, I also want to do something with these fields, but I definitely also need to select them. Now, what I want to do with them is I want to type into them. And of course, definitely feel free to always pause the video and try some steps on your own first. For example, here, try adding this typing logic on your own. You can always do that, and doing so will always be a great practice. Here, we could type into these fields by using the type method about which you learned in the previous course section. Here for the message, we could enter hello world. Then down here for the name, we could use John Doe. And for the email field here, we could use test@example.com. So thus far, nothing new. This is just a repetition of what we learned, but of course, repetition is also important. Now, in order to submit the form, we need to select the form button, and we can do this with ci-get. And of course, we could select the form button like this by using form button, and this would work here. But again, if we have multiple forms with buttons or one form with multiple buttons, we might accidentally select the wrong button or more than one button, and we don't want to do this here. Instead, this button in this form happens to also have a data-cy attribute, and if it wouldn't have it, we could of course add it. And here the value then is contact-btn-submit. So here in our code, we can safely select this button by using data-cy and then between double quotes this contact-button-submit value. Here I then want to click it. Now when this form here gets submitted, as shown before, the caption the text on the button changes briefly and the button gets disabled. And we might want to check these things. To do that, we of course can select this button here again. And after clicking it, so after the form was submitted, since this is the submit button of that form, we want to ensure that it has the correct text and that it is disabled. Now we can check the text by using contains, and here it should be saying sending ... after submitting the form. We also might want to check that it has the correct text before the form is submitted, so here we then want to check for the text of the button to be send message. We also want to make sure that it's disabled, and for this we can of course also select this button, and here we then want to take a look at one of the attributes of that button. We want to verify that it's disabled. Now there is no disabled method as there is contains for text checking, so we can't use this. But we can, of course, use should to add an assertion to this element, to add an expectation. And then here we indeed have attribute-related checks. If you type attr, you see that there is this have attr check. And here we would want to have the disabled attribute on this button. So that's a new kind of assertion and another example for what you can assert. Again, you have all these available assertions, and I showed you this assertions reference in the official docs earlier in the course already. You also find more assertion examples if you go to the should API page in the official documentation. And here we're using this have attr assertion to check if the disabled attribute is set on the button after submitting the form. And of course, before the form is submitted, we want to make sure that we don't have this. And to do that, we can simply add not in front of have attr. That's another supported assertion. If we save that, we can go back to our tests, go to this context.cy.js file, and it runs through all these steps, and in the end, the test passes. So as you can see, there's a broad range of things you can look for or you can check as part of your assertions, and it's really your imagination that's the limit. You should come up with assertions that make sense for the specific use cases you want to check. Now, in this example on which we worked in the previous lecture, we're doing a lot of things with this submit button. Here I'm selecting this submit button 5 times and then I'm doing different things with it, checking for different things, clicking it, and so on. Now, writing the code like this is perfectly fine and in my opinion also quite readable. But you can also restructure the code if you want to, because you should keep in mind that many of these queries like get or contains or should can be chained onto each other. So for example, here we could remove this selector and change should after contains, so that we select this button, then check whether it has this message. And as you learned earlier, contains does not just check for the existence of the text, but it then also yields the element that contains the text, so this button here in this case. And therefore we can change should after contains and perform an additional check on this button that is yielded by contains. In this case, checking whether we don't have the disabled attribute. If we restructure the code like this and save this, the test still runs successfully because this is a valid way of rewriting this test. It's not better than what we had before, it's just an alternative. By the way, you could also use the word end here because Cypress gives you the end method, which is simply an alias for should, just to make this overall sentence more readable. Because this now all says, get me this button, check if it contains this text, and then if it does not have this attribute. So that's a pure stylistic readability thing. You can use end or should, it's the same, and you can write it like this, or as we had it before, use 2 separate button get calls. This is up to you, but you should be aware of the fact that you can chain certain commands like this. Now, being able to chain commands like this is a very useful feature. One other thing you might be tempted to do when you see code replication like we have it here is to create a constant, which could be named button, and then you store the result of getting the button in this constant. And then thereafter, you replace your calls, your get calls, where you try to find that button with that constant that already stores this button. If you do that and save this, you will see that indeed the test still passes, so this works. But what's super important to understand here is that this might not work the way you think it does. Get does not give you the button. If you hover over a button, you see what kind of value is stored in this constant, and this is some chainable object. It's not the button itself. Indeed, what Cypress does when it executes this test function is it reads all your instructions here, one after another, and then it creates a queue of steps that should be performed, and then it runs that queue. So you just give a bunch of instructions to Cypress here, which helps Cypress build its queue. Therefore, what you get here when you call get is basically an instruction. And then you're reusing this instruction here 3 times, which works, but you're not getting the button itself here. This is important to keep in mind. And indeed, storing a command like this in a constant works here, but is not recommended. What you should do instead is create an alias with help of the chainable as method, which is offered by Cypress. As allows you to assign any alias of your choice to a value, for example an element, derived by a Cypress command. So here we could name this submit btn, but this is up to you. And then you can reuse this command or the element that's yielded by the command, so to say, by using this alias. And this alias can be used with the get method by referencing it with an @ symbol and then the alias name. So in this case, submit btn. And this would be the proper and officially recommended way of reusing a value yielded by a command. Use such an alias by defining it with as and by then using it with help of get and this @ symbol. With that, the code still works, this test still passes if you run it, but you're now doing it the proper way, the Cypress way, by using aliases. Now, aliases are a very important feature, but sometimes you might want to work directly with the element that is yielded. So you don't want to store it in an alias and then continue with click or contains or should and all these things, but sometimes you might want a more direct access to the element that is in the end fetched by Cypress. And Cypress gives you that direct access if you want to. For example here, instead of getting the button like this and checking for its caption and its attribute like this, we could also copy this get command and then comment out this line of code and instead call get and chain then after get. Now you might know then from promises. In JavaScript, you can use the then method on promises to tell JavaScript which function to execute once a promise resolved. Now here what you're getting is not a promise. You don't get a promise, but instead a chainable object. Nonetheless, Cypress gives you a then method to which you can pass an anonymous function. And as an argument to that function, Cypress will pass you the actual element that it selected in the DOM. It's still not the native DOM element you could select with vanilla JavaScript, but it is an element which gives you more access to the different properties the DOM element might have. To be precise, the argument you're getting here in this function you're passing to then is the so-called subject of the method you had before then, so of this get method here. And when using get with a selector as we're doing it here, this subject will actually be a wrapper object around the matched DOM element or elements, since you could also be matching multiple elements with that selector passed to get. And this wrapper object, which I named L here, then simply gives you more direct access to these matched DOM elements. Later in the course, you will also see other use cases for then, where the subject we're getting in then will not be a DOM element, but some other kind of data. But again, that is something we'll get back to later in the course. This L object which you're getting here, for example, has various utility methods that help you with adding CSS classes if you want to manipulate it as part of your test, or for checking whether a certain CSS class is set. You also have an attr method which allows you to check the value of an attribute. For example, here we could use the disabled attribute like this and take a look at its value. You also have a text method which gives you the text inside of that element, which then could be evaluated as part of an assertion. But that's now the interesting part. How could you now add an assertion for this L object that you're getting inside of this then method? Indeed, you do no longer have access to the should method. This method does not exist on this L object, neither as a chainable method nor as a method that could directly be called on the element. So that's not how you can add assertions here. Instead here, you can use an alternative way of defining your assertions, which you might know from writing unit tests and which is also supported by Cypress. You can use the globally available expect function. And expect then takes a value. For example, let's say we want to check whether this button is not disabled, so whether it is enabled. And to check this, we could pass L and then call the attr method, which exists on this L object, and pass disabled to attr. Now what this does is it gives us access to the disabled attribute, and this disabled attribute is passed as a value to expect. And now after expect, we can chain more methods made available by Cypress to formulate our expectation. So what we did before as part of should, via this first argument that's passed to should, can now be done by chaining properties and methods after expect. And here again, it's basically like writing a sentence. You can add .to and then .b .undefined to make sure that this button is not disabled. By writing this assertion, we're making sure that this test fails if the button should be disabled. So if the disabled attribute is defined before we submitted the form. We want it to be undefined, which means the button is not disabled. We can also check the button text by using expect L and then the text method to collect all the text inside of this element, which is passed to then. And then here we could say to contain send message or to be send message. And there's a broad variety of supported properties and methods here, as you can tell. And again, that's exactly what you find in the official documentation. Here in the assertions reference, you learn that different styles are supported by Cypress, like this expect style I showed you a couple of seconds ago. And basically all the assertions you can write with expect like this could also be written with should as a string value for this first argument when following this traditional Cypress approach I showed you up to this point. But you can also use this approach instead. And you basically have to use this approach when inside of this then function here. Because as shown before, you can't change should on this element. So outside of this then function, you typically use should, and you have your assertion in this first argument as a string. And inside of this then function, you use expect, and you pass your value to expect, and then define your expectation. So now that we learned that there are different ways of selecting elements and getting hold of elements and defining our assertions, let's get back to actions, and specifically to the type action. What I'm doing here in this test is I'm typing into all these input fields, and then I'm submitting the form by clicking this submit button down there. Now, this is perfectly fine, very expressive, and a realistic representation of a typical user flow. There would, however, also be an alternative way of submitting the form, and that would be a way you probably also would want to test. As a user of this page, it's not unrealistic that I'm entering my data here, and once I'm done, I'm not clicking this button, but instead I just finished entering data in the last input field and I hit enter. And that should submit the form. Now, since I'm doing that and I'm not clicking the button, we might want to simulate this flow as part of our test, hitting the enter key. That's what we might want to simulate. And Cypress makes this very straightforward and easy as well. Instead of selecting our button here and clicking it, we can comment this out and then take this line of code here, this step in our test where we enter the last value in the last input field in this form, and move this after these checks, which we want to run before the form is submitted. So move this here, for example. And now we can add a special character here to this form input. So a special character which we want to type into this input. And that special character would be opening and closing curly braces, and between them, enter. There's no white space between this enter thing and the email address, because we want to simulate that the user types the last character of the email address and then hits enter. And that's exactly what this curly brace enter thing represents. It's simply the user hitting the enter key on their keyboard. Now, if you take a look at the type documentation in the API reference, you learn about all these special keys. If you scroll down a little bit to arguments, here you find all these special keys like backspace, end, enter, and so on that can be simulated with the type method, because these are all special keys the user might be pressing when typing into that input field. Now, arguably, enter is the most important one because that simulates the submission of a form, but maybe you also have some other form-specific behaviors in your application that you want to test, where the form, for example, should behave differently when the escape key is pressed or anything like that. Well, that's how you could simulate it, with the type method, and then by defining these special key presses with the curly braces and then the identifier between them, like here for hitting the enter key. If we save this test still runs successfully and passes because the form is submitted as expected. Now, to conclude this section, let's write another test where we'll see some new features and a new way of using this then method and this direct element access. The new test which I want to write is related to this contact us form. In that form, when you select an input field and you don't enter anything, and you then lose focus on that input field, for example by selecting another field, you see that some special styling is being applied. And I want to write a test that checks whether that works as intended, so whether this styling is being applied when the input is blurred. Of course, we can see that it works that way, but we want to have a test that warns us if in the future, accidentally, that feature should maybe be removed from the code. So we want to have a test that checks exactly this behavior, a test that checks the form validation. And related to that, the same test should also make sure that when we click send message, the form is not being submitted if invalid data was entered, if all the form fields are empty, for example. Now, for this test, we'll need a couple of new features, but of course we'll start by creating a new it function in this contact form suite. And here I'll give this test a description or name of it should validate the form input. That sounds like a fitting name. And then, as mentioned, I want to do two things in there. I want to make sure that the empty form, when being submitted, is not submitted. And we can tell that it's not submitted by taking a look at this button. If we click it and it does not change to sending ... and become disabled, that means that the form is not submitted. Because we saw before that if it is submitted with valid data, the button does change. So if it does not change, that means the form is not submitted. So we want to make sure that that's the case, that the button is not changing. And then in a second step in this test, we want to check these validation styles here, this invalid style that's being applied if the input is invalid. Now, as a first step, let's visit this about page. That's definitely something we have to do. And let's thereafter select this button, this submit button. And for that, of course, we can use this data CY attribute that's added to it with a value of contact button submit. Just as we did it before, here we can practice what we learned and select this button like this. And then we can click it to submit the empty form. That is the first thing I'm doing here, submitting the empty form. Now, as mentioned, thereafter the button shouldn't change. So, of course, we can again select this button and, for example, check whether it contains the text send message, because that is the text it should contain if it has not been submitted, right? If we save this all, our tests run again, and they both pass. So looks like we're off to a good start, right? Well, not quite. This is not a good assertion. We're checking for whether the button says send message. But look what happens if I take this check and I add it at the end of the first test. And keep in mind that there I actually do submit a valid form. So there the button does change after submitting the form. But even though, despite that being the case, if I save everything, both tests still pass. The first test still passes, despite my check for the button saying send message. Why is that the case? Because all these checks that are provided by Cypress have a certain time frame, which is used by Cypress to check whether your expectation is met within that time frame. And by default, that would be 4 seconds. We'll take a look at how we can change that configuration later in the course, but that's the default time frame. This means that if at any point of time during 4 seconds after starting this step, the button says send message, this assertion here is met, this expectation is met, and the test does not fail. Now, of course, the button does change to sending ... if a valid form is submitted, but it changes back to send message before those 4 seconds passed. That's why this is not a great check in this second test here. If we want to make sure that the button doesn't change at all, it's not enough to check for the end result. Instead, we have to make sure that it's not getting disabled and that it's not having the text sending ... And to ensure that this is the case, we can, for example, use the then method again to get hold of that element, and then in there we can expect that this element should not have the disabled attribute, for example. Now we could check this as we did before, like this, or to simply show you an alternative and to show you that there's always more than one way of writing an assertion, we could expect element to not have the attribute disabled. That would simply be an alternative way of writing this. So now the test will fail if the button does have the disabled attribute, which it will only have if the form was submitted, which it should not be in this case, and that's why we want the test to fail if it's the case nonetheless. We can also expect that the element text here, and keep in mind that this is a method, so the text of this button is not equal to sending ... With that, if we save this second test still passes, but now it's a better test because we're now making sure that the button is never changing. And it should never change if an invalid form is submitted. So that's the first part about this test. And you see that it's really important to carefully think about your assertions as we're doing it here. Now, I also want to make sure that if we blur an input field, we get this error styling. Now for that, we need to select these input fields, and we can do this as we did it before with these data CY selectors. That would be message for the message field, name for the name field, and email for the email field. And we can then blur them with another new method you haven't seen before, which is called blur. So that's something we can do. We can blur these fields. And now we want to make sure that the look of those fields changed. Actually, not just of the fields, but also of the labels that belong to these fields. Now, if you take a closer look at the developer tools, you see that the styling changes because of this invalid class that's being added to the paragraph that wraps label and text area. So because of this class. Now, this class name in this application is actually dynamically generated. So we shouldn't write a test where we check for exactly this class name because it's not a stable value. Now, what is stable here, though, is this invalid part in this class name. So if we don't check for the entire class name, but for a part of that class name, we can use that information to determine whether this class is applied and whether the appropriate styles are being applied based on the information whether this paragraph, the paragraph that wraps the input that is invalid, has a class that contains the word invalid. And that's what we could check in our test. Now, to do that, we of course need to select those input elements, and I'll again do this with the data cy selector here. So use this attribute selector with data cy equals, and then this name, in this case to select the message input field. And we can then simulate this field being blurred by using the blur method that's provided by Cypress. A method we haven't used thus far, but a method you do want to use if you want to simulate that some input field or some element of any kind loses focus. That's what blur does. And that's the first step. Now, after blurring, we want to make sure that the paragraph that wraps this input field has a class that contains the word invalid. For this, we first of all need to get access to that paragraph element. Now, we don't have a data cy attribute on that paragraph, but we could of course add it in the source code. Here, however, it's not that likely that this DOM structure is going to change. It's not very likely that we're going to introduce some extra wrapping element around the text area or input that would be between the input and the paragraph. So it should be safe to select the input or text area and select its parent, which would be this paragraph. Again, here for this part of the DOM, the structure is not likely to change. And this allows me to show you another new method offered by Cypress. You can use the parent method on an element to get hold of, well, the parent. Similarly, by the way, you also have a children method to get hold of the children. But here it's the parent we want. And on this paragraph, we can then call then to get a more direct access to this paragraph. And then we can write an assertion with expect again. And here we want to take a look at the class attribute of the element, which we can do with help of the attr method. And we want to make sure that this contains the word invalid. It may contain more, but it should contain the word invalid. And that would be one way of checking whether this paragraph that wraps the input field has a class that contains the word invalid after we blurred that input field without entering anything valid. If we saved it all and we rerun all tests, they should both pass. And we can see here on the right, in the second test, that indeed this is being blurred here. And then we do have that styling applied. As you can see on the right, the label has this red color. And our test passes because we correctly determine that this invalid class was added. So that's how we could write this test. And of course, we can repeat this for all the other input fields as well. We can repeat this for the name input field, and thereafter also for the email input field like this. And if we save that all, this should also all work. Only that we get an error now, that blur can only be called when there is a currently focused element. And we're getting this error because after calling blur on the first input field, it does actually not automatically move the focus to the next input field. So what we should do to be safe is call focus first, which is another method offered by Cypress, which does what the name suggests. It focuses an element, it selects an element. Now we can do this for the message element as well, just to be safe, and also do it for the input element. And with that, we always focus those elements. We force Cypress to focus those elements before blurring them. And with that, of course, the test passes again. You see on the right that it indeed did select and unselect all elements, that they all have the invalid styling applied to it, so the red border and the red color for the label, and we correctly checked for all of that in our assertions here. Of course, here for this test, we also could have used some aliases to not duplicate all that code. And therefore, just to show this again, we could store this message input by calling as after selecting it and giving it any alias name of our choice, like MSG input. And from that point on, thereafter, we can always also just get this alias by using @ and then the alias name. And that saves us some typing here and also makes sure that if we ever change this data CY attribute value, we only have to adjust it in one place and not in all those places, which is also convenient. So that could of course also be done for the other input fields. I'll not do it here because it's not too much duplication, but you should definitely keep in mind that this aliases feature exists and that you could use it like this. Of course, our test still passes as before because we did not change the logic of this test with that. And that's it for this course section. We took a closer look at selecting elements in this section, and we learned that you should prefer this special data attribute. Data-CI attribute selector, simply to make sure that you don't accidentally break your tests just because you changed some DOM structure or some CSS class name. It's less error prone than other selectors, but of course, as you also saw, this does not mean that it's forbidden to use those other selectors. It's just preferable to use the data-CY selector. You also learned about aliases, which you can use to store some values or some elements that are yielded by get, for example, in a reusable way. Simply to save yourself some typing and reuse those values or elements in a safe way. Now, speaking of using elements, you also learned about a new way of getting element access with help of this special then method, which you can use for more direct element access, which can sometimes be useful, as you, for example, saw in the previous lectures when we also used it to take a closer look at the disabled or class attributes of certain elements. Now, kind of related to that, you also learned about different assertion approaches, and you saw that in most cases we use should, but if you do dive into this more direct element access with help of then, you actually have to switch to this expect alternative. You actually have to switch to this expect alternative because you can't change should on this element you get inside of that then block. So in the end, it's really about combining these different ways of writing your assertions and these different ways of accessing elements. In my personal opinion, you should typically prefer using get and all these other methods, and only use then if you really need this more direct element access. But as you also saw in this section, in some scenarios, it's really just for certain evaluations and certain tests, it's perfectly fine to use then, and it gives you a quick and easy way of checking exactly what you want to check. So now that we had a closer look at selecting elements and writing assertions, we're almost done for this section. But of course, the goal of this course is not just to help you write tests, you should also be able to analyze your test runs. For that, of course, the Cypress Studio app is a crucial tool. And we already used this tool quite a lot. It's opened by running npx cypress open, and in there you can dive into your spec files, run all the tests in those files, repeat them at any point of time, and you can then, as you saw, analyze your tests, take a look at every step, and on the right here, you then also see a snapshot of the page as it looked like when that step was executed by Cypress. Which is of course a super useful feature, and which of course also is a feature that can help you debug tests that are failing to understand why they failed. But even for successful cases, it can be useful to take a look through those different steps to make sure that your step really worked the way you wanted it to work, so that you're not accidentally testing something wrong. Here in these steps, as you can see, you also see your assertions and you see whether they passed or not. If they failed, as you saw earlier in the course already, you also get an explanation telling you why they failed, helping you understand why the test did not pass. You see the aliases you used, and you can also click on any of these steps to pin this snapshot here on the right so that you can take a closer look at it. Because this here is actually not a screenshot, instead it's really your website running in the browser as it looked at a certain point of time. You can inspect the elements there, you can open your developer tools here if you want to, and you can therefore take a closer look at your page at any point of time. Which of course is another amazing feature. And of course, when it comes to working with this snapshot here, you can also use this selector tool, which I showed you earlier in the course already, to find fitting unique selectors for the various elements that make up your page at a specific point of time. Once you used that tool to click on an element here, you can also conveniently copy that command here, which selects that element. So that's all very convenient. But that's still not all you're getting. So this Cypress Studio app here is a very useful tool. But you will not always use this tool. You will very likely use it when you're working on your tests, when you're just writing your tests. But once you have your tests written and you're not adding new tests, but let's say you're working on your main application source code. So once you're not actively working on your tests, you might still want to run them to verify that you haven't accidentally broken your application with your latest changes, but you might not be interested in starting this Cypress Studio thing and diving into all the tests there, because of course this is some extra work you have to do. That's why you're not limited to using this Cypress Studio app. You can always quit this npx cypress open process or not start it to begin with, and instead run npx cypress run. So run instead of open. Where open opens that Cypress Studio, run simply executes your tests in a so-called headless mode, so behind the scenes, using the browser behind the scenes, but without you diving into Cypress Studio. And you then also get a summary output of all these test runs. You see for which file, how many tests were executed, and how many of these tests passed or failed. And if you got failing tests, it actually also takes screenshots of the tests that failed, or of the app as it looked when a test failed. It takes screenshots of that to help you debug your tests even if you did not see them run interactively. And it even takes videos, one for every spec file, so one for every testing file that you have, where you can basically see your tests being executed, even though Cypress Studio was not running. That's really important to keep in mind. Cypress Studio was not running. It ran everything behind the scenes, and yet it recorded these videos that help you debug your tests in case they failed. And it even creates that video if the tests succeeded, by the way, so that you can still take a look at those test runs and see what happened, even though you ran it behind the scenes. And this behind the scenes mode is of course very useful for running your tests quickly without having to dive into that full Cypress Studio app, which is great for when you are working on your tests, but not necessarily what you want to use when you're working on the main application and you just want to verify that everything still works. Now, in the previous lecture, I showed you Cypress Run and that it automatically creates videos and screenshots, which is great for understanding why tests failed. But you actually might wonder why I had a test failure there, since all the tests did work just fine when using Cypress Open. Now, that is something which unfortunately sometimes occurs when using Cypress, that you do write valid tests that work when using Cypress Open, so when using this Cypress Studio, but fail when using Cypress Run. For that reason, you should always try both. Cypress Open for developing your tests and then also Cypress Run. Now here it's actually quite good that we ran into this problem because it A, allows me to show you that this can sometimes occur, and B, it allows me to show you what you can do in such situations. Now, if you have that problem that your tests behave differently when running them with Cypress Run than they do with Cypress Open, in my experience, it's easiest if you simply come up with a different way of writing your assertion or selecting elements. For example, here, instead of selecting the message input and then the parent with the parent method, you could instead add a data-cy attribute to that parent element which we're trying to select to have a unique selector for that. Because sometimes when running Cypress in this headless mode, it fails because certain elements can't be selected successfully. Using a unique selector like this can then therefore often fix this problem, and you can of course add this custom data-cy attribute to any HTML element of your choice. So that's often a good solution. Now here, at least for me, it wouldn't fix the problem though. Instead, the problem here is that I'm using then, and here for this application, where I'm dynamically setting the class of this parent based on the validity of the text area, then fails to give me that element correctly, and therefore this test fails. Now that allows me to show you an alternative way of asserting whether we have a class that contains the word invalid on that wrapper around the message input. Instead of using then here, which worked fine in the open mode, but not when running the tests with Cypress Run, we can use the good old should method again, which I personally also recommend to use whenever possible, because in my experience it's more stable than using then and diving into an element. And we can indeed use should here as well. Remember, we're interested in finding out whether the class added to this wrapper around message input contains the word invalid. To find out whether that's the case, we can first of all validate that we have a class. So we can say should have attribute class. That's how we can write it. You can check whether an attribute exists by using have attr as a first argument for should. And then the second argument is that attribute you're looking for. We actually did this before with disabled. Here not with should, but with expect. But here I did it with should. Now I'm doing it with class here. Now that's not all, of course, though. I don't just want to check whether we have a class. I want to check whether it's the correct class. And therefore we can chain another should here. Or use end so that this reads more like an English sentence, but as you learned, end is just an alias for should. And the cool thing here is, and that's the new part here, that should also returns something. It returns a value that makes sense for the assertion you ran before. For example, here, when you're looking for an attribute, for the existence of an attribute, the next should or end in line receives that attribute automatically. So here we can then, for example, check whether it's equal to some text, like invalid. That, however, would look for exact equality of the class that's being added to this parent. So now the test would only succeed if a CSS class named invalid is added to this parent here, which will not be the case. Therefore, a better alternative that should work is to use match. Match allows you to use a regular expression here, created with 2 forward slashes. And here we don't need a fancy complex regular expression. Instead, we can just type invalid here. And with that, this assertion will pass if we have a class on this parent that contains the word invalid. It may contain more characters before and after the word invalid, but it must include the word invalid in the classes that are added to this parent. We can then, of course, repeat this for all our other inputs here as well, and switch to this should-based approach where we use these connected should methods, use the fact that the first should method passes a value to the second. Cypress does that automatically as explained, and therefore in the second should, or end in this case, we can evaluate the value produced by the first should. Now, of course, it depends on what you're checking. It depends on your assertions, which values are passed to the next assertion in line. Indeed, for most cases, as you find in the official docs, should yields the same subject it was given. So in most cases, the next should in line still refers to the element or whatever you selected before. But in some scenarios, as mentioned here in the official docs, you get a different subject. And have attribute is one of the most prominent examples where the subject indeed does change, and the next should in line receives the value of the attribute instead of the original element. Now, with those changes made, if you now rerun Cypress run, these tests should now all succeed. And they do, because now we're using a different way of asserting this. And as mentioned, sometimes you can have that problem that Cypress run does not replicate what you saw in Cypress open, and changing your selectors or assertions is then typically what you want to do to work around that behavior and that bug. Now, last but not least, related to what you saw in the previous lectures, it's also worth noting that inside of your Cypress tests, you can also tell Cypress to take screenshots at specific points of time. Now, it does take videos automatically when you're using Cypress run, and it creates screenshots for any tests that fail to show you what failed, which step failed, but you can also explicitly tell Cypress to take a screenshot at a certain point of time, no matter if the test failed or not. For example, here, when submitting the form, we might want to take a screenshot right before we submit that form. So right before we hit enter here. And therefore, before we reach that part, we can use the CY object and then the screenshot method to take a screenshot. And then maybe take another screenshot thereafter. And if we do that, and we run npx cypress run, we again run all these tests as you would expect, but these screenshots are created as part of the test runs. And you find them in the Cypress folder, and they are in the screen. Kind of related to then and multiple shoulds, there also is another way of using should that can help you work with the element, take a closer look at the element you want to assert without using then. But also without using multiple shoulds, where you then need to know which should yields which value to the next should in line. And this alternative syntax I'm referring to is a syntax where you pass a function to should, for example, an anonymous arrow function, just as you could pass an anonymous arrow function to then. And here you then also receive the subject should refers to. So in this case here, for example, L would refer to this parent element of this element. So you get the subject to which should refers, in this case this parent, as a value automatically passed into this anonymous function by Cypress. And inside of this function, which is passed to should here, you can again run any assertions you want, but again using expect instead of should. So this function which you pass to should works basically the way this function you passed to then worked, though there are some technical differences. But when it comes to writing assertions, it works in the same way. L is the same as it was inside of the then function, but here we should not run into the problem of our test failing when we use should instead of then with this function passed here. And then therefore here I could again take a look at the attribute, the class attribute of L, and then say that this should contain invalid or contains. These are basically aliases. And I could also omit the two here. There are simply different ways of writing this. I could have done the same before with then. In the end, the goal always is that this kind of reads like an English sentence. But with that, I now have an alternative way of running my assertion here. And you could, as mentioned, have multiple assertions here. For example, also simply check that class is not undefined so that it exists. And with that, you simply have yet another way of writing your assertions. And of course, it comes down to your personal preferences, which approach you prefer. As you see, if I run Cypress run here again with this alternative syntax, my tests still all pass. So I'm not running into the problems I encountered before when using then. Should is a bit more stable here because, as mentioned, there are technical differences, and this therefore simply is yet another way of writing this. It's up to you what you prefer. I personally also try to avoid this syntax, though there's technically nothing wrong with it, but I personally prefer chaining multiple shoulds after each other, but that is also something you'll encounter quite a bit in the official docs, in other examples, in other projects, and therefore you should know this syntax, this way of writing your assertions and diving into should as well. And that's it for this course section. In this course section, we took a closer look at element selection. You learned that you can and typically should use custom attributes, specifically the data-cy attribute, which you can add to any HTML element to have unique selectors for the elements you want to use in your tests. Using such test-specific custom attributes as selectors in your tests simply is less error-prone than other selectors. With those test-specific selectors, DOM and HTML structure changes or CSS class name changes don't suddenly break your tests unexpectedly. Of course, if you would have a test that does require a specific class name on a specific element, you might want to stick to that class name as a selector. But in many cases, using these test-specific selectors is preferable. What's also preferable is the usage of aliases if you're reusing certain values in your tests. It's not a must-do. You can also simply duplicate your code. But if you have, for example, one and the same element that you're using in different parts of your test, you could store it as an alias and then reuse those query results where you're querying for that element by using that alias. You create an alias with the as method and you use it with the get method by looking for at and then the name of your alias. Now in this section, you also learned about a different way of getting access to elements. You can, of course, use get and should, and that indeed is the approach I personally prefer and would recommend. But you can also get more direct element access by using the then method after running a query. So for example, after using get. Then receives a function which automatically gets the element for which you were looking, for example, by Cypress. And then you got more methods and properties you can access on that subject, as it's called. You saw a couple of examples throughout this course section, but as mentioned, I personally prefer to not use then if I don't absolutely have to, or if it not vastly simplifies the assertion I want to make. And speaking of assertions, if you are using then, you typically need to use expect inside of that then block instead of should, because that value, that element that's passed to this then function by Cypress doesn't have this should method. Instead, you have to use this alternative syntax, and as you also saw in this section here, this can then sometimes lead to problems if you are running your tests with Cypress run instead of Cypress open, though of course typically you should not face such problems. Nonetheless, you often can access values and write assertions without using then and expect, because as you also saw in this section, should also sometimes yields a new subject. Typically, multiple chained shoulds all refer to the original subject, for example, to the original element. But if you are, for example, using should to check for a specific attribute, like the class attribute, a chained should thereafter would receive the value of that attribute and would allow you to then run a check on that value, which can of course also be useful. Now, and besides all these things, you of course also learned a bit more about the Cypress Studio app, that you can run tests without using that app. And you're now not just well prepared to start writing your own tests in your own projects, but you're also ready to dive a bit deeper into more advanced Cypress topics.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Now that we got a solid Cypress foundation and we understand how we can select elements and write assertions, and before we dive into more advanced topics, it's time to take a closer look at test organization, project and test configuration, and how we can write tests efficiently. Because that's of course crucial. You don't want to unnecessarily repeat certain steps or not be aware of settings that you might need for your projects. Therefore, in this course section, you will learn how you can configure your Cypress projects, and we'll take a look at some key configuration settings that you might want to tweak for your project. We'll then take a look at how we can share logic across tests, how we can have a shared setup step in front of all our tests, and why we might need that. And we'll take a look at an amazing Cypress feature that allows us to write and add our own custom commands and queries that we then can use inside of our tests. Now for this section, I'm using the project we worked on in the previous section, and we're not going to write a lot of tests in this section. Instead, we're going to refactor the tests we wrote thus far, and we'll explore some general configuration items. You find my latest project snapshot attached, and if you do download that snapshot, you should first of all run npm install to install all dependencies. Before then, thereafter, you can again run the development server with npm run dev and run the tests with npx cypress open or cypress run as you learned. Here, I'll just quickly run all tests so that you see that they initially pass. But then we're going to dive a bit deeper into the various configuration options Cypress gives us. So how can we configure our Cypress tests, and why would we want to configure anything? Well, let's start with the where. The main part where you can configure your Cypress tests is this cypress.config.js file, which you find in your project folder after adding Cypress to the project. This file by default should export the result of calling defineConfig, which is a function imported from Cypress, and to this defineConfig function, an object is passed where you can set various settings. For example, here If you place your cursor in there and you open the auto completion in your favorite IDE, you see a long list of settings you can add here. But of course, as so often, in many scenarios, you are probably fine with the default settings. Nonetheless, there are many settings you can set. And of course, as always, the official documentation gives you an overview of all these settings in case you want to dive into all of them and learn in detail what they do, which I would not recommend because, as mentioned, typically the default settings are fine. However, you can set things like, for example, control whether a video should be created when you run your tests with Cypress Run. Related to video, you can also choose in which folder it will be stored or how it should be compressed. You can, for example, also set the screenshot on run failure setting here to control whether screenshots should be created and saved when your test runs fail. So these are some examples for settings you can set here. But you also have settings related to timeouts, and those settings are worth a closer look. So what are these timeout settings all about? Well, Cypress, when running your tests, goes through a bunch of steps, a bunch of instructions which you give Cypress. And what's really important to understand and keep in mind is that for pretty much all these commands that you issue, Cypress waits for a certain time frame for that command to succeed before it marks the test as failed. For example, when getting an element with this selector here, so when running this command here, Cypress will not fail immediately if the element is not found immediately. Instead, it will look for this element for a certain time frame and only fail thereafter. The idea behind this feature is that, of course, often you have the situation where the UI is updated when certain things change. For example, when submitting the form and running this test, our button caption changes as we submit the form. Now, whilst this UI update, of course, looks instant to the user, it technically might not be done 1 millisecond after submitting the form. Now, of course, Cypress executes all these steps after each other, basically instantly after each other. Therefore, it could fail because it does not find this text on the button right after the form is submitted, because maybe that text only shows up after 10 milliseconds instead of instantly. That's why Cypress retries queries like that within that 4-second time frame until it finds that text or that element or whatever you're looking for, and it only fails after these 4 seconds passed, so that a test does not fail just because the UI update was not quick enough. That's the idea behind these timeouts, and you can set these timeouts in the setting file. If you type time here, you see all these timeout related settings, and for example, it's the default command timeout that's by default set to 4 seconds, as you can see here, which you could increase to 10 seconds if you needed that for your tests. Of course, you should not do that if you don't have a need for it, but it can sometimes be useful. Now, these other timeouts are, for example, related to requests that you might be sending as part of your Cypress tests, something we'll take a look at later, or related to page navigation actions, for example, when using the back button, how long Cypress should wait until the previous page is loaded until it marks a test as failed or a success. So these are these different timeouts, and it's important to understand why they exist and that you could change them here if you needed to. Now, whilst you can change various settings in this global config file, that's indeed not the only place where settings can be changed. Sometimes you want to change a certain setting only for one test or for one suite of tests. For example, here, maybe we want to have a different timeout for all our contact form related tests, but not for the navigation tests. So we might not want to change the overall setting here in the overall config file, but instead just override some setting for these contact form tests. This can be done by passing an object as a second argument to the describe function, and that function as a third argument thereafter. And this second argument is now also a configuration object where you can set many of the settings you also could have set globally. For example, that default command timeout. And you can not just do this on suite level here, you can also do it on test level. If only that test should have a deviating configuration, you can give this test this second argument configuration object here. And then, for example, set the default command timeout to 10 seconds for this second test only. So you can override settings on a per test or per suite basis as well, not just on a global level. Now, being able to override settings on a suite or test level is very useful. It's also worth knowing that you can, for example, also change the browser in which a certain test should be simulated. You can, for example, set this to Firefox, if you have Firefox installed on your system, to force Cypress to run this test in Firefox, even if all the other tests would be executed in Chrome or Electron. Now keep in mind that you can choose which browser to use when using npx Cypress open. There you can choose between Electron or Chrome. And when using npx Cypress run, you can set the browser by adding -- browser and then setting this to Chrome or Firefox, for example. But if you don't want to configure your browser like this, or if you need to use a different browser for a specific test, then you could indeed do this with this configuration item as well. And that's also just something I wanted to point out here. Now, one setting which you're probably going to add to almost all your Cypress projects is the base URL setting, and typically you set this globally. In this global config object, you can set the base URL setting, however not right here, but instead inside of this E2E sub setting, because there are certain settings that only apply to end-to-end tests. Now keep in mind that Cypress also could be used for component testing, even though that's not the focus of this course, but you could do that with Cypress, but certain settings only make sense for end-to-end testing. And therefore, for this end-to-end testing specific object here, you can, for example, set the base URL. And with that base URL setting, you can define the, base URL Cypress should use when visiting a page. So that instead of typing the full URL every time you call visit, you can just focus on the path of that URL you want to visit for that test. So here, for example, we could grab that URL of our development server and set this as a global base URL, like this. Now with that added here, Cypress would always use this URL when you're calling visit in your code. Therefore, you can now just call visit/about, and behind the scenes, Cypress will build this URL. So that happens behind the scenes because of this base URL setting. And that of course means that you have less work to do in your tests, less typing to do, and if your URL ever should change, you only need to change it in one place instead of in all your tests. So therefore here, I'm now going to adjust this, and I'll switch this to just/about in this second test as well. And for my navigation.cy.js file, I will also get rid of this URL and just visit/nothing, which is my homepage. And just to prove that this still works, if I now run npx cypress run with my development server up and running, all these tests are still executed and still finish successfully because this global base URL is now being used by Cypress. Now this base URL setting is a crucial setting because it makes the process of writing tests more efficient for us because we don't always have to repeat that URL. But we can get even more efficient. You might notice, for example, that in contact.cy.js we repeat this step of visiting the about page in all our tests. Of course, here we only have 2 tests, but it's not uncommon to have like 5 or 6, or maybe even a couple of dozens of tests in one single test suite or file. And those tests might all be happening on the same page, and you would therefore always repeat that visit instruction. Because it's quite common for your tests to have some common initialization work, like visiting this about page before the actual test logic runs, Cypress gives you various hooks, which you also might know from other testing frameworks or from unit testing. Cypress, for example, gives you the very important before each hook. Before each is a function that can be executed in your test file or in your test suite like this. And you pass a function to before each, and this function will now be executed by Cypress automatically before every test in that suite or file, depending on where you defined before each. So now here it would run before every test inside of that suite. And for example, here we could visit /about. And we can remove this code from the actual test. And of course, not just from this first test, but also from the second test. So now we outsourced this general initialization step that we want to perform before every step in this file and suite into this shared before each hook, which as mentioned is executed before every test. So therefore with that, we still visit this page in every test in here, but we don't have to repeat this code in every test function. Just to quickly show this to you, if I run npx cypress run here, all my tests again will run successfully because I still visit the about page, but now without duplicating that code. And therefore before each is a very important hook that can be used to do shared initialization work, like visiting a page. That's a common scenario. But you could also be doing other things in here, like seeding a database or doing any other kind of initialization work that should be done again and again before every test that's being executed. Now, Cypress does not just give you before each, it also gives you before. The difference is that before will run before all tests, so not before every test, but only once before all the tests in that suite or file are executed. So this runs only once before all tests. Before each, on the other hand, runs before every test, i.e., it's repeated. And just as you have before and before each, you also have after each and after. And you might be able to guess what these hooks do. You pass functions to after each and after as well, just as you did for before each and before. And after each runs after every test, and after, of course, runs after all tests, i.e., only once. You could use after each and after for cleanup work, but that's actually not recommended by Cypress. Instead, you should do all initialization work, including any cleanup work that might be needed inside of before and before each, to really make sure that before a test is run, it has exactly the environment that it needs to run successfully. So whilst you could use after each and after, it's far more common and recommended to use before each and before, and the most important hook is definitely before each, because it's very common that you have some setup work, like visiting a certain page, that should be repeated before every test, and not just once. When it comes to avoiding code repetition and writing more efficient tests, there also are two other very important Cypress features that you should consider using. And that would be custom commands and custom queries, which are two closely related features. Custom commands are in the end reusable shortcuts to more complex command chains you might have written in your tests otherwise. For example, you could create a custom submit form command, which internally then selects a submit button in a form and clicks it, so that you don't have to repeat this kind of code over and over again in your tests, and will create and use this exact custom command in the next lecture. A custom query, on the other hand, would be a synchronous chainable retryable command, a special form of command you could say, which is written in a slightly different way, as you will also see in the next course lecture. And here the example could be a custom getById command, which simply selects an element by this data-cy attribute so that in your main testing code, you don't have to repeat this kind of selection code over and over again. So the idea really is that you can outsource common steps or common command chains or selectors into your custom commands and queries to keep your actual test code leaner. So custom commands and queries hopefully sound useful, but it might not be entirely clear how they work. So let me give you an example. Here in this should submit the form test, we are submitting the form by hitting enter after entering this email address. And that's of course a fine way of submitting this. However, an alternative way would have been to get access to the submit button, for example by using this code here, which uses this data-cy attribute that was added to the submit button, and then clicking this button. Now, it would not be unreasonable to assume that the submit button does not have such a data-cy attribute though. Of course, you could add it in your source code, but for the submit button of a form, it would also be okay to, for example, select it like this, looking for a button that has the type submit. Possibly a button inside of a form, or maybe a form with a specific ID or data-cy attribute. That would be a valid way of selecting a submit button, because inside of a form you typically only have one submit button. Therefore, it would just be about selecting the form in a unique way. But let's assume that for this app, this way of selecting the submit button is fine. Now, if we do submit the form in different places, which indeed we do, we also submit the form in our second test here. Here, I select the submit button and click it. So if we repeat that process of getting hold of our submit button and clicking it in multiple tests, we could put that into a custom command so that we don't have to repeat this code over and over again. And to do that, we can copy this code, which we want to put into a custom command, and then go to our Cypress folder in the project, and there the support folder, and there the commands.js folder. And this is the file where you add your custom commands and queries. To add a new command, you use the Cypress object, which is available globally. And on that object, you can access commands and then add. Add is a method, and the first argument for this method is the command name you want to assign to your command. For example, submit form. And if you're adding a new command, this of course should be a name that does not exist yet. The autocompletion here should tell you which commands exist already. For example, it suggests visit, so this already exists, but submit form is not suggested, so this also doesn't exist yet. Now, of course, with this alone, we haven't yet added a command. Instead, the second argument is also important here, because that's the function that should be invoked by Cypress when you use that custom command in your test code. Now, this function may take any arguments your custom command needs, and you can pass those arguments when calling your custom command later. But here I don't need any arguments. And inside of this function body, you then write your custom command code. For example, here I paste in that code which I copied, where I get my submit button like this and click it. And this here is exactly the same code we could have written in our test function. But now we created a reusable command, and we can now use this command in our tests. So here my command is called submit form. So once I save that file, I can go back to the files where my test code resides. And here, instead of selecting my submit button like this and clicking it and repeating that code, I can simply call cy submit form. Now, it's not being suggested here to me, but I can call it because it is a command that I registered here. So with that, if I save this and I run Cypress open or Cypress run again, doesn't matter. This test still runs successfully. It still passes. Now with my custom command being used. And we could now use that same command in the second test, where we also select that button and submit the form. This test then also still passes. Now, when learning about custom commands for the first time, it might seem like a feature you should use a lot and you should put everything into a custom command, because you are, of course, typically repeating a lot of steps. But you should be careful with that. It's actually considered a bad practice to put everything into a custom command, because of course it also makes your tests less readable. We might be able to guess what submit form does, but it's not 100% clear. We have to dive into that custom command file to really understand what it does. So that's why you should not create a custom command for everything, but only for selected use cases where you have a certain step that's really repeated quite a bit, that maybe even includes more complex logic, so that's not as simple as this example, and where your custom command name then is pretty clear about what it's doing. In such situations, creating a custom command can save you a lot of time, but you should not start creating custom commands for everything. So that were custom commands. As mentioned, we also have custom queries, and I have a great example here. Selecting elements by this data-cy value. We have a lot of repetition here, where we select a lot of elements always in exactly the same way, just with different values for this data-cy attribute. But we always repeat this entire attribute selector syntax here. Now that could be a great use case for creating a custom query. Now you do also create custom queries in this commands.js file. In there, you still use cypress.commands, but then instead of add, you use add query. Now a query is like a command, but one core difference is that it's a retryable function that can be retried by Cypress, whilst it's, for example, waiting for the visibility of a certain element. So here we could add a custom query called getById. The name is up to you. And again, that first argument is the name of that query, just as the first argument for add was the name of the command. And the second argument then also is a function, just as with a custom command. However, this function, and that's now the new part, should then also return a function. So we have a function that returns a function as the second argument for add query. Now this inner function which is being returned here will be the function that's retried by Cypress within that 4-second time frame. It's, for example, here inside this inner function where we want to return the result of calling cy get, and then here, in this case, for example, looking for an element with the data-cy attribute and then a certain ID. Now the idea behind my custom query here is that this concrete ID value is dynamic. I expect to get it as an argument on this query when it's being used in the testing code. So here I am accepting a custom argument, and this can now be used in here. So I'll actually turn this into a template literal so that I can easily inject a value here. And in my case, that's this ID using this default JavaScript syntax. And with that, I'm using the built-in get method to look for an element that has the data-cy attribute with this ID value, which is dynamic and which will be different every time this query is called in different places of my testing code. And this command is then returned. It's very important that this return statement is inside of this return function because, as mentioned before, it's this returned function that's retried by Cypress when my custom query is executed in the code. This then also makes sure that I can use my custom query in my code just as I can use the built-in get method, for example. I can chain it and it will automatically be retried by Cypress until the element is found or those 4 seconds or whichever timeout you set are over. And with that, we can use this getById method here. Instead of always typing all this code here, we can, for example, use getById and then just pass that ID as a value to that query. And this could now be repeated in all the places where we are querying by data CY attribute. We can simplify the code in all those places. Now here I'm just doing it in 3 places to not waste your time, but you could of course change this in all the places where data CY is queried. Now when trying to run this code with Cypress open or Cypress run, you would get an error though. It would fail, the custom query would fail. And the reason for that failure is that you must not forget that calling get like this or any other Cypress command like this in the end just creates a step, an instruction that's scheduled or queued by Cypress. And the idea behind a custom query is not that you return an instruction or a step. Instead, what we want to do here is we want to immediately execute this, get hold of that element, and then return that element by our query so that our query itself becomes a command that can be queued by Cypress. To do that, we have to go to the part before this return function, so inside of the function passed to add query, but outside of this inner function. And here we can call a special Cypress method, the now method. Now simply allows you to execute any Cypress method instantly instead of just creating an instruction that's queued. And this now method is meant to be used in situations like this when creating a custom query. You should not use it in your test code. There you should use get and so on or your custom query, but not now. But here in this code where we prepare a custom query, we can now pass the name of the Cypress method that should be executed immediately, in this case get, as a first argument. Then the argument we would have passed to this method as a second argument. So here this is the argument we would have passed to get. Therefore it's the second argument to now, the argument that should be passed to get now that get is being executed immediately. And now by doing that, what we get as a return value from now is a function, a get function in this case, since we want to call get immediately, which then can be executed in this inner function. And this get function is now the actual function that will be executed immediately when this code runs, which, since we do this in the inner function, will only be the case when our query is executed by Cypress. So now gives us a function that's prepared for immediate execution, and it's this function that's stored in getFN. And I then call this function in this inner function, which, however, will only be executed by Cypress when our custom query runs. I know this can be tricky to wrap your head around, but in the end, it's all about preparing a command for future execution in our custom query. So what we get as a result here is then the element that's found by this get command for this selector, and it's this element that should now be returned by this inner function. Of course, we could also shorten this and just call get function here and return its return value as part of this inner function. So this is how you can write a custom query using a built-in function that is prepared for immediate execution and that is then executed inside of this inner function. And with that, you still use your custom query, get by ID in this case, as I showed it to you in your code, like this. But now with all the files saved, you see that you will be able to run this with Cypress run or Cypress open. And the tests will all pass, but now this time using a custom query. However, just as with custom commands, the idea behind a custom query is not that you put all your logic into custom queries. It's perfect for situations like this, for this data-cy selector, where you don't want to repeat this entire attribute selector code over and over again. It's perfect for situations like this. But you should not start putting all your logic in these custom queries for the same reason that applied to not putting everything into custom commands. Custom commands and queries can be very useful for outsourcing repeated steps or repeated combinations of commands or queries into your own custom commands or queries. As mentioned, you should not overuse this feature though. Now another Cypress feature that can sometimes be useful is the task method offered by Cypress. The task method allows you to run predefined tasks at any point of time in your tests or also as part of your hooks. So for example, before each test. But what is a predefined task? Well, you can predefine tasks in your Cypress config.js file under this setup node events method that is registered under this E2E key in this config object. Now this setup node events method here allows you to call a on function inside of it, which in the end allows you to listen certain events that are generated by Cypress. And one very important event is the task event. Now there also are other events, like for example after running all your tests, running a single test, right before running a test, and so on. And the idea behind those event listeners which you can add here in this config file is that here you can listen to certain events and then you can run code that runs outside of the browser. Any code you write as part of your tests or in your custom commands or as part of these hooks runs inside of the browser when Cypress runs your tests. And since it tests your app in a browser, all this code runs in a browser. If you have code that should run outside of a browser, maybe because you're using some Node.js features that are simply not supported in a browser, you have to add that code here in setup node events, so that you can listen to a certain event and then run your code when that event occurs. For example, you can listen to the task event, and this event will be triggered by Cypress whenever the task method is called in one of your tests. So calling task in a test or in one of these hooks here, before each and so on, will trigger this event listener here in setup node events in your config file. Now when listening to the task event, you can pass a second argument to on, which is an object, where you can specify which code should run for which task. So in the end here, you can register your own tasks, like seed database, but this name is totally up to you. It could be seed database, it could be db:/seed, whatever you want. Any valid JavaScript property name can be used here. And here I'll go for seed database. And then inside of this method here, which is added to this object, which is added to this task event listener, you can run your Node.js code. For example, you can edit a file here, make an HTTP request, run some SQL queries, do whatever you want to do. This code will not run in the browser, it will run outside of the browser, but it's triggered from inside your tests. For example, to run this seed database task here, we would call this task method in our testing code. And then to this method, we pass an argument, a string, with the name of the task we want to execute. So the name I just registered here in this object that was passed as a second argument to this on function. By naming this seed database here, and then passing seed database to the task method, this code in here will execute when task is called like this in our code. Now you could also pass some extra arguments here, like for example some file name, and those arguments would then be received in this method here. So here we would now also get that file name, and we could then use it inside of this code. Of course you don't have to accept parameters here, but you can. You can also return values here, like for example here, just the file name again, which of course is some dummy code, but just to show you that you could return something here. And that return value could then be accessed with help of the then method. So here we would have our return value, which we then could use inside of here. And this task feature can be a very useful feature, especially when it comes to things like storing some data in a file, preparing a database for our testing environment. Then being able to run tasks like this with help of the task method and registering them here can be very useful. And that's it for discourse section. In this section, we learned that you can configure Cypress. You can do this on a global level or also locally, test or suite specific. And the idea here is that you can, for example, override the default timeout values, choose which browser should be used for which test, set the base URL, and many other settings, though as mentioned, of course, the default settings are often just what you need. But it's of course good to know that you can tweak those settings if you do need to tweak them. Another very useful feature offered by Cypress, which you might know from other testing frameworks or testing environments, are hooks, like before each, after, and after each. The idea here is that you can put shared logic that maybe should run before every test into one of these hooks, into the before each hook, for example, so that you can prepare all your tests in one central place or perform test cleanup. Though speaking of test cleanup, as mentioned in this section, it's recommended that you avoid the after and after each hooks and instead you use before and before each to prepare the testing environment exactly as it's needed right before every test. Another very useful feature would be custom commands and queries. The idea behind these features is that you can outsource and easily reuse shared logic or common command combinations that you might be using in a lot of different places in your test files. Like in the examples I showed you in this course section, though also as mentioned there, you shouldn't overuse these features because it can make your tests less readable, and in the worst case scenario, you have a totally bloated commands file which is totally not understandable and manageable, whilst at the same time having super unreadable tests, which is definitely not what you want. But when used carefully, these can be useful features that lead to leaner testing code. And last but not least, you learned about tasks. This is a feature which can sound similar to custom commands and queries, but the idea is a totally different one. Tasks are all about running code that should run outside of the browser, so that's triggered from inside your tests, but does not run in the browser. Here you can, for example, do things like work with the file system, seed the database, send some HTTP requests that are not directly related to your tests. And therefore this can be another very useful feature for performing certain tasks that must be performed, but that can't be done from right inside your testing functions. Up to this point in the course, we had fairly basic websites and therefore also fairly basic. Now, as always, for this course section, I prepared a brand new starting project, which you find attached, of course. As always, you must run npm install after downloading that project. And then once you did that, you can run npm run dev to view this website. And this website is all about getting a user's name, location, fetched from inside the browser, for which you need to grant permission. And then once that location has been fetched and a name has been entered, this website behind the scenes creates a shareable link, which then can be copied to the clipboard and which can be used to load this location on a map, here using Bing Maps. And this URL here at the top is generated dynamically and is copied to the clipboard by this website here. So even though this website doesn't have any other pages than this main page and doesn't have a lot of UI elements, it definitely does have some complexity, especially when it comes to writing automated tests, because fetching a user's location, copying data to a clipboard definitely works when using a website as a user, but using these features in automated tests will be a different story, as you will see throughout this section. Now, in order to write tests for this application, we of course need Cypress, and I did already add it to this starting project, which you found attached in the previous lecture. And therefore, of course, after running npm install, you can run npx cypress open and then run the tests in this location.cy.js file, which at the moment are basically no tests. I mean, there is one test, but it doesn't do anything, because we're going to fill this test with live together, and we're going to explore how we can simulate things like fetching a user's location in automated end-to-end tests. So let's get started with this first test here. The goal here in this test is to fetch a user's location. Now for that, if I reload this website, we have this get location button. When we click this button, we have a spinner here and the location is fetched behind the scenes by the browser. When you visit this site for the first time and you click this button for the first time, the browser also asks you for permission to do that. Thereafter, it uses that permission, though you could of course always revoke it if you wanted to. But that's how it works here. How can we simulate this in our test here? Well, if we take a look at the developer tools or the source code, we see that in the end, it is this button here, this get location button, that is clicked. And this button indeed does have a data-cy attribute added to it so that we can conveniently select our button with help of this special attribute in our tests. Because as you learned in the previous course sections, you want to use this special attribute in most cases at least, because this attribute was added to this element to be used in tests. It has no other purpose. And if we would, for example, select this button by this ID or by its CSS class, that class or even the ID text might change because we make changes to the application. This test-specific ID is not likely to change because it has no other purpose than being used in a test. So all that being said, it is this button which we want to select. So of course we can select it by this attribute here in our test file with the good old cyget method here, and then this attribute selector syntax selecting by that attribute and value. And then we can of course simulate a click on that button with the click method. Of course, what we also need to do is visit this page before we can click anything, and therefore we should call cyvisit / and we only need / here because in the Cypress config I set this base URL to this development server domain. If you are running the development server on a different port, if you do have a different port here in the browser when viewing this site, then you should of course adjust this port here in this setting. However, this is the default port that's used by this project, and therefore this should work. And with that, we're visiting the site, and if we now save everything, this test passes because indeed we can visit the site and click this button. However, if you block the permission to fetch the location here, for example, you will notice that the test still passes because all we're testing is that we can find and click this button. But at the end, once the test is done, after the button was clicked, you will notice that we get this error overlay here, which tells us that we do not have sufficient permissions to fetch the location. Now, of course, I could simply grant this browser window where our tests run the permissions to fetch this location, but we would definitely face a problem when we later run our tests with Cypress run instead of Cypress open. Because when running these automated tests, Cypress of course simulates them in a browser, but it's not an actual user. So getting the location of a user or asking a user for permission to get their location will simply fail or not yield the expected results because there is no user when running these automated tests. And that's a problem we'll face here for this web application when trying to test it with Cypress without making any changes first, which we of course will do throughout this section though. So here in this test, we can't really test whether we successfully fetch the user's location because it's not likely to work when our tests run in an automated way. And it's exactly this kind of problem that can be solved with stubs. In this section, as mentioned, you will learn about spies and stubs, but we will start with stubs. When dealing with automated tests, stubs are simply replacements for existing functions or methods. And you use them for evaluating and controlling function or method calls. So with stubs, you simply replace existing functions or methods so that they don't do what they would normally do, but they instead do what you want to simulate in your testing environment. So now with this new knowledge about stubs in mind, it makes a lot of sense to use a stub for this test here. Because we in the end want to replace the built-in fetch a user's location functionality that's offered by a browser with our own test-specific functionality where we simulate getting a user's location. Now, if you take a look at the source code of this application, you will see that in there, in the end, a user's location is fetched with help of this navigator geolocation get current position method, which again is a method and a feature built into modern browsers. So this is not something written by me or anything like that. Instead, this get current position and this geolocation object on the navigator object is all coming from the browser. And it is in the end this method, this get current position method, that we want to override for this testing environment so that we don't actually ask for permission and try to get a user's location, but that we instead simulate getting a user's location and we return some dummy location which then can be used in the test, so that we can then thereafter test whether the rest of our application works as expected. Because that's also very important. When writing your tests, you want to test your code, your application. You don't want to test whether browsers are able to fetch a user's location. It's the job of the browser vendors, of the teams that work on those browsers, to ensure and test that their browsers work correctly. So you don't want to test whether the browser does its job correctly. You want to test whether your application uses the data yielded by the browser correctly. And that's why we want to replace this method that's built into the browser so that we have some dummy data that we can use to test the rest of our application. So therefore, we want to replace this navigator geolocation get current position method. We want to do this in our test, and we can do this with help of a method provided by Cypress, a method that's also offered on this CY object, and that would be the stub method. Now, stub typically takes two arguments. The first argument points at the object that contains the method you want to replace. In my case, that's navigator.geolocation. However, this actually is accessed on the window object, so it's window.navigator.geolocation. The second argument passed to stub then is the name of the method you want to replace as a string. So here, get current position as a string. This code would already replace get current position with an empty function that does nothing. Now later we'll change this. Later we want to do something, just not what the browser does, but something else. But for the moment, even this empty function is better than the default function, because the default, which is all about getting a user's permission to fetch the user's location, wouldn't work when running these tests in an automated way, as mentioned before. So this empty function, which we use to replace get current position, is already a good start. However, we have to restructure this. Calling stub like this here will not have the intended result. If you save this, you will see that the test passes, but it will actually not replace this method correctly. Because this window object, which is built into the browser and made available by the browser, is not available here when executing this code like this. Keep in mind that what we're doing here with Cypress is we're giving Cypress instructions, which it then queues up so that it creates a queue of to-do steps, and then those steps are executed at a later point of time. However, with this code here, I'm directly trying to access the window object when I give Cypress that instruction. At this point of time though, the tests are not running yet and the window object will not be available yet, or at least not the window object of the website I'm trying to test. So we have to move this to a different line, to a place where the window object will be available. And for that, we can use the then method, about which you already learned. You learned that then can be used to get more direct access to, for example, an element that's fetched with help of the get method. When using then after visit, we instead get the window object of the site we're visiting. This is simply how then works when used after visit. Visit yields the window object of the site that's visited, just as get yields the element that we got when using then. So here inside of then, we get this window object, and we can then call CY_step inside of this then block using this window object, which we got here as an argument for this function. And this is, by the way, something you can do. You can use this CY object and call your Cypress methods like get and all the other methods inside of then blocks. This is absolutely fine and absolutely something you may do. And here we're doing this to create our step with that window object of the site we're visiting. You can think of these instructions that you have inside of a then block as instructions that will still be queued by Cypress before it runs through all these steps, but it knows that when it runs through that step specifically here, it will depend on some data yielded by the previous step, by the visit step, and it is able to use that data then. And with this code alone, we already replace the default getCurrentPosition method offered by the browser with an empty function that does nothing. So now that we added this step here, we can go back to our regular instructions, and after clicking this button for getting a user's location, so this getLocation button here, we might want to assert that this getCurrentPosition has been called. That would be a check that makes a lot of sense. We want to make sure that our application, which we're testing here, calls the browser's built-in getCurrentPosition method whenever this getLocation button is clicked. Now, finding out whether this built-in method has been called or not is super simple now that we created our stub here. Because all we have to do is give this stub an alias with the as method so that we can refer to it later in our other steps. And here you can use any alias of your choice, like for example, getUserPosition. And then after clicking this button here, we can get our alias, getUserPosition, like this. And that's also worth noting. You can use the get method to get things by their aliases, even if those things are not DOM elements. Of course, thus far, we pretty much always used get to get access to DOM elements, either directly by using a selector like this attribute selector with the data_cy attribute here, or in conjunction with aliases to re-access elements we accessed earlier, which we then stored under an alias. But you can use get in conjunction with aliases to get access to any kind of data again, including stubs that you created earlier. Here we're assigning an alias to a stub, and we're then using get to get access to that stub by using that alias. And that's also a core mechanism of Cypress, that you can assign aliases to all kinds of data, not just to DOM elements, but also, for example, to stubs, and then use the get method to get access to that data again. So to that stub function, that stub method here in this case. So long story short, here we're using this getUserPosition alias to get access to this step again, and then we can chain the should method thereafter, which now will be applied to that stub therefore, to evaluate that stub, to evaluate that getCurrentPosition function that we replaced. And there are assertions that are specifically made for checking whether methods or functions have been called, with which arguments they have been called, and so on. So here, for example, the have been called assertion makes a lot of sense, because that assertion will pass if this function, so this stub function, which we used for replacing the built-in getCurrentPosition function, has been called. And on the other hand, it will make the test fail if this function has not been called. So if we save this all now and we rerun all tests, we can see that our test passed here. You now see this new section, Spies Stubs here, where you see that stub that we added, this stub that replaces getCurrentPosition. You see that it has been called once, and you therefore also see that this assertion at the bottom here passes, which is the assertion where we check whether getCurrentPosition has been called. And what's now really important to understand is that we replaced this built-in getCurrentPosition method with our own empty stub function here. But of course, our application code still called getCurrentPosition, just not the default built-in method offered by the browser, but instead our stub method. That is what was called by this line of code in our application code when running this code in this automated testing environment through Cypress. When you visit this website as a regular user, you're of course not using this stub method because you're not running Cypress here. You're just visiting this page. That's really important to understand, and that's the idea behind stubs and a first example for a stub. So we have our first stub here, and at the moment, as explained, we're just replacing the default getCurrentPosition method with an empty method. Now for this test, that is all we need. An empty method is all we need because we just need an empty method to find out whether it has been called, even if it then doesn't do anything, but it has been called, and that's the only thing we're checking here. Of course, however, when you're using this website and you click this button, a couple of other things happen as well. We get this spinner on the disabled button, and then after a few seconds, we get this location fetched text. And if our test here is about testing this fetch location functionality, we probably also want to ensure that the button is disabled whilst we are fetching the location, and that thereafter it shows us this location fetched text. So to test this, we can take a look at the source code or use the developer tools. And in the source code, we in the end find out that once a location has been fetched, at some point of time the clicked button is removed from the DOM, and instead a new text node is inserted in the place where the button was, and it's this text node that says location fetched. So in the end, what we want to test here is that first the button is disabled, because that's the first thing that happens when we start fetching. We disable the button, and only once we have the location, the button is removed and this text node is inserted. So as a first step, I want to get this button here again. And then we want to check whether it is disabled. And we already had similar checks before in this course, where we checked for elements being disabled. And you can, of course, use all these approaches I did show you earlier in the course. But one other quick way of checking whether a button is disabled or not is to use the should be disabled assertion. So this will pass if the button is disabled, which it should be after clicking the button. And then thereafter, at some point of time, we want to have this location fetch text here in the container that contains the button. Now, if we take a look at the index.html file, we see that this is this paragraph that contains the button. So it's this paragraph that should contain the location fetched text at some point. And conveniently here, we also have a test-specific unique selector, and therefore we can use this to get it with the attribute selector. And then here, as mentioned, we want to find that location fetched text. And we can use contains for that, as we did many times before in the course, or alternatively, to also show you this alternative, we can also use should contain, and then here, location fetched. So that's in the end simply an alternative to using contains. With that, if we save this all, however, you will notice that this test fails. It does not pass. And it fails in the end here because we stay in this spinning mode. We don't leave this spinning mode, and therefore we never find location fetched. So the button is disabled, but we don't see location fetched. The reason for that can again be found in the source code. There you see that we do remove this button and add this text if we do have a location. And for that, it's important to understand how the built-in getCurrentPosition method works. This method takes a callback function, this anonymous function which is passed to getCurrentPosition. Internally, the browser will call this function for us once it has fetched a user's location, and it, the browser, then passes this location object in the end as an argument to this callback function. That's why I'm expecting it here as an argument in this anonymous function, which I am passing as a callback to getCurrentPosition. This position object will be provided by the browser when it calls this function, which it will do once it finished fetching a location. So we depend on the execution of this function for the UI update, where we remove the button and set the location fetched text. However, since in our tests here, we replace the built-in getCurrentPosition method with an empty function that does nothing, this callback function here, of course, never gets called, because we no longer have the browser's default behavior. That's the entire idea behind using a stub, after all. But that, of course, also means that this function never gets called, and we therefore don't get the UI update which we normally would get. And for that reason, an empty stub function, as we have it at the moment, is not always enough.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So in order to make sure that this callback function here in our application code gets called when getCurrentPosition is done, we need to tweak our stub here, our function implementation, and move from an empty function, which we have here as a default, to a function that does what we want it to do. And this can easily be done by chaining more methods after as when being used on a stub. And we get a couple of methods we can call here, but amongst the most important methods you can chain here are resolves, if you would want to simulate that getCurrentPosition returns a promise that yields a certain value, which is not what we want to do here, but this could come in handy in other scenarios. You can add returns if you want to make sure that getCurrentPosition returns a certain value, but that's also not what we want to do here. Instead, we really want to change the body of this getCurrentPosition function so that it takes a callback function as an argument and then executes that callback function with a dummy position object passed to that callback function. And that behavior can be added by chaining calls fake. And here you then pass a function to calls fake, and this is the function implementation that will be used instead of this empty implementation which you have as a default when stubbing this. So this is now the new function containing the new logic we want to assign to getCurrentPosition. Now here we should accept a callback function as an argument. So CB will be a function because getCurrentPosition takes a callback function. And we want to emulate that. We just want to make sure that then internally getCurrentPosition does something else than it would normally do. Because inside of this function here, where we now add the logic of getCurrentPosition, we don't want to ask for permission or try to fetch the user's location. Instead, all I want to do here is call that callback function, which we receive as an argument here, and pass a dummy position object to it. Now, if you take a look at the application code, you see that this position object that seems to be passed to that callback function by the original getCurrentPosition method has a chords property, which then has a nested object as a value, which has latitude and longitude properties, which then actually hold numbers, as I can tell you. Well, and therefore we can pass an object here to this callback function to emulate this, give this object a chords property, just as the original position object provided by getCurrentPosition would have. And then as a value for chords, we add a nested JavaScript object, which has a latitude property that could be set to 37.5. Any valid coordinate values can be used here, and a longitude value that could be set to 48.01. These values are up to you though. So with that, getCurrentPosition, when called in this testing context, so when called because of our automated tests running on that website, uses this function here as its implementation. So this function here, this highlighted part, replaces getCurrentPosition when it's being called by our application when Cypress visits our website because it's executing our automated tests. And therefore now if you save that and we're using this custom function implementation here, our test still fails, but now it fails due to another reason. Before we added this custom function implementation here, our test failed because it did not find location fetched. As you can see on that snapshot on the right here, it does now find that though. It now fails because it actually can't confirm that this get location button is disabled. This expectation is not met anymore. Now this is not met anymore because now with our fake implementation of getCurrentPosition, we immediately call this callback function and return our dummy coordinates. Therefore, if we take a look at our application code, this callback function here is executed immediately after calling getCurrentPosition because it's this callback function that's passed as a callback here to our fake getCurrentPosition implementation, of course. And since this executes immediately, we also immediately get rid of the button and instead add our location fetched text. This state here, where the button is disabled and we show this loader, isn't really visible on the page at any point of time because this all happens too quickly and getCurrentPosition internally, thanks to our fake implementation, immediately executes this function. So we basically skip this disable step because things are moving too fast. Now what we can do to slow this down and make this a bit more realistic is we can add set timeout here, a default JavaScript function you can use, and set a timer of 100 milliseconds, which is super fast but slow enough for the UI to change in between, and move this code where we call the callback in our fake getCurrentPosition implementation into this timeout function. Now with that, we're making sure that we only call that callback in our fake implementation after 100 milliseconds. And if you take a look at the actual website as it can be viewed by website visitors, you will notice that of course when this button is clicked, it takes some time until the location was fetched. So that's exactly what we're simulating here, though we just simulate 100 milliseconds because when running our tests it makes no sense and would just slow things down if we would arbitrarily wait for 3 seconds or anything like that. But if we wait at least 100 milliseconds, you will see that now all tests pass, or all steps in this test pass, because now indeed, as you can see here on the right in the snapshot, we do have that loading state, at least briefly, before we then switch to this location fetched state. And with that, we now have a proper fake implementation for getCurrentPosition with this stub feature that allows us to successfully test this user flow of clicking this fetch location button. We're not checking whether the location is really fetched, but as explained before, we don't want to check this because that's some behavior built into the browser. It's not our responsibility to make sure that the browser works correctly, but we can ensure that our website behaves correctly before the location is fetched and after it's fetched. So this was our first test using our first step. It's not all I want to add to this website though. Instead, we of course also have this share link button. Now, if we click it without entering a name, we get an error message here. And we could of course write a test that checks whether this error message is displayed if this button is clicked without entering a name. But even more important, also to learn something new in this section here, is what happens if you do enter a name. Because if you do enter a name here and you click this link, you actually copy a URL to your clipboard, which then can be used to load this place on a map. And of course, we probably do want to write a test for that as well. Now, this copy to clipboard mechanism is again a built-in browser feature, a browser API that we're using. You can see it in main.js there after fetching a location. Here in this share location function, which is in the end triggered when that form is submitted, so when that share link button is clicked. In that share location function, we have some validation code, But then towards the end of this function, we call copy to clipboard, which is another custom function that uses the navigator clipboard write text method. And just as we had navigator geolocation get current position, navigator clipboard write text is an API provided by the browser. So what we might want to test in our tests here is whether, after fetching a location, when we click this link, this browser API is triggered. So if our flow works correctly. We don't want to test whether we actually have some data in our clipboard thereafter, so if we can paste it anywhere, because that's some browser behavior again. It's not our duty to test that, and we shouldn't try to test it. But of course, we do want to test whether we correctly call this clipboard API, whether we're using it correctly. And that will be the second test we'll add here to this test suite. In this test, I want to test whether we can correctly share a location URL, so whether that sharing process generally works. Now for that, in this test, we need to go through a couple of steps. We need to fetch a location, and we then also need to enter a name here. And thereafter, of course, this share link button must be clicked. Now for that, to enter a name, we of course need to select this input here. And conveniently, we have another data-cy attribute on it, so we can use that here in this newly added test to get hold of this input field. And then we can type a name into it, like John Doe, for example. This will be our dummy name for the test. Then, of course, we want to start fetching the location. And for that, we, of course, again, want to click this Fetch Location button. Now, what's really important to understand here is that in this second test, the geolocation API provided by the browser and this getCurrentPosition method, which we stubbed before, will not be stubbed because I am creating this stub in the first test. And as you learned earlier in the course, these tests run in isolation from each other. So if we create a stub in the first test, it won't have any effect on this second test. Therefore, if I quickly add this visit code to this second test, because we of course need to do that as well to visit this page, and I then save everything, you will notice that this second test passes, but in the snapshot here on the right, you see that we have this ongoing spinner, just as we had it earlier for the first test, because we never stop fetching the location, because that actually fails, because we can't do this here in this automated test, because I haven't granted permissions to this browser tab. So this stub is not active here for this second test. Of course, I do want it to be active here though, because I need to simulate that process of fetching the user's location in order to go through the remaining steps of the flow I want to test. Therefore, of course, we could copy and paste this code here where we create the stub, but this would not be ideal. Instead, it's much better to use a hook about which we learned earlier in the course, the before each hook. If we call before each like this in this suite, so outside of the tests, but in the suite, and pass a function to before each, this function will be executed by Cypress before each test in this suite. And we can copy and paste, or cut and paste to be precise, this visit code where we then also create our stub and cut it from the first test and add it here to this before each hook so that this runs before every other test in this suite. Which means we'll always visit the page and then create this stub. Therefore, of course, in the second test, we can now get rid of this visit code. And now in the second test, you will notice that if you take a look at the final snapshot here on the right, this spinner is gone and it instead says location fetched because our stub was used to replace the built-in getCurrentPosition API. And that's how you can reuse a stub across multiple tests. Now, of course, here, reusing the stub was just one of the things I wanted to do. The main thing I want to do is continue with that process here. We want to enter a name, then fetch a location, and then click on Share Link. So, therefore, we also need to get access to that Share Link button. And conveniently, again, I have a data-cy attribute on that. So again, we can use that here in our second test to use it as a selector like this and click this button, which will submit the form. Just as a quick side note, this is also a great step to add to this test, not just because we of course want to submit the form, but also because it will fail if this share link button would still be disabled. Because keep in mind that it is disabled initially. So if we had a bug in our application code that would cause this share link button to not get enabled after a location was fetched, our test would fail and we would therefore catch this bug with our test as well. That's why it's so important to really simulate all these steps a user would go through as they would use the website, because that of course can help with catching many possible bugs. So with that, we now clicked this share link button, and now what? Well, now we want to make sure that this browser internal clipboard API was used. And for that, we can again use a stub. We can again use a stub to replace the built-in API, the built-in method offered by the browser, with our own custom method when running our automated tests. And I'll do this here in this before each hook, where we also create this first stub. In there, we can also, of course, create a second stub. So here we can call cy stub again. And now here, this time, we want to stub win, so this window object we're getting here from visit, dot navigator, dot clipboard. And here, it's then the write text method. And you also see that we get some nice auto-completion here, which of course is awesome and simplifies this process. So with that, we're creating a stub, and as you learned, by default, it will simply be an empty function that replaces the default write text method. Now, if you take another look at the main.js code here, so at this main application code, you will see that the default write text method offered by the browser seems to return a promise, because we chain then here, and this of course is not the then offered by Cypress, about which you also learned in this course. Instead, that is a default promise you're getting here. So write text originally seems to return a promise, and we're using that promise in our main code to have some code that should be executed if we successfully stored some data in our clipboard, and we also define some fallback code if that failed. So we want to make sure that in our stub here, we also return a promise. Otherwise, our main code won't work correctly, because here we expect to get a promise. Otherwise, calling then will fail. Now, to make sure that our stub returns a promise, we can use resolves, a method I already briefly showed you earlier in this section. When chaining resolves here after stub, this stub will return a promise, and you can pass a value to resolve, and that value will then be the value yielded by that promise that is returned by the stub. Now here, however, we don't need any value, because if we take a look at the main application code again, you see that we actually don't expect to get any value here in this function that should be triggered when the promise resolved. So we don't need to pass any value here, but by simply calling resolves, we make sure that write text returns a promise, which then actually turns out to resolve immediately, which is fine because we also don't want to wait unnecessarily when running our tests. So with that, we have this resolving promise here as a stub implementation. And to then refer to this stub later when adding our assertions, I will also add an alias here. And this alias must be added here. You can't add it here after resolves. Instead, it must be added before you call resolves. So right after the stub method. And it's up to you which alias you want to assign. Here, I'll name it save to clipboard. And that's now our second stub added. Now we can use this second stub in our second test here to add some assertions. Because here, after clicking the share button, the expectation of course would be that this clipboard API offered by the browser has been used, so that our save to clipboard stub has been called. Therefore, again here, just as before in the previous test with that geolocation API, we can get our alias here and then add should to add our expectation here. And the expectation here is that it has been called. So just as we had it before for fetching the location. Now that's actually not all I want to check, but it's a start. So if I now save this second test also ran and also passes, and you see that we have two stubs active for this test now. We see that both stub functions have been called, and therefore all these steps here passed. And we can see here for the last step that indeed this share link button was called. We even see this info overlay here, which is another proof that this all worked as expected. Now, of course, with this second stub, we make sure that the clipboard API has been called, but we can't be 100% certain that our application works exactly as intended. Because it, of course, only works as intended if that clipboard API is called with that URL that can then be used to visit a map in the browser. And at the moment, we're just verifying that write text has been called at all. We don't care about the data that was passed to write text. Now, in the main application, the data passed to write text in the end is the data passed to this copy to clipboard function, which is defined in the application code. And the data passed to that is actually this location URL, which is built dynamically in this code, and which in the end is a Bing URL using Bing Maps, which then contains the latitude and longitude coordinates amongst some other configuration items, and which then also contains the username, which is added here in this step. Therefore, we don't just want to check whether save to clipboard has been called, but we actually also want to verify that it has been called with the right arguments, that the right data has been passed to it. Of course, our dummy function here doesn't do anything with that data, but we still want to make sure that the right data has been passed to it, because in reality, on the real website, we would be using this browser internal API, and of course we want to make sure that our application passes the right data to that API. And we can test this with help of our stub here as well. For that, we of course want to add another assertion, and here we can check that this stub function should have been called with match. This assertion allows us to use a regular expression that's matched against the data that's been passed to our stub function. The second argument passed to should have been called with match, therefore, is that regular expression we want to use for matching. And here I will build this regular expression with the default regexp constructor function, which is a default JavaScript feature, because I want to build this regular expression dynamically using a template literal. Because I, in the end, want to inject my latitude, my longitude, and my username here as dynamic values into this regular expression, because the URL that's passed to this write text method in the end contains my latitude, my longitude, and the username, in that order with some extra characters in between. And those extra characters can be reflected with these patterns, with a dot followed by a star. This means any other characters and as many of these characters as you want. And then here we want to have the latitude, the longitude, and the name, though these variables don't exist here. Instead, the name will be John Doe, because that's what we enter here. And for latitude and longitude, we have to use the values we set here in our stub function, which we use for getCurrentPosition. So latitude, in my case, is 37.5, and longitude is 48.01. And with that, we're verifying that the value passed to this write text function, which we're stubbing with this save to clipboard stub, receives an argument that's a string that matches this regular expression. So that contains a latitude, a longitude, and John Doe with any characters in between and any characters before and after these three values. If you save that, you see that here for me, this actually fails. And the reason for that is that I'm looking for this pattern where John Doe is written like this, but in the actual URL, it's written like this: John Doe with %20 as a separator between John and Doe. The reason for that is that it's URL encoded in the actual URL that's generated by my application, and therefore we also need to encode John Doe in this URL format, which we can do with the default encode URI function offered by JavaScript. So this is not Cypress specific, this is a default JavaScript function, just as this regex constructor function is default JavaScript. And with that, this test now passes. And we're now verifying that this writeText method, which we stubbed, has not just been called, but has actually been called with the correct data. Of course, alternatively, we could have also been more restrictive and matched for the exact full URL instead of these main data fragments here. This simply depends on how restrictive you want to be in your test. For this test, to keep it a bit simpler and this line a bit shorter, I will simply match for these main data points. So we're using a second stub here, and we're also validating the fact that the correct data has been passed to this stub function. But currently this solution has a big flaw. We have hard-coded coordinates here and here. So whenever we decide to change these coordinates up here, we also need to change them down here. Now, of course, arguably, we're probably not going to change them all the time, but we could definitely be changing them at some point, because maybe we want to simulate some exact point on the world. So therefore, it would be better if we would define these coordinates in one central place and then use them from there. Now, of course, for that, you could create a helper variable or constant here at the top of this testing file. But this, of course, then becomes problematic if you need to use the same data in other testing files as well, which is not the case here, but definitely a realistic scenario in bigger projects with more tests. And because it's so common that you have some fixed dummy data that should be shared across multiple testing files when running your tests, Cypress officially supports this data sharing with a concept called fixtures. You even have that extra fixtures folder in your Cypress folder. And fixtures are simply pieces of data, pieces of JSON data that can be shared across your tests. Here in this fixtures folder, we can create a new file, user-location.json, for example, though the file name is up to you, but it should typically be a JSON file. And then in that file, you can store your data that you want to use or that you want to share across tests in the JSON format. Now, here in my case, I want to move that object here, this dummy position object, from this stub implementation to this user-location.json file. For that, we can copy it in here, and to then turn it into valid JSON, we need to wrap these property names with double quotes and get rid of these extra commas. With that, the data is stored here in this central place. Now we can easily access that data from inside our different test files and their tests. To access some fixture data, you can use cyFixture, a built-in method. And then here you specify the file name of your fixture data. So in my case, user-location.json. This file name I set here. I'm using this here, and this now accesses and loads the data from that file. It also parses the data and converts JSON to a plain JavaScript object. To then use this fixture, I'm loading this fixture data here in before each, so that thereafter I can use it in all my tests and of course also further down in this before each hook. To access that loaded fixture data, we should assign an alias. So as you can tell by now, this alias feature is really quite important because you can not just use it to share elements or access to elements that you got with the get method, but also to get access to stubs or to fixture data. Again, you can assign any name you want, for example, user location. And then that data can be used anywhere else in this before each hook or in the tests that belong to this suite by using this alias. For example, here for this stub, where I of course still want to pass that dummy data to this callback. To do that, instead of this visit function, we have to get hold of this user location fixture data by using this alias with the @ symbol. And then instead of then, we have our fake position. So this data that's stored in this fixture file and stored under this alias can then be accessed by loading that alias and using then. Fake position then holds the data that's stored in the file. However, as mentioned, already converted from JSON to JavaScript objects. And then we can move this stubbing code inside of this then method. And we then have access to fake position here and can pass this to our callback. So of course we have a couple of levels of nesting here, but this is not uncommon to have when writing tests with Cypress, especially when working with stubs and fixtures in the same place. So with that, we still pass the fake position to this callback, but now we can also use that same fixture down there in this test. And here we can now also get access to that user location dummy data and then use then to get hold of this fake position. And inside of this function that's passed to then, we can then access our save to clipboard stub and match its arguments. But now instead of hard coding those position values here, we can extract latitude and longitude like this from fake position.chords. Chords, because in this fake position data we have the chords key, which then has another nested object with latitude and longitude. So we're extracting latitude and longitude here, and that should actually be in that line of code here. And then we can use latitude here, longitude here, and we can keep John Doe like this because we just defined it up here in this same test. We could alternatively also store this in some variable or constant, but the more important part is that we did now outsource this position data, and therefore we have one central place where we can manage it, and we're using Cypress fixture feature to load and use that data. And that's all fixtures are about. They are about storing and providing dummy data to your tests. So with all that saved, you can rerun your tests, and they should all still pass because we still successfully go through all these steps and verify that this copy to clipboard function was called as it should be called. So at this point, we worked a lot with stubs and we had a look at fixtures. But you might recall that there also is a concept called spies, and we haven't had a look at that yet. So what are spies? Well, where stubs are replacements for existing functions or methods, spies are simply listeners that are attached to existing functions or methods. They can be used for evaluating and asserting function calls, so to find out whether a function was called, with which arguments it was called. But unlike stubs, they don't replace or change those functions. That's the key difference. For that reason, you of course often use stubs because often you might want to control what a function or method does, as we had it here for getCurrentPosition, where we wanted to make sure that we're not trying to fetch the user's location because that would not work when running our tests in this automated environment. But you also sometimes have functions or methods that may be executed where you don't care about whether they're executed, or maybe they even must be executed, but you want to know that they have been executed. And that's where you can use spies. And this demo application, which I provided to you here, actually also has a use case for spies. If we take another look at the main application code, at the share location function in there, then you will see that towards the end of the function, we're calling copy to clipboard with the data that was entered into this form here. But if you take a closer look, you will actually see that we also seem to be storing and retrieving some data from local storage. which is a standard browser storage, some storage you have access to via the browser from inside your website code. This application uses local storage to store this location URL, which is generated by the application, in this storage under the username as a key that was entered here in this input field. And if then later this share link button is clicked again, so when it's not clicked for the first time, but a second or third time, we're actually using that URL that's stored in local storage instead of recreating the URL. So if we find a stored URL, this application uses that stored URL instead of generating a new one. So it's this local storage feature that's being used by this application, and just as geolocation and the clipboard, local storage is a feature, an API, offered by the browser. It, for example, offers setItem and getItem methods to store or fetch data to or from this local storage. Now, unlike this getCurrentPosition method offered by the browser, this local storage API doesn't do anything that could cause our tests to fail. It should work in our automated testing environment just fine. So there's no reason to stub it, but we still might be interested in finding out whether we actually did try to store some data in local storage or fetch some data from there. And that's a perfect use case for using a spy. We don't need to replace the API. We don't need to replace the local storage methods. We just want to attach a listener so that later in our tests, we can find out whether local storage has been accessed, because our application, of course, should access it, and we can then test this. Now, to create spies, you again use the CY object, and then instead of stub, you use the spy method. Now, just like stub, you then pass the object and the method name you want to add a spy to. So here, that would be win.localStorage, and the method name then is setItem, and I also want to add a spy to getItem. So that creates two spies, and in order to then also use them in our tests, we also need to assign aliases like store location, and here get stored location, though as always the alias names are of course up to you. Now these spies can be used down there in this second test. This should share a location URL test, maybe after this step here, to find out whether local storage has been accessed. So here we can call set get at store location, which refers to my spy that was added to the setItem method. So I access this spy, and then we can again write our assertion that it should have been called, for example. You can also expand this assertion and, for example, make sure that it has been called with the right arguments, which in this case would be two arguments, where the first argument should be the username and the second argument should be that URL. If you would want to verify those arguments as well as the fact that it has been called at all, you could again use have been called with match, and you can pass multiple arguments to the should method then, so not just one as we're doing it here, but in this case two extra arguments after the assertion description, where this second argument passed to should is the first argument that has been passed to setItem here. And the last argument passed to should is compared to the second argument that has been passed to this function we're spying on, so to setItem. And here I'm using two regular expressions, here looking for John Doe, and here the exact same regular expression I used up there. Since I'm using my latitude and longitude again, I now would have to add this code here into this then block though, where I have access to this fixture data. So to this fake position, because that's where latitude and longitude are coming from. And with that, if you save everything, these tests would pass. Now, as always, it is up to you what exactly you want to test, but that is something you could do. We of course might want to test that we also then get data from local storage when clicking this button for a second or third time after initially creating that link. And to simulate that, we need to make sure that this share location button is clicked again in our test. So we can copy this code and paste it in here. And then thereafter, we can get our get stored location spy, which is assigned to local storage get item method, and make sure that this has been called. So this method should have been called. That's what we're asserting here. We could then also add another check where we take a look at the return value of this spied function. This could be done with should have returned, but actually it's not too important here, because with that we would just be checking that local storage works as it should work. And as mentioned multiple times before, it's not your job to verify that those browser APIs work correctly. So I don't really care about the return value here. I just want to make sure that our application does call this get item method on which we're spying. And with that, if we save everything, looks like everything is working. Now, with all that, we're almost done. But if you take a look at this application, there is one last feature which we also might want to test. And that's this info banner, which is showing up here at the top. Whenever we click share link, this banner, this message appears and tells us that the data was copied to the clipboard. And we of course might want to test this as well. We might want to test whether this shows up when clicking this button, and we also might want to make sure in our test that it disappears after a couple of seconds. And to test this, we can add another step to this test. We could also create a new test, but as mentioned before in this course, it's not uncommon for end-to-end tests to become rather long and to include many steps and assertions, because you wanna test entire application or user flows. And this banner, this info message, definitely belongs to this overall flow of sharing our location. So creating a separate test would be possible, but I would say it would not be recommended. Instead, adding it to this existing test sounds like a better idea to me. Now, of course, we need to get access to this info element. And if we take a look at the source code, we see that it's this aside element that's showing up. And this again has this convenient test-specific attribute, which we can use for selecting this element in our test. So here we can again use the attribute selector to get hold of this info message banner element. And then we of course want to make sure that after clicking the share button, this banner is visible, that it's showing up. Now for that, to ensure that this banner is visible, we can use should be visible. And that should do the trick. If we save everything, this test should pass, and this assertion, checking the visibility, passes because indeed Cypress sees that this banner, this message is visible. Alternatively, we could of course also have checked for the existence of a certain CSS class. As you learned throughout this course, there are different ways of evaluating the existence of classes or looking into class names. If we're not interested in a part of a class name, but we want to check whether a specific CSS class was added to an element or not, we can use have class as an assertion here and look for the visible class, because if you take a look at the source code again, in main.js, in this display info message function, you will see that this visible CSS class is added to this element when it should be visible. So that would be an alternative way of checking that it is visible. Either of these two steps would work, and if you really care about that exactly this class was added, you can of course also add both steps here. Of course, if you take a look at this application, it's not just about showing this message though. Instead, it should also disappear after 2 seconds or something like this. And therefore, we can also add another step thereafter. And here, we might want to check that it's not visible. So it should not be visible. Now, if you save this, the test takes a bit longer, but ultimately it passes. If I run all tests again, you will see this last step, it takes a while. We even see that countdown starting here in Cypress Studio, but eventually it passes. The reason for that is, as you learned before, that Cypress will actually wait until a certain assertion or step fails. The default time frame, the default timeout are 4 seconds. So Cypress continues looking for a certain element and checks whether it's visible, or in this case, if it becomes invisible, for up to 4 seconds. Of course, initially when that step starts, the element is still visible because this item only disappears after 2 seconds. It's visible for 2 seconds. And therefore, initially, this step here, this assertion would fail. But because of this timeout, Cypress keeps on trying and keeps on repeating that step for up to 4 seconds, and the overall test would only fail if after these 4 seconds this element would still be visible. So this assertion would not be met, because here we're looking for the element to be invisible. So because of this timeout functionality, our test works as we want it to work. However, of course, it's not ideal if in our tests we have to wait for certain timers to expire, because that slows down our tests. It's not a big problem here, we only have 2 tests, but if you have a more complex application with maybe dozens of tests, if every test takes 2 seconds longer than it must take, well, then you're already waiting for almost 30 seconds just because your application might be using timers in certain areas. And because you don't want to wait for this timer to expire, you don't want to wait for these 2 seconds that we're waiting in our application code until this message disappears when running your automated tests, you can also manipulate the clock when using Cypress. Being able to manipulate the clock is a pretty amazing feature offered by Cypress, because it allows you to simulate intervals or skip timers when running your tests. And that's exactly what we need here. In our main application code, this info message disappears after 2 seconds. Because here we're setting a timer, and after 2 seconds, this visible CSS class is removed and the element disappears. So therefore, we basically want to simulate that 2 seconds passed without waiting for 2 seconds. To do that, we can use another method offered on the CY object, and that would be the clock method. Now, when calling clock, you're telling Cypress that you want to manipulate the clock, that you want to manipulate timers and intervals. And after calling clock, and only then, you can call another method on the CY object, and that's the tick method. And this allows you to advance time by a certain amount of milliseconds. For example, 2000 milliseconds here, which is exactly the time we're waiting here with this timer in our application. So with these 2 lines, we're manipulating the clock, or we're telling Cypress that we want to manipulate the clock, and then we're advancing the timer by 2 seconds. So we're basically skipping 2 seconds of time in our test. We're simulating that 2000 milliseconds, 2 seconds passed in this one single step. Now, with that, if you save everything, you will notice that your test, your second test, still takes some time though. It was not sped up. And the reason for that is that clock actually must be called before initializing your tests, before running your tests. So the best place to call it is here in before each. When calling clock here, the clock will be manipulated before the test runs, and that's exactly what you need to do. You need to manipulate it before the test starts running. And now with clock being called here, and then you advancing the time down here in the actual test, in this case by 2 seconds, you will notice that the second test now runs way faster. You see, we don't start that timeout here in Cypress Studio. It finishes almost instantly because we're manually skipping 2 seconds, thanks to manipulating the clock with this clock method, and then. And that's it for this course section. You learned about stubs and spies, where both concepts are related to functions and methods, but the idea behind stubs is that you can replace existing methods, like this getCurrentPosition method offered by the browser, and spies are there to just add listeners to existing methods. With both stubs and spies, you can add assertions that check whether certain methods have been called, with which arguments they have been called, what they returned, and so on. But with stubs, you can also change how these existing methods and functions behave. You can set their return values or, as you also learned in this section, even replace their entire implementation. You also learned about fixtures, which is all about dummy data. With fixtures, you have a central place to manage your dummy data in these fixture files in the fixtures folder in your Cypress folder. And you can use the fixture method to access and use that data in your tests, as you also saw it in this section. And last but not least, you also learned that you can manipulate the clock with the clock method offered by Cypress, and this allows you to, for example, skip timers or in general advance time so that your tests that depend on application code that uses timers don't take forever to run. In this course section, we'll take a look at a couple of very common problems that you'll often have to deal with when writing tests. We'll take a look at dealing with network requests, databases, and authentication. If you're testing an application that sends network requests and/or uses a database and/or uses authentication, you're likely going to run into some problems, or at least some potential problems, when adding end-to-end testing or any kind of testing to such an application. And of course, since most applications use at least one of these features, it's crucial to understand how to deal with these problems. Therefore, in this section, you will learn how to handle HTTP requests in end-to-end tests. You will learn how to work with a testing database to avoid problems with your production and main database. And you will also learn how you can test and simulate authentication flows, like users sign up, user log in, logging users out, and so on. Now, as always, I prepared a starting project for you, which you find attached to this lecture. And this project here is now at least slightly more advanced project, because it's actually a full stack application which has a front end and a back end. So work that's done on the server and work that's done in the browser. And this demo application, which I'm providing to you here, has all these features I just mentioned. We will have network requests here, we are using a database here, and we will have user authentication. Now, after downloading this attached application, you can run npm install, but you actually don't have to. Instead, run npm run init, and this will execute a small script which I prepared for you, which does also run npm install, but which also sets up a couple of other things behind the scenes. Most importantly, this script also set up a development database, a local database, a SQLite database, that will be managed by Prisma, which is simply a tool, a JavaScript library that can be used for querying databases. And we're not going to write any Prisma code in this section. In general, as always, we're not going to work with that application code, though you may of course browse it. I'm using Remix as a framework here, and I do have a course on Remix, but again, you don't need to understand that code, but you should understand that this application will use a database. And you can see this application in action if you run npm run dev, which starts a development server, and you can then view this application by visiting localhost 3000. And you should see this starting screen here, and on that screen you see a couple of key Cypress takeaways, a couple of key concepts you should know about Cypress, and you can add your own concepts, your own takeaways, but for that you must be logged in, and for that you of course first must create an account, which you can do with a dummy email address, since this will all be stored locally in this development database. And once you created that account, you're going to be logged in automatically, but you can of course also log out and then explicitly log back in. So that all works. And if you're logged in, you can also add new takeaways. And these takeaways will then also show up here if you are on this takeaways page, not on the starting page, because there we only see 2 takeaways at most, but we see all our takeaways on this page. Now, besides being able to store your key takeaways and manage your key takeaways on this page, and just by the way, of course, these takeaways are going to be stored in the database. That's why this application does use a database. It does store all that data in that database. But besides this feature, this application also has a newsletter sign-up area at the bottom of the page. And there you can also enter an email address even without being logged in, and then sign up to the newsletter. And what this will do is it will send a request and then store this email address in the database and thereafter show you a little message. And if you, for example, try to sign up with an existing email address again, you will instead see an error message that this email is already subscribed. So a couple of interesting features that could be tested, and a couple of features that rely on network requests being sent, on data being stored in a database, and as you saw, on user authentication. Now this demo project, which I provided to you, then also has Cypress already added to it. The Cypress package is already installed, and you already have a Cypress folder, though in there you don't find any tests yet. Because that's of course what we're going to work on together for the rest of this section. So let's start adding some tests. For that, I of course have my development server up and running here. That's important because, as for the rest of this course, Cypress needs that application to be up and running in order to run tests against it. But we can now of course also add our testing file here. And I want to start with testing these key takeaways that can be stored. For example, we could start here on the starting page of this application and check whether these key takeaways, these 2 key takeaways which we have here, are displayed on this page. For that, we can of course go to the E2E folder and then in there add a new testing file which could be named takeaways.cy.js. .cy.js is important at the end, as you learned, because that makes sure that Cypress finds this spec file. And then with that added in there, just as we always did it, I will add this reference element at the top to make sure that we do get proper auto-completion. And then thereafter we can call describe here and test our takeaways. You can of course give this any name you want, as you learned. And then in this function which we pass to describe, we create our tests with the it function. And in this first test, I want to ensure that my application should display a list of fetched takeaways on the starting screen in this case, but I'll just keep my description like this. And now, of course, here the goal is to visit the starting screen, and you just need to visit / because in this Cypress config.js file, which I provided to you, I do have my base URL already set to localhost 3000, so we just have to add the path when calling visit. So with that, I visit the starting page, and then there, I of course want to make sure that these 2 elements are being rendered. And to ensure that this is the case, we can quickly inspect those elements here. And you'll see that these list items have a data-cy attribute. Now this is not unique because every list item has that, but it's only the list items that have this attribute with this value, and therefore we can of course use that to select all these list items with that selector. Therefore here we can now call cyget, and then just as we did it before in this course, use data-cy, and then here it's takeaway-item, which is the value that's placed on these list items. And then we can add our expectation here with should, as you learned. And as always, there are multiple ways of creating your expectation, of writing your expectation here. Here, I'll keep it simple and just check that this should have a length of 2. So that 2 takeaway items should be rendered on the starting screen. By the way, in case you're wondering where this initial data is coming from, when you ran this init script, this is what you executed in the end, a seeding file was executed, which contains some logic to add some dummy data to the database when it's being created. Later in this section, we'll take another look at seeding, but that's where this dummy data is coming from. With that, we have this test though, and now we can add a new terminal tab, and in there, as we did it before, run npx cypress open, or better for this project, actually run npm run test :open. This will trigger another script which I prepared for you, which you find in the package.json file, this script here. And in this script, I make sure that the database is prepared correctly, this local development database. And I also make sure that both the development server and Cypress open are executed simultaneously. And therefore, you can now indeed quit the development server, which you executed before, and instead run this one single command, and this will now run both development server and Cypress open. Cypress open will still open Cypress Studio, which will still work as before, but it's now more convenient to do that. We could have done this before in the other course sections as well, but this course section is the first time I'm doing it, because in this course section we'll take advantage of this utility script a little bit later on. So this opens Cypress Studio, which we can use as we did before in this course. And there we can then execute our takeaways CY spec file, and we should see that it passes. By the way, there you might see some errors which don't cause the test to fail though. And these errors are simply coming from a bug with this framework and the libraries I'm using here in the end. These are not errors related to the application code and not errors that should cause the tests to fail. And for that reason, I also added some code in the Cypress folder, and there in the support folder in the commands.js file, I added this code at the bottom, which you should not change, which simply makes sure that these errors don't cause our tests to fail, because these are specific errors with React and this remix library I'm using here. And as mentioned, they are not related to the application code. And therefore, this code here simply makes sure that our tests don't fail unnecessarily. Instead here, this test passes because our expectation is met and we do have 2 list items here. But even though this test passes, it has a problem.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So what's the problem with this first test we wrote here? The at least potential problem with this test is that it uses a database under the hood. If you take a look at the source code, and there at the index.jsx file, which you find in the app folder and there the routes folder, you will notice that even though if you don't fully understand that code, in this file we seem to be hitting a database. I mentioned that Prisma is a package we're using for database communication, and here we're basically fetching multiple takeaway items, 2 takeaway items to be precise, from the database, and that's the data we're showing on the screen. Now, of course, getting data from a database is probably not too problematic because it doesn't change anything about the data in the database, but you should always be careful when you're writing tests that need a database in order to work. Because as mentioned here, we're getting data. That's probably fine. But later, we're also going to write tests that manipulate data, that create new key takeaway items, for example, or that create new users. And that then will definitely become problematic because your tests should never change any data in your production or development database. The development database might be fine, but the production database, that would be horrible if your tests would mess with your actual application data. That is something that should absolutely be avoided, and that's the problem we have with this test. At the moment, we're using the same database we're using for all our other development. And even though it's just development, it's definitely a good idea to use a dedicated testing database for your tests. A database that can be changed and manipulated and cleared and whatever without affecting any other environments. And that's the problem with this test that should be fixed. At the moment, this test tests our application without using a dedicated testing database. For situations like this, we can use a test-specific database. A database that's only used for our automated tests, and therefore a database that includes and holds our testing data. So instead of using a fixture file, as we did it before in this course, we're now going to use an entire dummy testing database. Now this of course requires some extra setup work. You might need to spin up an extra database server that's only used during testing. But here in this application, where we're using SQLite, it's easy enough to do. We just need to make sure that an extra database file is being created by this application when our tests run. Now for this, I already prepared an extra .env.test file, and these .env files simply hold some extra environment variables that are used by various parts of the application. And this .env.test file instructs this Prisma package, which as mentioned before is the package responsible for managing our database, to create a separate test database when running our tests. At the moment we're not using this configuration file though, that's why at the moment this extra testing database is not being created. Using it is easy enough to do though. For this I'm using another extra package, .env-cli, which simply allows me to inject different environment configurations in the commands that are executed as part of these scripts with help of this .env command. And at the moment here, I'm always using the normal .env file, which contains my environment variable configuration for my regular development, which uses the wrong database. And to make sure that this testing database is created and used instead, we simply have to go to this package.json file. And for these two testing scripts, we have to change .env to .env.test. So for all these .env occurrences, where we have some at the beginning of this script, and then also some a little bit further down in this script, we should always use .env.test here in these commands, which do start this development server and Cypress run or Cypress open. And with that, if we now restart this test open command, we will have an application that will use a test-specific database. So what you can do is open your terminal and quit this running test open command and simply rerun it so that this new configuration with this new environment variables file is taken into account. And this will now create this testing database file and then again start the development server and your tests. And there, if you now run your test, you will see that it fails because indeed there are no takeaway items on the screen. Because this testing database is a different database which has not been seeded with the dummy data. So that's something we'll have to do, but we'll do it a bit differently than we did it before for the main development database. So how should this testing database be seeded? Well, before for the main development, it was this init script here, which also executed this seed.js file, which in the end ran some code to put some dummy data into the database. We're not going to use such an initialization script because, of course, with that the problem would be that the database is initialized once, but if our tests then change that database, which they don't do yet, but which they will do later, then of course we would lose that initialized state, and in the future some tests might fail because data simply changed because of some other tests. And we would therefore not have any test isolation anymore because the database is shared across all these tests. That's why instead it's better to seed the database before every test run so that it's cleared and set up from scratch again before every test. Which might sound like a lot of work, but which will actually be super fast and which will ensure that we keep test isolation because every test starts with a brand new database. Now to seed that database again and again and again before every test run, we of course can use before each to run our seeding code in there, but we also have to keep in mind that this code here of course runs in the browser, because all our tests run in the browser, in this Cypress Studio here for example. But even when not using that, they run in the browser because they test our application as it runs in the browser. So therefore here is not a great place to reach out to our database. Instead, for situations like this, Cypress gives us this setup node events area here in the Cypress config.js file. And I did briefly talk about this area, or this method, that's what it actually is, earlier in the course. In there, you can use this on function to listen to various events. For example, the task event, which, as you learned earlier in the course, will be triggered whenever you call cytask in your tests or hooks. This allows you to trigger some tasks from inside your tests that will then run outside of the browser. Because whatever you add here to set up node events runs outside of the browser directly on your system instead. So here with that, we can listen to tasks triggered by cytask. And we have to pass a second argument to onTask, which is an object where we now can define different tasks to which we want to listen. And here it's totally up to you how you name your tasks. I'll name mine seed database. But again, this name is up to you. This should be a method, and in this method, you can now put your code that runs outside of the browser. Now here, I actually want to use an existing file, seed-test.js, which contains my test database seeding instructions. It's a bit different from the development seeding, because in this test seed file, I am creating these dummy takeaways, but I'm also creating a dummy user and a dummy newsletter user, so to say, an email address signed up to the newsletter, because that will be helpful for other tests we're going to write in the future. So it's this logic which I want to execute, and all we have to do to execute that logic is we have to import this seed function, which is exported from that seed test.js file, into our Cypress config file, and then execute it inside of this seed database method here. So here I'm going to import seed from, and then we dive into the Prisma folder, and there it's this seed-test file. And then here we execute seed. And what's now important to understand is that this seed function is an async function, therefore it returns a promise, and we should wait for this promise to finish here inside of this seed database function. And we can do this by adding async here and then await. And then also very important, at the end you should return null here, because you have to return a value from inside your task methods for this cytask call here to succeed. Even if you're just returning null, but you have to return something. Well, and with that we can trigger this task by going back to our test file here, and when calling cytask, you now pass the name of the task you want to trigger to this task method. And in my case, that is seed database, so the name you chose here. And by adding this code here, by triggering this task, Cypress will execute this code and therefore reseed your database before every test. And this ensures that every test runs in total isolation from other tests with a fresh database. And with that, we now have our test-specific database set up, which we can also safely manipulate without affecting our other development data, or even worse, possibly our production data, and we ensure that our tests have exactly the data they need to have. So with all that, if everything is saved, you can rerun your tests. This test now passes again, and we now have a properly set up testing database. So in the previous lectures, we set up that testing database. Now this testing database will also help us when we add some tests related to this newsletter sign up. Because when signing up for this newsletter here, this application of course also sends a request to the backend and stores that email address in the database. And as mentioned before, that's another good reason for using a testing database, because you don't want to start inserting your test data into your development or even worse, production database. You don't want to end up mixing testing and real data. So that's another very good reason for using a testing database. And that's exactly what we're going to test next. We can add a new testing file to keep our tests organized and now write some newsletter-related tests. Now in there, we of course again want to use describe and test our newsletter functionality here and add a first test here. And in this test, I want to make sure that my application displays a success message if we do sign up successfully to our newsletter. So in the end here, I want to make sure that when I submit my data here, I do see this message after it was stored successfully. Now to achieve this, we can again visit the starting page because we find the newsletter sign up area on that page. It's actually on every page, but also on the starting page, so we can simply visit that. And then of course we want to select this input field and enter our data. And we can inspect this input field as always to find its selector. And here I do have another data-cy attribute, which I will use for selecting this input field here in my test. So we can, as before, get this by using this data-cy attribute. And here this attribute has a value of newsletter, email. And then we can type into this field and enter our test email address here. Thereafter, this should be submitted, and for this we have the submit button right next to the input field, and there we also have a data-cy attribute that can be used. So we can also get hold of that button here by using newsletter submit, which is the value of that button's data-cy attribute, and then this can be clicked. Well, and thereafter, we want to make sure that we see the success message, and for that we can use the good old contains method and look for thanks for signing up. Because if we quickly do sign up here again, you will see that this is the message that is shown below the input field, or instead of the input field to be precise, after signing up successfully. So with all that, if we save that, we should have a valid test. And if I now go to this spec file here in Cypress Studio, we see that, well, actually it fails. And it fails because it shows us that this email is already subscribed. So we don't get this success text, we don't get the thanks for signing up text. Instead, we learn that the email already is subscribed. And that turns out to be correct because this email address, which I'm using in this test, indeed does already exist here. If I quickly enter it again here, I get the same message. The reason for that is that I am using my testing database, but I did not reseed it before running this test. And I'm showing this on purpose to show you how important this seed before every test approach is. It really ensures that every test has a brand new database and that we keep our tests isolated. At the moment, we're not doing this because this test doesn't start with a fresh database. So of course, what we should be doing here is that we should be calling before each again. And in this before each hook, we should again use cy_task and execute this seed database task, just as we did it in the other testing file. If we do that and run all our tests again, we will see that now, this time, this test passes because we do see our success message here. And therefore this test now works as it should. And this again shows us the importance of using a testing database. Now this newsletter test works, and we are using our testing database here again, which is of course super important. However, we could still argue that this is not a great test, because it's always important to keep in mind what exactly you're trying to test. And if here we're trying to verify whether we see this success message or not after signing up successfully, it seems a bit redundant to really send that HTTP request to the backend. Because for this test here, it does not only mean that we need to use a testing database, which we of course would be using anyways, but still we also need it for that test. But it also means that this test takes quite some time to finish because the backend turns out to be quite slow for this sign-up process. So this test runs for quite some time, for around 2 seconds, even though all we want to do is verify whether we see this message or not after signing up successfully. Now, of course, you might say, well, in order to sign up successfully, we need to send the data to the backend. But I would argue that we don't have to do that. Instead, we could intercept the outgoing HTTP request and block it and make sure that this HTTP request that's sent when we click the submit button never reaches the backend. And instead, for the purpose of this test, we simply simulate that we did sign up successfully. Because we don't care about whether the backend works correctly here, we just care about the success message. So in order to test that, it's enough to simulate that the sign up worked on the backend. And this is another core feature of Cypress. You can interset HTTP requests. You can do this by calling cyinterset, and typically that's done at the beginning of your test, before you even visit a page, because interset will set up an intersetter. It will basically watch for certain kinds of HTTP requests, and if such requests then occur at any point of time during the test in which you set up your intersetter, Cypress will step in and intercept that request. That's why it makes sense to set this up early in the test. So here we're calling interset to set up such an intersetter, and now this intersetter needs some configuration. For example, you can define the URL for which you want to watch in the outgoing HTTP requests to define which requests should be blocked. Like, for example, requests that are sent to google.com. Of course, that's not the kind of requests that are going to be sent here. Instead, here it will actually be a request that's sent to /newsletter. And you can verify that by going to your browser developer tools and there to the network tab. And here, if you enter some email address and click sign up, you will see a new request being sent to localhost 3000 /newsletter and then some query parameters thereafter. So that's the request we want to intercept. And therefore here we can enter this as a path /newsletter. And since we just saw that there also are some query parameters added thereafter, we can add an asterisk at the end, which is simply a wildcard character for any other kinds of characters after /newsletter. So this will intercept any HTTP request that's sent to localhost 3000 /newsletter and then anything. That's how this would work now. Now that alone won't do the trick though. Instead, the HTTP request that was sent here was actually a post request. And the intercept method does not just accept this way of using it, but instead you can also add an HTTP verb as a first argument and then your path. So that now post requests to /newsletter anything will be intercepted. And with that we're almost there. But I'm saying almost because this alone, when calling interset like this, will just add a spy to outgoing HTTP requests. So by setting up an intersetter like this, you could spy on the fact whether such a HTTP request was sent or not, and this would allow you to add some assertions that, for example, check that certain HTTP requests were sent. Sometimes this is what you want, but here I really want to block the HTTP request and return some dummy response instead of actually hitting the backend. If we left the code like this, that would not be the case though. Interset does not block the HTTP request when just configured like this. Instead, you need to pass another extra argument to really block that HTTP request and use some dummy response instead. And that extra argument which you add is the dummy data that should be returned by the request, the dummy response data that should be returned. Here, I'll set this to an object with a status property that's set to 201. I'm using this dummy object because in my newsletter sign-up form component, which is the component that is responsible for sending this request, I am looking for this kind of data in the response. In the end, with that code, I'm looking for a 201 status code in the response data package. That's why in my simulated response data, I am setting that status property to 201. If you pass an object like this as a third argument to interset, this data will be used as the response data for that request, and the actual request will be blocked and will not reach your backend. Instead, that dummy data will be used for the response. And with that, we now finally have the setup we want. With that, we are making sure that we are intersetting and blocking this request and that we are simulating this dummy response. So if we now save this and we run our tests again, this test still passes, but now it's way quicker because now that request was intercepted. You can also see this here in this test summary under routes. Here you see your interceptors and you see that it was stubbed so that it uses dummy data. You can also give your intersetters aliases, just as you could use aliases for stubs and a couple of other things as well. And here we could give this an alias of subscribe or whatever you want. And when assigning an alias like this to an intersetter, you can actually also use cywait, another built-in method, to wait for this intersetter. So to wait for this request to be sent and intercepted. Like this, by using that alias name. This step is not really necessary here, but you can add it to ensure that the next instruction will only be executed by Cypress after it observed this HTTP request and after it blocked and stubbed this HTTP request. So by adding this line, we make sure that this check only is executed after the HTTP request was sent, and therefore the test of course still works, but you now also know about this aliasing feature and that this can be used to wait for intercepted HTTP requests. So we learned about intersetters and that we can intercept a request here, and you might be wondering, why did we not use this intersetter logic for the takeaways test here? There we use the dummy database instead of intercepting the request and simulating some takeaway items. And the answer is that these two pages or these two processes work differently. These takeaways are actually rendered on the server. It's this index.jsx file that we tested, and there all this code is executed on the server and the database is hit on the server. So we have no request to intercept here. For the newsletter signup, that's different. For the newsletter signup, we actually have different code where a request is sent from the client to the server. So here we can actually intercept it after the page was loaded. And it's important to understand this. Applications simply can work differently. Some applications might send all requests from the client to the server. Others have certain logic that happens on the server, as it's the case here for this index page. And so now that we did learn how to intercept requests, we can add another test that uses this feature. Here I want to verify that validation errors are displayed when trying to sign up for the newsletter. And with that I mean that if you try to use an email address that exists already, you get an appropriate error message. Now of course we reseed the database before every test run, so we start with a brand new empty testing database. But we can still simulate that we try to sign up with an existing email address by again intercepting the request and returning some dummy data. So in the end, we can of course copy all that code here from the previous test, because I still want to enter an email address and click this button, and I still want to intercept this request, but now I want to return a different response when this request is intercepted. In my backend code that handles the newsletter requests that are sent from the client, I am in the end returning a response that has a message property with an error message if signup fails. That means that here in our interceptor, we also want to return an object with a message property with the error message we want to display on the screen, like email exists already. And we now want to test in this application that this error message is displayed on the screen when receiving such an error response as we're simulating it here. And therefore, of course, we still want to enter data, which theoretically would be valid, but again, we're simulating that it's not. We then click this button, wait for this request to be detected, and then thereafter we're not looking for the success message, but instead for this message, because that's the message our application should be outputting, and that's exactly what we want to test with this test. And therefore, if you now save everything, these tests should both run and should both pass, because indeed here we do see this message. And again, we're using this interceptor concept to avoid the actual HTTP request and still test that our application behaves exactly as it should. So now you know how to intercept requests, and this can be very useful, especially when blocking the request and providing your own response for decoupling your front-end and back-end tests, as we're doing it here. But of course, this application does not just have this front-end. Instead, when signing up here for the newsletter, a request is sent to the back-end, and it actually reaches this newsletter.js file, this newsletter route here, on the backend. Now in this file, the incoming request data gets parsed and ultimately the email address gets stored in the database. That's what happens here on the backend, and we of course might want to test this as well. Now to test this, we could of course simply not intercept this request here and instead test the entire flow, including frontend and backend. So this test could simply test the backend implicitly by not blocking the request. That would be a fine approach. It might even be the approach you prefer, but it would also not be uncommon to decouple these two ends as we're doing it here. And you can therefore also directly test the backend and just the backend. And for that, I'm going to add a new test here, which should successfully create a new contact. And the idea behind this test is to really just test this backend and ignore the frontend. And Cypress can also be used for that. You can use it to directly test your backend APIs to directly send requests to your API endpoints. And you can do this with the CI request method. This method will send a request from right inside your test, so without using the application frontend. And there are different ways of using this method, but in my opinion and experience, the easiest way to use it is to pass an object to request. And then you got various properties for configuring this request. You can add a body, you can determine whether you are submitting a form or if some JSON data should be attached to the request. You can add headers, you can set the request method and also define the request URL. And here, for this scenario, I do want to set the method to post, because that is what my application would be sending to the backend as well, and that is what my backend expects. It expects to get a post request. And the URL here is /newsletter, because this also takes advantage of this base URL, which is set up in the Cypress config. And then the body is an object where I set an email property and set it to any email of my choice. And here we could use test@example.com, though it is important to keep in mind that in this seed test file here, we are actually creating a newsletter signup as some dummy data, so that we could then also create some tests where we test what happens when we try to sign up an existing email address. And here the seeded email address that's inserted in the database right before every test is test2@example.com. So therefore here, where I want to test the success case that a contact is created, we should not use test2@example.com, but just test@example.com. And then here for this request, we also need to set form to true, because my application here would actually send some form data to the backend, and the backend expects to get some form data, and therefore we must configure the request appropriately by setting form to true. If you set this to false, some JSON data is sent instead, but here we set it to true to send our form data. Well, and with that, Cypress goes ahead and sends this request, and we of course probably want to evaluate the response that's being sent back from the server to evaluate whether everything worked as intended. And this can be done by using the then method, about which you already learned in this course. And you learned that the then method can be used to access the subject of the command in front of the then method. So in this case, the subject of the request, and the subject of the request, so the value yielded by the then method after the request, is the response that's returned because of this request. So therefore here we can then evaluate this response. And we can add an expectation with the expect function, and for example expect that this response status code, which is one of the properties response offers. You find a bunch of properties when adding a dot here. Status is one of them. So we can expect that status, for example, is equal to 201, because in my backend code, I am actually setting this status property in the response body to 201 if everything worked. So that's what we can check for here in our test. And with that, if we save this, this test also executes and should also pass, and it does, because this request is now sent successfully. Now you can see here on the right that there is no DOM snapshot visible because we haven't visited any page, we haven't interacted with the frontend at all. Instead here, the idea behind this test really is that we send the request from directly inside the test. And this is another core feature offered by Cypress because this feature is of course amazing for directly testing your API endpoints. So now with the approach covered in the last lecture, you learned about a couple of different strategies that can be used for writing tests that have to deal with network requests. The first strategy is that you simply allow and accept those requests. So you test your website as you would always do it, and you just let the website send requests behind the scenes. Here you just have to be careful that of course on the back end a database might be hit, and you therefore probably want to use a testing database to make sure that you have predictable data in your tests and to make sure that you don't accidentally mess with production data, because you of course don't want your tests to affect your live data, your production data. Now, another strategy for dealing with network requests is to intercept them. You can intercept and spy, which means the request still is passed to the backend. It still does its thing there, but you can still find out whether a request was sent and inspect the request body and actual request response. But you can also stub the request, which simply means that you decide which response should be sent. The request is therefore blocked. It's not sent to the backend, and you have full control over request and response in your test. And last but not least, you also learned that you can trigger and send requests manually from inside your tests, which is amazing for testing API endpoints and decoupling your frontend and backend. And it's of course important to know all these different tools and approaches because different applications and different tests simply require different strategies. Now, this application that we have here is not just about sending requests. Instead, it also features user authentication. Users can log in, and for that, they can, of course, also create an account to begin with. And once logged in, they can, for example, add new key takeaways, which they want to note, and of course, also log out again. And of course, these different flows should also be tested. But dealing with authentication and writing tests for authentication can sound very intimidating and challenging at first, but it actually doesn't have to be. Instead, writing authentication tests turns out to be quite straightforward as well. So here, to dive into authentication, I'll add a new authcy.js file, and in there we add our suite, and in that suite we add our tests like this. And the first test I'm adding here should deal with user signup. So here we want to test that this signup flow works as intended. So what do we have to do for that? Well, if we take a look at this application, signing up means that we need to switch to this /signup page here. So that's the page we want to visit. And then we have to select these different input fields, which we can do with the data-cy attributes. Here it's auth email for the email field, and then auth password for the password field. And then of course, once data has been entered, the form must be submitted by clicking this auth submit button. So therefore, that's what we should do in this test. First of all, visit /signup, and then get access to these different elements, starting with the auth email field, and typing into those elements. Here, for example, test2@example.com. I'm using test2@example.com because in the data I'm seeding, I am already creating a user with an email address of test@example.com. So trying to create a user with that email address would actually fail. Now, you could definitely also write a test for this, but here I want to write a test for a successful authentication attempt or for a successful sign-up attempt, and therefore I'll use test2@example.com, which is an email address that has not been taken yet. Now I'll then copy this and also select auth password. And here you can use any password of your choice. I'll go with test password. Actually, it should be at least 6 characters long because that is what this auth form will expect. Now, just as a side note, you also might want to grab this auth email field here and click on it before typing, because there sometimes can be a bug with this application and Cypress where it fails to type into the first field of the form if you don't click into it first. This normally should not be required, but it makes sure that this test here does not fail unexpectedly due to this bug. But with that, we're entering these values. Now, as always, we can select the submit button with data cy auth submit, and then click this to submit the form. So with that, we should actually do everything we need to do to sign up. But of course, we now also must add an assertion to verify that the sign up process worked as intended. Now for that, let me quickly sign up here to see what changes when I do that. And thereafter, you can see that, for example, the URL changes. We're on /takeaways thereafter. And we can't visit this page if we're not logged in. If I try to visit /takeaways when not logged in, I'm redirected to the login page instead. So if we see /takeaway here, that's a clear indicator that we are logged in. In addition, if you open the browser developer tools and you go to the application tab under storage cookies, you will see that a session cookie was added, and that session cookie should have some value, some random cryptic key. So the existence of a value for this session cookie is another indicator for the sign-up process to have succeeded. And with that new knowledge, we can go back to our test and take a look at the location to access the path name of the page we're currently in after signing up. And here, this should equal /takeaways, as I showed you a couple of seconds ago. Now, besides verifying the URL, we also want to take a look at that cookie. We can do this with the built-in getCookie method. Here, you can enter the name of the cookie you want to inspect, which in this case was __session. And then you can access its value with the special its method. Now, its is also provided by Cypress, like all these methods, and it's actually not limited to cookies. But we haven't used it thus far in this course because its is used to dive into the property of an object yielded by the command in front of its. And getCookie yields a cookie object. Its can then be used to take a closer look at the individual properties of that cookie object. For example, the value property. And I'll show you how to find out which properties exist in just a second. So now with that, we take a look at the value property of the cookie here. And then we can add our expectation and, for example, expect that this should not be empty. So there should be a value for this cookie. If it's empty, that means the cookie is not set, or at least not set to a valid value, and therefore we are not authenticated. But after signing up, we should be authenticated, and that cookie should have a non-empty value. Now, if we would save this, it might pass, but it also might fail if you, for example, created a user with that email address before. So therefore, we should do what we always did. We should add before each and reseed our database with cytask seed database. That's very important. As always, we want to start with a fresh, clean database before every test. And now we can save this and then go to this auth.cy.js file. And this now actually passes, and all the checks pass, all the steps pass, and we therefore do verify that the sign-up process works as intended. Now, one quick note about finding out what's inside this cookie. You can click on all these steps here to pin this snapshot on the right to make sure that it doesn't change, and you can, for example, inspect it. But when you click on an item here, this also has another effect. If you open the developer tools here in this Cypress Studio app, when you click on an item here, more information about this item is output in that console. In this case, for example, more information about this location path name and what it yielded. If I click on Get Cookie, the cookie object is output. And here you see all the properties that could be accessed with its. Here, for example, you see the value property which we're using. So you could, of course, also use the official Cypress documentation to find out what's inside an object, but in my experience, this is the faster and more intuitive and helpful way of quickly looking into certain objects and finding out what's inside of them. And in general, this works with all steps. When you click on them, you find meaningful information about that step and the data it acted on. So that was the sign up process. In this app, we can of course also log in, not just sign up. And therefore, we can add a second test here in this auth.js file, and here check whether the login flow works as expected. For this, we want to visit /login because that is the login page. And then there, again, we want to select all these input fields like we did it in the sign up test because it's the same form we're working on. And we want to enter data, but here, of course, we can't use the data we used in the previous test because there we created a new user and we can't log in with that user in this test because we, of course, reseed the database. We clear the database before the login test. So this user, which we created in the previous test, will be gone. Instead, we should use that user which is created as part of seeding. A user with the email test@example.com and test password as a password. And that's what I'll use here, therefore. Test@example.com and test password as a password. And this user should exist in the database and we should be able to log in with it. Thereafter, we can also copy the 3 remaining steps and paste them here because we want to submit the form, and thereafter, just as before, we should be redirected to /takeaways, and this session cookie should have a non-empty value. So that's the same as before, and we can therefore still do that. Just as a side note, the cookie, of course, also was cleared between those tests, because Cypress enforces test isolation and, for example, clears cookies between tests. So we have to log in again because the login state is cleared after the previous test finished, before this test started, because of this test isolation. Nonetheless, here, after going through all these steps and entering the valid data, we should of course be logged in, and therefore these tests here, these assertions, should pass. So if you save everything, all these tests should again execute and pass, because we are indeed able to log in successfully. So now we got tests for signing up and for logging in. Now when logged in, we can of course also add new takeaways and log out. And we might want to write a test for that as well. And let's start with logging out. For this, in auth.cy.js, we can add a new test, should log out. And here the idea is that we, can successfully log out. Now, since we have this test isolation and the login state of the previous test is lost when this test starts, we have to log in first before we can log out thereafter. So for that, we could copy all these steps, including the assertions, to log in, and then thereafter we can select this logout button by using contains logout. Since the logout button in this app is the only thing that contains the word logout, this will select this logout button. Alternatively, you could of course also use a data-cy selector or anything like that. Here I'll grab my logout button like this and then click on it. This should log us out, and now we just need to verify that we have been logged out, and we can verify that this is the case by copying these 2 assertions. And for example, the path name should be changed to / after logging out, because we are redirected to the starting page when the logout button is clicked. In addition, the session value should now be empty because it should have been cleared by this application when the user logs out. And that would be a valid logout test, even though repeating all that code here for logging in is not ideal. But we'll deal with that in the next seconds. For the moment, let's just save this and see whether all these tests succeed. And they do. And let's now come back to this part here. Because as mentioned, repeating all this login code over and over again is annoying. And it's not just this logout test. We also might want to test whether creating new takeaways works, and for that we also must be logged in. And it's not unreasonable to assume that many of your tests need users to be logged in. And therefore here we have a great example for a custom command that can be created. We can cut the code from this logout test and instead go to commands.js, and there we can add a new command as you learned it before in the course, and this command could be called login. We pass a function as a second argument, and this is the function that will be executed when this custom command is executed. And we paste our code, our login code, into this login function here. So here we have all the steps we need for logging in and for asserting that this worked. And now we got a reusable login command, which we can use anywhere we need to. So we can save this and go back to auth.cy.js. And here in this logout test, we can simply call cy login now. And this will go through all these steps, but it's now way easier and way more convenient for us to repeat these steps in all the tests that need logged in users. Instead of copying and pasting the code, we just have this one convenient command which executes all these steps behind the scenes. And with that, these tests still pass. This all works, but we got this reusable login command now. And that's, as mentioned, a great example for a custom command. So now that we have this reusable login command, we can also use it to add another takeaway test. Because when logged in, we can add new takeaways by clicking this button, which takes us to /takeaways/new. And on this page, we can enter a new takeaway, which then shows up here. And of course, we might want to test this flow as well. And thanks to this new login command, this is super easy to do. Here in the takeaways cy.js file, we can add our new test, should add a new takeaway, sounds like a fitting description. And in there, we now want to call cy login as a first step, because the user must be logged in order to be able to create new takeaways. And then thereafter, we can visit /takeaways/new. This takes us to this new takeaway page. And then here we need to enter all that takeaway data. So for this, if we take a look at this, in this form, we can enter a title for the takeaway with help of this title input, which has this data.cy selector or attribute. Then for the body, it's data.cy body. And ultimately, this form can be submitted with this button that has data.cy equal to create takeaway. So here in this test, we get all these different elements with help of the attribute selector, as we did so often. And we can start with the title input field like this. Click onto it to make sure that we don't run into this bug where this is for some reason treated as being disabled by Cypress. And thereafter we can type into it and, for example, give this a title of test title 1. And I deliberately write this as one word. You will soon see why. But that's the test title I want to use. Then thereafter we can select the body field and give this a text of test body 1, also deliberately written like this. And then thereafter get access to the button, the create takeaway button, and this button should then be clicked to submit the form. So this would now submit the form, and it would send a request to the backend, and there a new takeaway would be added to the database. And we could definitely run this test and then also add an assertion that checks that this new item was added here. We could do that. But here I'd again like to decouple frontend and backend, also simply to practice this again. So I'd like to intercept this request, which is sent to the backend, and make sure that it's not being sent there, to make sure that the backend isn't hit and the database therefore isn't changed. Of course, we could do this since we have a testing database, but I'd like to avoid it here. And for this, we can, of course, again, use cy-intercept to create a new interceptor, and intercept post requests to /takeaways/new, because that is the path our data would be sent to. And we have to add an asterisk since this application again adds a bunch of query parameters thereafter, which also have to be considered here. And then I want to make sure that the request is blocked, so we have to return some dummy data. And here I'll just return the text success. Because here I don't really care about the dummy data. Instead here I just want to make sure that the request is blocked. And then in my assertion, I want to verify that this request that would have been sent, or that was sent but that was blocked, does have the right data attached to it. So the data entered into this form. To do that, we have to give this interceptor an alias, like for example, create takeaway. Of course, the alias is up to you though. And then as you learned, we can wait for it with this wait method. So here we wait for create takeaway. And I'm doing this here because when you use wait, you can do something which we haven't done before. You can take a closer look at this intercepted request and add an assertion related to this request. Either an assertion that looks at the request itself or an assertion that looks at the response. For that, you can chain its here to again take a closer look at one specific property of this intercepted request. Because wait will actually give you this intercepted request when used on an interceptor, as we're doing it here, thanks to this alias. So here we can then take a look at a couple of fields, and thankfully I'm getting some autocompletion here, so that we can, for example, take a look at the request, and then there actually at the body. Now I'm not getting any autocompletion for body here, but I'll again show you how you can see which data is available in just a second. This here will give us access to the request body, and with that we can then chain our assertion with should, and here I want to match this body against a regular expression. Now to understand this, let me quickly add a new takeaway here and open the network tab in the browser DevTools. You will see that if I now send a request here, this request appears here in the DevTools, and it's actually this request which is being sent here, a post request to takeaways/new as mentioned. And if you take a look at the payload, you see the data that's attached to this request. And here it looks quite formatted, but it's worth pointing out that this is form data. And if you click on View Source to see the original formatting as it would be attached to the request, then it would look like this. This is the actual request body. It's a long string that looks like this. And I want to match this request body. I want to take a look at this request body and use a regular expression for matching. And that's what this match assertion allows me to do. So here I want to find these keywords in my request body, and that's why I wrote them like this, to keep the regular expression simple and straightforward, because now I can look for test title, then any amount of characters after it, and then test body 1. So this should now make sure that our request body indeed contains these words. And with that, if we save everything and we switch to this takeaways CY.js file again, this second test here should pass, but it fails to find create takeaway because I have a typo here. I need this closing double quote. So now if I save this test now passes, and you can again click on an item to learn more about it. Here, for example, on wait. And if you do that, you can open the DevTools, and there in the console, you can dive into the object that's yielded by wait. And here you have all the data that could be accessed, like for example, request body, which is what we accessed here with its. But we could have had a look at all kinds of data here, as you see. And this was the request body, which we matched against our regular expression. And that's why this test also passes, because all our assertions were successful. And that's it now for this course section. In this section, you learned how to deal with network requests when writing Cypress tests. You learned that you, for example, can intercept and block them if you want to return some dummy data and have full control over those requests and their responses. But you can also manually trigger them to test your API endpoints, for example. Of course, you can also just allow them and not do anything with them, but in that case, of course, a database might be hit, and therefore you might want to use a test database to make sure that you have predictable testing data, isolated tests when reseeding that database before every test, as we did it in this course section, and of course also to avoid that you accidentally break your production data, because you never want your tests to mess with your actual application data. Last but not least, we also had a look at authentication, and you saw that there actually isn't anything special to it when it comes to testing user authentication, but that you of course might want to consider creating a custom login command to have an easy and quick way of reusing that authentication logic between your tests, as many tests might rely on users being authenticated. And for that, it's of course important to keep in mind that Cypress ensures test isolation, so if you log in one test, you're still logged out in the next test thereafter. That's why you might want such a reusable login command. Congratulations, you did it. You finished this course, and you therefore now should have a solid understanding of all these core Cypress concepts. Therefore, you're now ready to dive deeper and build up on that foundation. And of course, that also means that you should now start using Cypress in your own projects, including your demo and dummy projects, because practice makes perfect, and otherwise you're soon going to forget what you learned in this course. So instead, apply it to your projects, start using Cypress there, and of course this also means that at some point of time you'll probably face a problem or some assertion you want to add where you're not sure how to solve it or how to add that specific assertion you want. You will definitely reach that point where you need to add something or need to do something that was not covered in this exact way in this course here. And therefore, also as a next step, you should also explore the official Cypress documentation. It's a great place to revisit all these core concepts with the various guides and explanations you find there. It's also a great place to dive deeper into these concepts and learn more about them. You can, for example, also explore component testing there, which is another feature offered by Cypress. This course, of course, was about end-to-end testing. And here in the official documentation, you can, for example, also learn how to use various cloud features offered by Cypress, or how to integrate Cypress in your CI/CD pipeline, for example, with GitHub Actions. Most importantly, on this site, you also find the API documentation, where you can learn about all these Cypress methods, how these methods can maybe be used in different ways, how they can be configured, which options you have, and you can simply dive deeper into Cypress and all these core methods. And that's of course also something you should do, especially when facing challenges in your own projects. But besides the official documentation, there also is one other resource I want to point you at, and that's the Cypress Real World app. When searching for Cypress Real World app, you'll find a GitHub repository managed by the Cypress team that includes a demo application. As we had it multiple times throughout this course, though this is a bit of a more complex application, and this application uses Cypress for testing. And you can of course explore this application and explore the Cypress configuration you find here and the Cypress tests you find here to see more use cases, more examples, and more Cypress features. Here you'll find many features about which you'll learn in this course, but you'll also find some new features, some new ways of writing assertions, and you might find certain approaches or solutions to problems in this demo application that also help you in your own applications. And therefore, with this course and the knowledge you gain from this course applied to your own projects, as well as all these other extra resources, you're well prepared to learn more about Cypress and become a real Cypress master.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.